manage. Otherwise you can use the flashlights of your phone for the time being, है ना. That is how you will use the batteries all together. Done. Chalo. Done है? Okay. Hi online. Online, am I audible? Is it going good? I mean the class right now, is it good? So online, there will be a topic today, energy and this fuel, right? Then we see a topic, subtopic, battery. So right now, currently we are running on the battery, है ना? So I hope if you have joined us back, there was a power cut. Okay? We are starting up again. So we have some batteries, functional as of now. And when I say as of now, I don't know until when. Okay? Chalo. Listed. Public. चलो अभी लिंक पब्लिक कर दो क्योंकि बच्चों को नहीं पता अभी. So what we are doing, we started the topic. First we saw all the subtopics of the science and tech, right? I told you we will be dividing all the subtopics in 3 lectures. Today we will be talking about the particle physics, quantum technology, nanotechnology, fuel tech, nuclear tech, AI, robotech, and some miscellaneous technologies today. Okay? Given the fact the thing should functional, the thing should be all right. So we started with the first topic of particle physics. I told you that whatsoever is a material, this material is broken into some molecules, some compounds, some molecules. Those molecules have some atoms. Now when you will see those atoms very closely, those atoms are further subdivided into 3 things: proton, neutron, and electron. So there will be atom. This atom will have some nucleus, and around this nucleus the electron will be revolving. Done. Now this nucleus comprises of 2 things. First is proton and second is neutron, and these are the electrons revolving around the nucleus. Now what I am saying, what standard model of particle physics says, that if I talk about this particle, this atom, there should be some matter which is coming in this atom. Apart from this matter, there should be some binding forces which is binding them together. And apart from that, there is some mass of this matter, mass provided to this matter. So what the standard model of particle physics says, that is what we discussed, that beta, when I talk about this matter is imparted from the fermions. These fermions are nothing but quarks and leptons. There are 6 types of quarks. Those quarks are nothing but the elementary particle. They combine and then they make the proton or the neutron. So in this standard model of particle physics, proton and neutron are not the elementary, they are not the basic, because they can be broken further into quarks. A proton can be broken further, a neutron can be broken further, hence they are not elementary. So what I am saying, these 6 type of quarks, 3 of them will make proton and 3 of them will combine and will make neutron. Itna fundamental hai. And all of them, these 6 particles, all of them are particles. And when I say particles, they have both nature of, they have especially the nature of wave. We'll see. Abhi itni baat samajh mein aayi. Then fermions also include the leptons. Again the leptons are of 6 types. And these leptons are nothing but electron or neutrino, not neutron, neutrino. Now what is happening, there are 3 types or 3 flavors of electron. This will oscillate into this flavor, this will oscillate into this flavor. Three different flavors. Names are not important for you. Three different flavors. Similarly, neutrinos have three different flavors. See, nothing is combining to make the electron. These are changing their types. These are changing their types. Nothing is combining to make the electron, neutrinos, sorry. This is changing their types. But when it comes to proton, these three things, they combine to make one proton. And these three combine to make one neutron. Okay. I'm playing one video in front of you. See, can you see these three things going together? These three things are combining to make proton or neutron. And these three are nothing but quarks. You can open it in your phone, the video, okay, for the time being. These three things are nothing but quarks. So what is elementary here? Elementaries are these three type of quarks. This is nothing but neutron, proton, and these are electrons. Okay, and this combined is nothing but atom, and this is nothing but nucleus. Okay, these atoms will come together to make molecule. Molecule will come together to make material. See this. This is material. This shirt is material. When I zoom it, this is the compound. In this compound, this is the atom. Again, these are the electrons. So nucleus mein there are two things, proton and neutron. When you will now zoom out the proton, there will be again three quarks available. Three quarks in a proton. Three quarks, okay? Making one single proton. Up see, these are nothing but the flavors. Not important, names not important, but I am reading it for you. I am reading it for you. For example, you have up quark, down quark. Then you have strange quark. Then you have bottom quark. Then here you have charm quark. Then again there is a top quark. These are six quarks. These six are nothing but elementary particles. Three of them will combine together to make proton, and three of them will combine together to make neutron. Now see this. This is electron, electron neutrino, muon neutrino, tau neutrino. These three are nothing but the flavors of neutrino. They don't combine to make neutrino. They change into one another. They change the form. So these three are flavors of neutrino. Similarly, these are three, tau, muon, and electron. These three are flavors of electron. Do I make sense? Itni baat clear hui? Okay. Now three of them will combine, or let's say there is nothing but a same lab combine कर रहे हैं उनको, ठीक है? Quark, ठीक है? So the flavors forms क्या बोला जाता है? Strange quark, up quark, down quark, top quark, not important for you, है ना? You just understand one thing. You just understand the basic concepts. ठीक है? चलो. So what we have done so far, we have written this in the document. Done. So proton is also known by the name atomic number. So the number of protons in the nucleus will define the atomic number. And atomic mass is nothing but proton plus neutron. Done. Done. Now what you will do in the same column, beta दिखाना, here only horizontal बनाइए इसको, here only you will write these three things: isotopes, isotones, isobars. Done. I am dictating, you will write. First write isotope. क्या होता है isotope? Same number of atomic number or protons. इधर लिखना है, कहीं भी लिख लीजिए, इसी बॉक्स में लिखना है, आप कहीं भी लिख लीजिए बॉक्स में. आइसोटोप इज सेम नंबर ऑफ atomic number. What is the atomic number? Protons, number of protons. ठीक है, so in bracket you can write number of protons. If the atomic number is same, it is nothing but isotope. Then you write isobar. Isobar is same atomic mass, same atomic mass. See, whenever the atomic number remains the same on the board, very important, whenever the atomic number remains the same, atomic number is number of protons, the compound of the atom behaves in the same fashion, the chemical properties remain the same. You might have heard about the isotopes of carbon, isotopes of carbon. So the chemical properties of those isotopes, you might have heard about fluorines and all those isotopes, C14, C16, है ना, isotopes of carbon. So in isotopes chemical property remains same. So in isotopes के bracket में please write chemical properties remains same. Isotopes in bracket you write chemical properties remains same. Done. So isotones में chemical properties changes, please write isotones में, in isotones please write chemical property changes. Sorry, isobar, सेकंड हमने isobar लिखा है ना, हाँ isobar, सॉरी, isobar में chemical property changes. Isotone, so first is isotope. See how I remember this on the board, please देख लो, तुम्हें याद रहेगा फिर बोलोगे नहीं. How I remember this, TOP is top, P आ रहा है, P is proton, so same number of protons. Isotone is nothing but neutron, so N neutron, same number of neutrons. Isobar, B is both, both में क्या लेंगे हम, proton and neutron. Done. That is how you have to remember this. And these two are important for today's class, isotope and isobar. Isotope and isobar. Done. Isotone is nothing but same number of neutrons. Same number of neutrons is isotone. N आया तो neutron, P आया proton, bar आया both आया, both proton and neutron. Done. याद रहेगा, ठीक है. Now on the board I have briefed you sufficiently well now for the matter, for the forces and for the mass, but इससे हमारा काम नहीं चलेगा. We have to add some element of physics into it, and when I say some element of physics, see, very crudely I have explained you what do I mean by matter, the forces binding it and the mass in it. This I have explained you, right? Matter is coming from the fermions, the force within this matter is coming from the this photons, gluons, bosons. Done. And then mass is coming from the Higgs field or Higgs boson. Okay. But right now the things are not that simple, है ना? We have to understand the these particles with three properties, and those three properties to understand any of the particle in physics is charge, mass, spin. On the board now I want you to increase your attention so that you don't remember anything. If a particle has a charge, don't you think that particle will be involved in the electromagnetic forces, electricity related forces, positive and negative charge, attract or repel, electromagnetic force. So if the charge is coming into the picture, the electromagnetic force will come into the picture. If there is a mass now, in standard physics, if there is a mass in standard physics, first of all, this mass will be coming from the Higgs field, but this mass will enable the matter to be blocked. Understand? If mass is there, this will fall down, this will be attracted under the model of gravity, and at the same time it will be blocked by my earth. रुक गया ना? But there are some particles which do not have any mass. For example, photons, gluons. Okay. They don't have mass, they don't even interact at all. So we have to understand this. Then third is spin. Ab spin is a very complex phenomena. Spin says that the particle keeps on rotating like this, or else it may keep on changing the forms. आपको ज़्यादा दिमाग नहीं लगाना है इस पे. Don't take it very close to your heart. I just want you to focus upon two things: charge, mass. Spin is something which either you will do the rectification or थोड़ा बहुत शायद quantum में समझ में आ जाए. What do I mean by spin? Some of it I have tried to explain you with the flavors. But spin पे ज़्यादा दिमाग नहीं देना है. It is all about the core physics वाला part, not concern of the class today. ठीक है? So these three things, C, M, S. So what we will be doing for every particle, we will be concerned about C, charge, mass, and spin. Let's decode the spin first. Charge, mass, and spin. C, M, S. I am saying for all the fermions, what the spin? The spin is half, or fractions. You remember, the spin is in fractions. ठीक है, half होती है spin. When I talk about the forces have the integer spin, generally 1. Don't worry, नहीं, हमें बस इतना पता करना है, ये half spin है, ये integer spin है. And when I talk about the Higgs boson, the spin of the Higgs boson is 0. It have 0 spin. ठीक है? What you will do now? आपके नोट्स में दिखाइए क्या फॉर्मेट है. ठीक है? Matter. Okay. Under matter, make a arrow and write fermions. Under matter, make a arrow and write fermions. Fermions. In bracket you write half spin, comma, half spin, comma, mass. Mass is there in fermions. In all the particles, mass is there. Except 3 particles, ठीक है, which we'll see. Although those 3 particles also have the mass, but बहुत minor है. कितना हो गया? Now, come on the quarks. Proton, what is the charge? Charge is positive. Please write proton. Charge is positive. Q. Charge is denoted by Q. Neutron, the charge is 0. The charge is 0. The charge is 0. If I now ask you, okay. If I now ask you, what force could apply on this? What will your answer? I told you there are 3 types of forces, right? There are 3 types of forces. First force is strong nuclear. So this is around the nucleus force. Second is electromagnetic force, and third is weak nuclear force. So this is outside the nucleus also, and this almost keep on applying on every particle. Weak nuclear force. These are the three types of forces. If I now ask you, these particles can feel what type of forces, what will be your answer? All three. Strong nuclear force, weak तो सब पे लगता ही है, then electromagnetic force between proton and electron. ठीक है, so please write, make an arrow and write. अच्छा दिखाइए, नोट दिखाइए कैसे. Quarks, okay. Under quarks, please write quarks. Divide that into two: proton, neutron. Positive charge, zero charge. Then make an arrow and write fields. दोनों fields strong nuclear force, comma electromagnetic. So you will write EM, electromagnetic force. If you don't know, EM is electromagnetic, ऊपर कहीं लिख लीजिए EM is equals to electromagnetic. ठीक है, if you don't know, comma weak nuclear force. Done. Okay. Leptons, 6 types, and they are the building blocks of electron and neutron. What is the charge of electron? Q charge is negative. What is the charge of neutrino? 0. This is not neutron, this is neutrino. Please write this in bracket. So leptons are of 6 type, electron charge is negative, and neutrino charge is 0. I am asking you the conceptual question now. Will the strong nuclear force will be active on the electron? It is outside the nucleus. So strong nuclear force तो नहीं होगा. Electromagnetic force, why? Because of the charge. And weak तो सब पे लगता ही है, तो इस पे लगेगा. ठीक है, please write electromagnetic force, comma weak nuclear force. Why we are seeing it weak? Because it is outside the nucleus. ठीक है, weak nuclear force. Now neutrino. Will the strong nuclear force will be applied on the neutrino? सोच के बोला, and this is something which I am expecting also in the examination. Which of the following forces will be applied on the neutrinos? Will the strong nuclear force will be applied on the neutrinos? It is outside the nucleus. Second, will the electromagnetic force will be applied on neutrinos? Why no? Charge नहीं है, no charge, so no electromagnetic force. Will the weak nuclear force will be applied? Yes, weak is applicable on all the particles. So it will face some weak nuclear force. It will have only, it will have some weak nuclear force. So either you can write strong nuclear force and make a cross mark. Either you can write EM force, make a cross mark, and then strong nuclear force, make a cross mark. ठीक है, not प्रोटॉन से अटैच्ड है बस इसलिए. ठीक है, इंडिविजुअल न्यूट्रॉन पे आप बात करोगे तो EM नहीं लगेगा, है ना, चार्ज नहीं है. व्हाट इज सेइंग, न्यूट्रॉन में इलेक्ट्रोमैग्नेटिक फोर्स है. मैं कह रहा हूँ न्यूक्लियस की बात कर रहे हैं हम यहाँ पे, जब कर रहे हैं ना न्यूक्लियस की बात कर रहे हैं. ठीक है, चलो नाउ इधर दिखाइए. ये बाइंडिंग फोर्सेस. प्लीज राइट फोर्सेस में मेक एरो एंड राइट बोसोन्स. See, these were known by the name fermions. These are known by the name bosons. All of them are form of bosons. Photons, gluons, W and Z bosons. 1 particle, 2 particle, 3 particle, 4 particle. See, here we have seen 12 particles, है ना? Here we are seeing another 4 particles, but these particles, bosons, these are force providing or binding particles. They help the particles to bind together. First is photon. So photon में what we'll write? We'll write the charge, mass and spin. What is the charge on the photon? Zero charge. What is the mass of the photon? No mass. And what is the spin of the photon? It is integer. Yeah, all these forces have the integer spin. Spin हमने देख लिया. These are half spin, fractional spin. These are the integer spin. Higgs boson has zero spin. ठीक है. स्पिन में सिर्फ इतना इंपॉर्टेंट है आपके लिए, इससे ज्यादा कुछ नहीं, कुछ नहीं. ठीक है, इतना ही इंपॉर्टेंट है बस. अब दिस इज नथिंग बट चार्ज, दिस इज मास एंड दिस इज अच्छा, on the board. Generally, this model do not explain gravity. And when we talk about the gravity on the board beta, and we are going into the core physics now, generally this model do not explain gravity, but gravity plays a very important role when you do the astronomy. Black holes, देखो सुना होगा ना, बहुत ज्यादा ग्रेविटी है उसमें, बहुत ज्यादा मास है तो बहुत ज्यादा सब कुछ पुल कर लेता है ना. तो ग्रेविटी प्लेज अ वेरी बिग रोल इन द this astronomy. Right now also in the classical physics, gravity is the most important force. There is a what I can say, saying that out of this model there is a missing particle not proved yet. He was asking a doubt in the break. That missing particle is termed as the name of graviton, not discovered yet. We have discovered the Higgs boson, but the here is saying that that particle may assign the gravity wala force to all of them, and that particle is termed to be graviton. Not important for you. For you, only these 17 particles are important from the standard model of particle physics point of view. But is the gravity applying on all of them? We know all of the particles is under the gravity. So gravity is applying, and gravity applies on. See, if I am writing a formula, I don't know how many of you read about this. G is equals to, एक जना बोलो. This is proportional. ऐसे I will make it more simple. R square and directly proportional to mass of the object. This is another mass not important to us, and this is gravitational constant. What I'm saying, gravitational force is directly proportional to mass of the object. Only this is important for us. ये भूल जाओ, ठीक है. Gravitational force is proportional to, and this is I am talking in the classical physics, whatever you see in your 11th, 12th and 9th and 10th class, classical physics. Gravity is proportional to mass of the object. So if the object has the mass, gravitational force will be applied. So if I want to see this, whether the gravitational force is applied on these particles or not, how you will answer it? Mass. So if the particle has the mass, gravitational force will be applied. Now you tell me, fermions have the mass or not? All the fermions have the mass and have the spin, which is fractional. Let me tell you, proton has the mass, neutron has the mass, electron has the mass. The ideology is neutrinos also have the mass, but that mass is not proved with the standard physics model. But in experiments, we have identified that the neutrinos have the mass which is very, very, very small mass. Very small mass. ठीक है, मेरी बात समझ में आ रही है? मास है, but बहुत छोटा है. Now I'm asking a straight question. Will the gravitational force will be applied on proton, neutron, electron, neutrinos? Yes. ठीक है. So neutrinos will, apart from this, will also have gravitational force acting on them, because they have very tiny mass, right? So they generally interact with the gravitational waves, which we will see later, है ना. चलो, just a passing reference, not important, मैं लिखवाऊंगा जहाँ भी लिखवाना है. अब वापस आ जाते हैं स्टैंडर्ड मॉडल ऑफ पार्टिकल फिजिक्स पे. Photons don't have the charge, don't have the mass, but they have the spin, and they are responsible for, please write, responsible for electromagnetic force. किस पे लगेगा? on charged particles. Photons are responsible for the electromagnetic force and the force will be on charged particles. Arey, this is the most complex part. See, I would have taken in the lecture 3, but then you would have skipped it. ठीक है, so I am taking it in the lecture 1 because I know the questions are coming from this. At least 3-4 क्वेश्चन आपको आज के लेक्चर से मिलेंगे ही मिलेंगे 100%. ठीक है, so heavy part we are taking in the lecture number 1, then we will take further. Now although I will try my best that things look very simple to you, है ना, बस समझते जाओ. Gluons. When I talk about gluons, what is the charge? Charge is 0, mass is 0, spin is 1. Charge is 0, mass is 0, spin is 1. You have to remember this in the same order. CMS. Charge is 0, spin is 0, mass is, sorry, charge is 0, mass is 0, spin is 1. And these gluons, please write, are responsible for strong nuclear force. Strong nuclear force. ठीक है, अब this strong nuclear force, if I ask you now, which has the higher range on the board? See, these will be the statements in your questions. Don't worry, यही मिलेगा क्योंकि यही concept है. If I ask you, electromagnetic force has a shorter range than strong nuclear force. Think and tell. Electromagnetic force has a shorter range than strong nuclear force. Just see this. See this. I told you this strong nuclear force is just applying around the nucleus. But electromagnetic force with this to this electron. And not only this electron, this proton is interacting with the electrons of the other atoms also through the electromagnetic force. Although weak, distance increases, force becomes weak, but force is there. So what I am saying, electromagnetic force has a higher distance. And तुम्हें क्या याद रखना? What you have to remember is strong nuclear force are very short range forces, just around the nucleus. Okay, please write this, comma, very short range force. In bracket you write around nucleus, very short range around nucleus. Around nucleus. Then you write W and Z bosons. There is charge, there is mass, and spin is 1. There is charge, there is mass, the spin is 1. That is why these bosons are interacting with everything and providing force to everything. But the force they are providing is weak nuclear force. Please write, responsible for, both of them are responsible for weak nuclear forces. Then weak nuclear forces में make a arrow. अब weak nuclear forces कहाँ apply होते हैं? Weak nuclear forces, make a arrow, applies almost to and between all the fermions. Almost to and between all the fermions. So it will be here also weak है. In all the particles, subatomic particles, weak nuclear force is there. ठीक है, I am giving you just 10 seconds. Please digest, just revise. Please revise. Sorry, fermions beta, ये leptons and quarks. Just 10 seconds. Please do not talk. Please do not talk. Ask me whatever you want to ask. I will explain. हाँ, बस इतना बहुत है कि इसमें चार्ज है, इसमें मास है, और कुछ नहीं. हाँ, सॉरी, हाँ, बोसोन्स इन सारे फोर्सेस को, if a question is coming on the bosons may there are four things for you, four particles, and those four particles are photons, then gluons, then W and Z bosons. Bosons have four particles: photons, electromagnetic charge, this gluons, strong nuclear force, W and Z bosons, weak nuclear force. बेटा न्यूट्रॉन सिंस इज द पार्ट ऑफ न्यूक्लियस, प्रोटॉन के साथ है ना वो, इलेक्ट्रोमैग्नेटिक फोर्स इज नॉट अप्लाइड ऑन द न्यूट्रॉन्स, चार्ज ही नहीं है उसके पास. व्हाट आई एम सेइंग, न्यूक्लियस पे लग रहा है. व्हेनेवर आई एम सेइंग दिस कि these quarks are experiencing three types of forces, I mean combinedly these are experiencing these type of forces. आप अगर इंडिविजुअली न्यूट्रॉन देखोगे तो उस पे ईएम फोर्स नहीं लगेगा, बट न्यूक्लियस पे लग रहा है, और न्यूट्रॉन इज अ पार्ट ऑफ न्यूक्लियस. आप ऐसे देखो उसको, ठीक है. हाँ, photons are particles which is providing this force. हाँ ठीक है. हाँ सॉरी, कोई फर्क नहीं पड़ता. अभी रुक जाओ, ठीक है. दैट वी विल सी इन द आईसीटी. एनीथिंग एल्स? Exactly, I answered. If you see individually neutrons, they will not be applied. But if I talk about nucleus, it will be applied. ठीक है. No, obviously no charge. Conceptually we have seen nothing. ठीक है. अब let's see the mass on the board. Now see, for example, this is Higgs field. The entire screen is Higgs field. If any particle is coming into this Higgs field, there is another particle roaming around, and the name of this particle is Higgs boson. If let's say this quark comes in this Higgs field, this Higgs field is full of these Higgs boson. So what this boson will do? This boson will impart the mass to this whatever is the particle. ठीक है. So all the fermions responsible for the matter, these fermions will gain the mass from the Higgs boson when they are interacting with the Higgs boson in the Higgs field. Show me your notes. Please write mass, make an arrow and write Higgs field. So I will dictate one line for the Higgs field. Please write Higgs field. Higgs field present almost everywhere, including vacuum. Higgs field present almost everywhere including vacuum. This vacuum is important word, है ना. For example, in vacuum, if you will measure this, see on the board, in vacuum if you will measure this, the weight will be same na in vacuum. That means vacuum में there is Higgs boson. Okay, now please write Higgs boson. Please write particles imparting mass to the matter. Particles imparting mass to the matter. Imparting mass to the matter. Can I make the statement now on the board? Can I make the statement? Neutrinos do not interact with the Higgs boson. Neutrinos do not interact with the Higgs boson. क्या डाउट आ रहा है इसमें? फॉल्स है ना. देयर इज अ मास, तो इट हैज टू इंटरेक्ट. इफ आई मेक द स्टेटमेंट photons do not interact with the Higgs boson, photons do not interact with the Higgs boson, true. Photons don't have any mass, so they don't interact with the Higgs boson. Do I make sense? ठीक है. चलो, अब what happened? I told you about graviton, right? It is a theoretical particle, not discovered yet. So until 2012, if I am not wrong, this Higgs boson was also a theoretical particle known by the name God particle. There might be some particle existing which is imparting mass to the matter. ठीक है. Now what happened? I will show you one video first. See this video. Don't read whatever is written, just see the video. What is happening between the magnets? What is happening between the magnets? When I'm keeping that particular, what I can say, the ball starts rotating, and the speeds keep on increasing. If in this scenario, if two balls are striking together, what will happen? Collapse. I will explain you with another example, and on the board, I make it very crude. On the board, let's say this is one atom, car 1. In this car, these are nothing but the components of the car. These are nothing but the components of the car. This is another car traveling in this direction. There will be, let's say, these components of the car. Chair hai, steering hai, all those things. Okay, components of the car. If I make them rotate at very big speed, and if I make them collide, what will happen? What will happen? These particles or these components will ooze out. These particles will ooze out. Take this way. In car, if you are seeing from outside, if I ask you whether the car has the steering or not, आपका आंसर क्या होगा? सर नहीं पता. Maybe the steering is available, maybe the steering is not available. It may be the case. But when I am colliding them, and if the steering is coming out of this car, out of the accident, what will be your answer? The steering do exist. That is how the Higgs boson has been identified. Two atoms at very good speed in the particle accelerator. This is the word which you will see in the science and tech. Two atoms in the particle accelerators are accelerated towards each other at very high speed, and when they collide, the subatomic particles, they ooze out, similar to this. And when they ooze out, you try to detect whether the Higgs boson is there or not. If the Higgs boson is there, I will say Higgs boson is nothing but the another elementary particle. मेरी बात समझ में आई? So there is a concept, there is a term with the name particle accelerator. So what happened in a at a place in France at CERN, CERN, okay, there is a equipment known with the name of Large Hadron Collider. So they did the experiment. They collided the particles at a very high speed. कि अगर बोसोन है तो दिख जाएगा. But the ideology was that this God particle or this Higgs boson is very short-lived, very minute fractions of seconds. You know? So then they made the technology more advanced to identify it. But finally they were successful. They identified the Higgs boson particle in year, if I am not wrong, 2012 only. 2012 only. ठीक है. Particle accelerate बहुत crudely समझ में आया क्या होता है ना? Particle accelerator is nothing but you are accelerating the particles. The experiment done was at CERN in France, and the this equipment was Large Hadron Collider. You are colliding the things. Done. So what you will do now? Okay, so let's understand the Higgs boson now. Some information about the Higgs boson. Higgs boson में अभी हमने क्या लिखा है? ठीक है, particles imparting mass to the matter. So this is also known by the name God particle, and this itself has some mass, which is nothing but 133 times of mass of proton. Not important, you can just take mass hai. Charge, there is no charge in the God particle, and when I say spin, the spin is 0. This we have discussed, and this allot mass to fundamental particles or the matter. Done. अब Large Hadron Collider समझ में आया क्या हुआ? Particles are accelerating within a machine in a circular fashion. I showed you the video, right? In that video only. So the subatomic particle will ooze out when the things are colliding. So this is nothing but a particle accelerator. The length is 27 km long. This discovered Higgs boson in 2012. So the particles were oozing out. You told sir this is a steering. So steering was available. Hence the Higgs boson particle oozed out. So you are able to tell sir Higgs boson is available in the atom. That is how the Higgs boson was discovered. Made by a body or the organization named CERN. sun will see again in www dot or in ICT, ठीक है. In this body only the www dot देखा ना website के आगे, so that was invented here only. So it is located at, no sorry, not in France, it is in Geneva, Switzerland. Done. So sun is a body. The name of the body is European Organization for Nuclear Research, located in Geneva, Switzerland. 1954 में it was established. It has 23 members, mostly from EU. I want to ask you the question, if you have done your IR, थोड़ा बहुत भी, is India a member of sun? India is not a member. India is an associate member, not a full member. So when I see the members of sun, India is not a member of it. India is a associate member. Very important information. See, if you are not focusing upon India, वहाँ पे एक statement तुम्हें मिलेगा whether the India is member. So India is not a complete member. India is a associate member. That we can participate in some of the activities, but we are not a full contributor. Funds वगैरह ये सब नहीं, ठीक है. सेमिनार है तो जाके बैठ जाओ, वैसा है ना. So until here you write, you take your notes फटाफट से. Okay, you have this Higgs boson. Please write इधर नीचे particle accelerators वाले में लिख लीजिए. Higgs boson का there is another column. Please write got particle. Mass में either you can tick, or if you want to write this, although not important from my perspective, there is a mass in Higgs boson. That is it. Mass, just tick. Charge 0, no charge. Instead of this you can write this 0. Spin, I have already told you, 0 spin, no spin is there. And this allot mass to the fundamental particles when they are interacting with Higgs boson in the Higgs field. Large Hadron Collider. This is a particle accelerator. This accelerates the particles so that they collide with each other. 27 kilometer long. This discovered Higgs boson in 2012. This discovered Higgs boson in 2012. ठीक है. Made by sun, CERN, sun, the body. And since sun is also located at Geneva, Switzerland, the Large Hadron Collider, this machine is also located at sun. Sun, European Organization for Nuclear Research, the complete name, full form of sun is European Organization for Nuclear Research. It is an European organization. So India is not a member. Located in Geneva, Switzerland. 1954 में बना था. 23 members from EU and Israel is also a member, although not important for you. But you write 23 members from EU. Then you write India is an associate member. Associate member. So we are not party to the decision making, funding, experiments. We are just party that if there is some conference, anything, or the report is out, you can be a part of it. Okay, association. Now, again, now the things will be factual quite. Okay. See, we have another upgradation to Large Hadron Collider, and that upgradation is nothing but Future Circular Collider, FCC. So what the sun is planning on the board, देख लो पहले. What is sun is planning? Sun is planning to make 100 kilometer radius का 100 kilometer. अच्छा, by the way, this larger hadron collider is also a circular collider. ठीक है. So they are making a 100 kilometer का circular collider. at sun, and it will be ready by 2040. It will be ready by 2040, right? So more powerful, upgraded, future circular collider. Not that important. Not that important. Just part of current affairs, so I cover. Okay. See, on the board. These collisions, these collisions can be either linear. I told you two cars moving on the, let's say, road collided, linear. This could be out of circular. So car moving in the circular tracks collided. Then there is another which is nothing but circular ka upgraded spiral, like this. Okay? So it keeps on rotating like this, then the radius starts diminishing. Radius kam hota jata hai. Why? Anyone from the engineering background, why we are decreasing the radius? What will the help? If the radius is decreasing, na, speed will keep on increasing. Radius kam karte ja rahe ho, and the particle is on the spiral, the speed will keep on increasing. Okay? Whenever this is the case, this is known as particle accelerator only, but the name is synchrotrons. Done? So please write synchrotrons. Synchrotrons. Please write particle accelerator. Particle accelerator in circular spiral form. In circular spiral form. Now we have another particle accelerator with the name HEPS. HEPS is high energy proton source. And if the UPSC will ask, UPSC will directly ask you this recently seen in news, maybe the initiative of the country or maybe related to what. So this is nothing but a particle accelerator. High energy proton source. Please write made by China. HEPS, high energy proton source. It is sourcing what? Protons. So made by China. Made by China. Secondly, right. Particle accelerator particle accelerator which accelerates particles like electrons to generate X-rays. See on the board. X-rays. I will explain on the board. समझ लो, बहुत आसान चीज है अगर समझ के करोगे, वरना रट्टे मारोगे. On the board. This is an electron. So I am saying this is a car. Electron. This car will have some particles. Electron will be made, let's say electron will be in some form, will be binded by some other particles. Done. This car. So what is happening? You are accelerating this, and then when this car is colliding, you are just capturing what? You are capturing high energy photons. And these high energy photons are nothing but source of electromagnetic radiations. And these electromagnetic radiations, when we will see in the ICT, believe me, can be of any wavelength. Certain wavelength of these, board पे देखो, these photons, ऐसे समझो, these photons, भूल जाओ इसको, ऐसे देखो, these photons can be of low energy, बहुत तेज भाग के निकला, can be of can be of low energy, बहुत धीरे धीरे भाग के चल के निकला, ठीक है, can be of high energy. So whenever the photon is in the high energy, this will be converted into some X-rays and other types of rays. And whenever it is a medium to low energy, this will make light, whatever you see right now. This light is nothing but a low energy photons. Okay? So we are just concerned about the high energy photons making the X-rays. So what you are doing, you are accelerating the electrons. When these electrons are colliding, that binding wala photons is coming out, and what you are capturing, you are just capturing the high part of that photons, high energy photons. And when you are capturing the high energy photons, that is nothing but the X-rays. Okay? So the photons and the relation with the electromagnetic radiation we will see in the ICT. Someone was asking also in the class. Done? Chalo. Next. Sorry. Name नाम से कैसे related है? Don't go to this. That is why I am making write the things. High energy proton source. Don't link it with the function. ठीक है? Indus 1 and Indus 2. Indus 1 and Indus 2. So what is this? India's synchrotron facility. Please write, these are India's synchrotron facility. Synchrotron facility. India's synchrotron facility. Generally to produce, second point, generally to produce X-rays. Generally to produce X-rays. ठीक है. Third point, कहाँ located है? Anyone? Very good. Located in Indore, MP. Indore. Okay. Now, if you want to go further, what I want you to request is, there is a body which is responsible for this. You will write the name. You will search and you will write the name, and you are revising. Not important that much. ठीक है. Up. I am giving you 10 seconds. Please revise this part. Second bracket. Please revise the Higgs boson, Large Hadron Collider, Sun. Sun के बाद revise the synchrotrons and the HAPS and Indus 1 and Indus 2. Particle accelerators. Online, any doubt, anything? Online. Higgs field दोबारा explain करूं. See, Higgs field is like this digital the screen. ठीक है. This is available everywhere. So in this field, whenever it is available, even in the vacuum, whenever the Higgs boson interact with any of the fermions, it imparts the mass to it, or any of the other particles also. It imparts the mass if it can interact. Okay? So whatever is the mass coming to the fermions or maybe W and Z bosons, it is coming from the Higgs boson. You remember this much बहुत है तुम्हारे लिए, है ना? This much is sufficient. Done. हो गया? आगे बढ़े? चलो. Okay. Now. बेटा ठीक है. This is very important topic for your year. Neutrinos. Done. On the board now. on the board now. Whenever you see the atom, and in that atom, if there is a decay, then there will be an oozing out of neutrino from that atom. For example, let's say when I talk about the nuclear power plants, done, or let's say this radioactive decay, or maybe in the fusion. Whenever there is a decay or there is a nuclear reaction, the neutrinos will nothing but be the outcome of it. Neutrinos ooze out. Okay. Ab, when I talk about the neutrinos, again three things important from our exam point of view: charge, mass, and spin. So we have discussed this sufficiently. You write first charge, mass, and spin. ठीक है, ब्रैकेट में लिख लो charge, mass, and spin. What is the charge? In bracket you will write charge is 0. Mass, very small, right? Very small. It is non-zero mass. Let me tell you very frankly, the statement will come like this only: neutrinos are zero mass particles or non-zero mass particles. So these are having mass. There is charge 0. Charge is 0. Done. So this charge is 0. Spin is half. Mass is, although I will not use the word negligible here, very small mass. Neutrinos, ठीक है. Please make an arrow and write. Make a vertical arrow and write. Oozed out, or come out in decay, comma, radioactive activity, comma, fusion. See, if you remember, I told you these neutrinos are part of atom. Have I told you this? Fundamentally, neutrinos are not part of atom. On the board, please यार, फिर बोलोगे सर ऐसा पढ़ाया वैसा पढ़ाया. On the board, neutrinos are not part of atom. The flavors of neutrinos are part of atom. Are you getting my point? For example, you have seen 3 flavors. Those 3 flavors are part of atom, but those 3 flavors have independent name. The name is not like electron. They have tau neutrino, electron neutrino. These are flavors of neutrino. So whenever they are in the atom, those are nothing but the flavors of neutrino, or the flavors of this lepton, right? Flavors of lepton. Once they ooze out of some decay, those are nothing but the neutrinos. Done. थोड़ा सा complex है. What we will do, we'll first write it. ठीक है, तो इतना हमने लिख लिया. Then please write, make an arrow and write, make an arrow and write neutrinos are not part of atom, comma, but they are produced inside nuclei and leaves immediately during decay. Okay. अब my question to you, My question to you: can I say the neutrinos are only available in the universe? I mean, let me rephrase it. Neutrinos are not naturally available on the Earth, or naturally. Let me rephrase it. Neutrinos are not naturally produced on the Earth. True or false? Right आ गई क्या बेटा? सौरभ हो गया क्या? लाइट आ गई क्या? देखना. ठीक है ठीक है, तुम लोग इलेक्ट्रीशियन मत बनो. हाँ. So what I'm saying that neutrinos, I'm asking a question. Neutrinos are not naturally produced on the Earth. True or false? I told you, in any of the radioactive decay, don't you think the nuclear reactors works on the Earth? So from those nuclear reactors also neutrinos are oozing out. Even in banana, there is an radioactive element which keeps on decaying, which we'll see today, right? So from that also neutrinos are oozing out. So whatsoever is the decay process, in whatsoever activities, neutrinos will ooze out. So please make an arrow and write abundantly available on Earth and in universe. And in universe. In universe कहाँ से आ रहे हैं? In universe, from where the neutrinos are coming? From stars. There is a fusion reaction in the star, and whenever the reaction is there, there will be a decay, and whenever the decay is there, the neutrinos are oozing out. Please write. Then make a comma and write. Make a comma and write. Second most. Please write. Second most abundant. Second most abundant after photons. Second most abundant after photons. Okay. Okay. Now tell me on the board. Tell me. Neutrinos will interact with what sort of forces? Neutrinos will interact with what sort of forces? We have done this. Weak nuclear force and gravitational force. Please write. Only interacts with weak nuclear force and gravitational force. Now, I don't know how many of you understand this, but ठीक है. Let me try. On the board. नहीं भी समझ में आता है भूल जाना, ठीक है? टेंशन मत लेना, बस ऐसे याद रखना. If this is a wall, if I throw the ball to this wall, the ball will prevent this ball. ठीक है? दीवार इसको रोक लेगी. But when it comes to the neutrino, these neutrino have only two forces. Weak nuclear force, वो तो लगेगा नहीं, wall is very very far. Strong nuclear force will not be attracting. So whatever are the atoms in this wall will never interact with the neutrinos. Secondly, electromagnetic force will never interact with the neutrino. Thirdly, since the neutrinos are very fastly moving, the weak nuclear force will not be dominant on the neutrino. And lastly, gravity do not come into the picture. Why? Because the mass is negligible. So when it comes to these neutrinos can pass to this wall. Again, I am explaining. The first, strong nuclear force will not be acting on this. We have seen. Electromagnetic force is not acting on this. So it will not interacting with the protons, neutrons and electrons of this wall. Very clearly. Weak nuclear force, since the speed is very high, do not act or is not predominant. do not predominate, ज़्यादा नहीं है, ठीक है. Fourth, gravitational force. Since this is negligible mass, the gravitational force is very less. If you remember, we discussed gravitational force is directly proportional to mass of the object. So what is happening to these neutrinos? These neutrinos are passing almost all the object. Even you right now, billions of neutrinos are passing currently. Billions. Even around me. Because the neutrinos do not interact with the matter or the mass. Okay? Because of the properties of the neutrinos. And the gravitational force on the neutrinos is also weak because of the negligible mass of the neutrinos. Please make error and write. Last point. Yeah, why detection है ना, उधर लिखिए, दिखाइए. Why detecting? Please make an arrow, like vertical and right. Why detecting? Detection is difficult because of no interaction. Because of no interaction with mass. ठीक है. Slash you write matter. No interaction with mass or matter. मतलब if I want to stop the neutrino like this with my hand, it will not be stopped. ठीक है. It will pass through my hand. Done. Then what is the way out of detecting the neutrino? कैसे आप, how you will identify the neutrinos are there? How you will identify the neutrinos are there? See, there you will understand one thing. That neutrinos have some negligible mass. So whatsoever is the gravity that is acting upon it, so it may be interacting or should be interacting with the gravitational waves, which we'll see later. Okay. So neutrinos generally interact with the gravitational waves. So please make an arrow and write identified through, make an arrow and write identified through interaction with gravitational waves. Although mass is negligible, but up see, again there is a difficulty on the board here, please. That is how the things will evolve on the board. Mass is negligible, so they will interact with the gravity, but the interaction will be very meager, very weak. मानते हो? The interaction will be the weakest interaction. So what is happening, in order to identify these neutrinos, we cannot identify them directly on the Earth's surface. We have to go deep underground wherever the interaction is weak with the other ecosystem. Here the neutrinos can interact with the other masses can attract the neutrinos. Mass to hai, there will be the gravitational force, so the neutrinos will be attracted or will be distorted. So what is happening, what we are doing, we are going underneath the ground, maybe underneath the ice sometimes, maybe underneath the ocean sometimes, maybe underneath the ground sometimes, to identify these neutrinos. So whatsoever are the observatories set up to identify the neutrinos, you will find either they are buried deep the ice, they are buried deep the ocean, or they are buried deep the land or the ground. ठीक है. अब why we are detecting neutrinos should be your question. कि sir हम why we are detecting the neutrinos, क्या हो जाएगा? What will happen if we are detecting the neutrinos? Don't you think, first of all, if I am able to detect the neutrino right now, let's say I'm giving a hypothetical example, if I am able to detect the neutrino, I am figuring out, okay, these 3 or 4 neutrinos are coming right now to me. That means there should be something nearby which is having a nuclear, which is the ongoing nuclear activity. Hai na? So these neutrinos can help me identify the nearby nuclear activity. Let's say if I am able to identify the neutrinos are very high in amount and they are coming from somewhere from the universe. Don't you think the black holes and the other stars which are oozing out the neutrinos, I can identify them? So identifying the neutrinos or the rays of neutrinos, detecting the neutrinos, can not only help me identify the things on the ground, can also help me identifying the things in the universe. And I am giving a simple principle: whatever is undergoing decay or fusion or fission will emit the neutrino. And in order to detect all of it, in order to detect all those elements, be it the stars or the black holes or maybe the nuclear reactors or maybe anything in the galaxy which is either undergoing the fusion or fission, which we'll see today only, the neutrinos will be helping us. So please make iron right. Detection helps in detection helps in detection helps in identifying black holes, comma, supernova explosions. All these terms we will see in the astronomy. Supernova explosions, comma, early universe condition. That is nothing but the evolution of life on earth, है ना? Early universe condition, comma, monitor nuclear reactors on earth, etc. Done. I'm giving you 5 seconds or 10 seconds. Just revise neutrinos. Two things: charge, mass, spin. So they come out in decay, radioactive activity, fusion, fission. The neutrinos are not part of atom but are produced inside nuclei and leave immediately during decay. Okay. Flavors of neutrinos are part of leptons. Those are leptons, abundantly available on earth and in universe. So second most abundant particle after photons. Then there is a difficulty in detection because they generally have only weak nuclear force or is the weak gravitational force. So since the gravitational force is weak, the detection is difficult. अब the part is factual. See, now we have some global observatories, we have some Indian observatories. 4 of them I have written in front of you. Okay. 2 are of China. Sorry, one, this Trident is of China. Then we have IceCube. Then we have INO. INO is Indian observatory, but it is still under the construction. So what we are doing in the Theni district of Tamil Nadu, underground, deep the rock. See, I have told you, when I talk about the detection, either we are going below the ice, ये ice है, इसके below यहाँ पे आके we are detecting, ठीक है, or else we are going below the ocean, or else we are going below the ground. So whatever we are doing at India, it is underground. ठीक है. Ice cube कौन सा है? Ice. So this is under the ice. This is international. ठीक है. Then we have Trident. Trident is China. China is fine, but under ocean. ठीक है. So you just write the facts about them. है ना? 2-3 चीजें इंपॉर्टेंट है, किसका है और कहाँ है और कैसा है. I mean under the ocean है, क्या है. Please write Ice Cube Observatory. Sorry. हाँ, neutrino detectors में you have the space, right? Right. In neutrino detectors, please write INO. Sorry, Ice Cube. First you write Ice Cube. Please write Ice Cube. Please write. Buried deep in ice, at Antarctica. Buried deep in ice at Antarctica. Second point you write observe neutrinos from observe neutrinos from cosmic events, cosmic events. ठीक है, secondary right, INO, INO, INO. First you write the full form of INO. India based neutrino observatory, India based neutrino observatory is right. Second point, under construction, and underline this, there is a trap. It is not constructed yet, this is under construction, and out of protest अभी तो वो भी बंद है, ठीक है. Under construction at Theni district, THENI, Theni district, comma Tamil Nadu, comma Tamil Nadu. टाइप क्या है इसका? अंडर सी है, अंडर आई से अंडर रॉक है, अंडर रॉक. प्लीज राइट अंडर रॉक ऑब्जर्वेटरी. So this is under rock, this is ice, this is under rock. Same work, neutrino detection. Why we are detecting the neutrinos? Either for the universal events, maybe black holes, supernova explosions, everything, cosmic events, whatsoever it is, or else for the nuclear reactors and all those things. ठीक है. Trident, please write trident. Neutrino detector of in capital you will write China. Neutrino detector of China. Done. Is this ice, sea, or undersea or ocean? Please write undersea observatory. Undersea or ocean? Undersea observatory, underwater observatory. ठीक है. Okay. Then you write Juno experiment. See, in space tech we will read about the Juno mission, है ना, for Jupiter. That is different. There is Juno experiment, so do not confuse this with the Juno mission. ठीक है, that is also same, JUNO. This is Juno experiment. So please write by China. They are also by China, comma to detect neutrinos from sun, earth mantle, 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 nuclear plants, nuclear plants. Next point, also measured mass of neutrinos in bracket you write by detecting oscillation, oscillation we will see neutrino oscillation. Done. Last point, this is ice है, rock है, sea है, this is rock, underground. So please write underground observatory. underground observatory. Done. Now on the board, these are three terms which you have to remember from the neutrinos. Then we are done with the neutrinos, right? These are the three terms you have to remember with the for the neutrinos. First is neutrino oscillation. Second is atmospheric neutrinos, and third is neutrino fog. First I am explaining, फिर you will write on the board. On the board, whatsoever the neutrinos are currently present in the atmosphere, whatsoever the neutrinos are currently present in our Earth's atmosphere, those are nothing but the atmospheric neutrinos. Done. Not important. Important term is neutrino fog. See, if I am trying to detect, ध्यान से समझना, and this should be a very fundamental doubt because I too don't have the answer for this. I'm not a scientist, right? I too don't have the answer for this, very frankly speaking. For example, if this is a neutrino detector, let's say this is a neutrino detector. This neutrino is coming to the neutrino detector. How I will identify whether this neutrino is coming from the universe or coming from the power plant? Ayana, whether it is coming from the universe or it is coming from the power plant, I don't know. So what is happening? What is happening right now? Whenever the question of this neutrino detection is being like considered, then there are various random neutrinos in the atmosphere known with the name of atmospheric neutrinos, and these atmospheric neutrinos are blocking the new neutrinos coming from the universe. They are acting as a fog in the detection of the new neutrinos coming from the universe. ठीक है? So we have seen three concepts. Atmospheric neutrinos are the neutrinos available in the atmosphere. So whatever are the atmospheric neutrinos, whenever they are floating in the atmosphere, they are creating a neutrino fog. And whenever this fog is there, the neutrinos, the new neutrinos which are coming from the distant galaxies, from the stars, etc., this is creating a issue in the detection of these new neutrinos. Then either it is interacting or maybe blocking or the other aspects. Okay, so please write. You don't have the space. Okay, नीचे एक जो line है ना, नीचे जो line है, just divide that into three parts for three neutrino oscillations. First you write neutrino atmospheric neutrinos. First you write atmospheric neutrinos. क्या? No, because the बहुत weak interaction है, तो LIGO has to be situated underground so that detection is possible. Mass बहुत कम है ना? हाँ, सॉरी, अभी करेंगे ना वो, अभी क्यों ला रहे हो उसको? अभी रुक जाओ, एस्ट्रोनॉमी में देखेंगे उसको, डॉपलर, चर्केनोव, ऑल दोस थिंग्स. ठीक है, प्लीज राइट एटमॉस्फेरिक न्यूट्रिनोस. एटमॉस्फेरिक न्यूट्रिनोस are the neutrinos available in the Earth's atmosphere, are the neutrinos available in the Earth's atmosphere out of various activities. Out of various activities, these neutrinos went together, right? These neutrinos went together makes a neutrino fog. So write neutrino fog, makes a neutrino fog. So we have completed two, right? Makes a neutrino fog. Then you write neutrino oscillation. Neutrino oscillation. This we have discussed. बताओ क्या होता है? ठीक है, प्लीज राइट change in the form of neutrinos from one flavor to another. Change in the form of neutrinos from one flavor to another is न्यूट्रिनो ऑक्सीलेशन. या ठीक है, छोड़ दो, इसे हटा दो, छोड़ दो. ठीक है, डन. Now there are two words written in your document. One is antimatter, one is Majorana. We'll come to this later. Let's start the new topic. इसे रुक जाओ. Quantum tech. I'm giving you 1 minute. Just revise the particle physics. थोड़ा heavy है, I understand, but I've tried to make it as simple as I can. Sorry, नहीं नहीं, एक ही है, बना ही नहीं अभी. ये अभी अभी रुकते हैं, क्वांटम की बात करेंगे इसको. तो लास्ट 30 सेकेंड्स. ये तो मैंने मना ही नहीं किया, मास और मैटर से इंटरेक्ट नहीं करता. अरे बहुत वीक इंटरेक्ट करता है, क्योंकि वीक न्यूक्लियर फोर्स है ना, लेकिन स्पीड इतनी ज्यादा होती है कि निकल जाता है वो. हाँ, अब दिस इज समथिंग विथ. यार उस पर करते हैं ना अभी बात. इसलिए उसे अंडरग्राउंड जाना पड़ा. चलो ना, क्वांटम टेक. हाउ मेनी ऑफ आर कंफर्टेबल इन द पार्टिकल फिजिक्स? हाउ मेनी ऑफ आर नॉट कंफर्टेबल एट ऑल? आई मीन बिल्कुल ऊपर से गया है, कोई है ऐसा? ठीक है, चलो. ऑन द बोर्ड नाउ, प्लीज साइलेंस, प्लीज 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 प्लीज. ऑन द बोर्ड, क्वांटम टेक्नोलॉजी. What happens now? See, there are two forms of mechanics. First is classical and second is quantum. First is classical, second is quantum. Let's say any coin, anyone? अभी आने दो उसको. कॉइन है किसी के पास? एक बस बस. ठीक है, there is a coin in my hand. ठीक है. When I talk about the normal computer, the computer which I am using, you all use, or maybe the supercomputers also, normal computers or even the supercomputers, they generally work upon the classical physics or classical mechanics. When you will read classical mechanics में, the computer understand whatever you are inserting, whatever you are giving the command through bits. Bits, these are nothing but binary 0 or 1. If the coin is having, let's say, tail, the computer will understand, okay, it is tail. If the coil is having head, the computer will understand, okay, it is head. It will make some random combination of those heads and tail 0 1 0 1 0 1 to take the command from you to give the output to you. Let's keep it very crude, not important. ठीक है, समझो बस. 0 1 0 1 0 1. Okay, what is happening in the quantum? Quantum is using the qubits, and these qubits are nothing but the quantum particles. And when I say these quantum particles, these are nothing but, these are spinning, rotating continuously. For example, if this is a particle, if I flip this in the air, whenever it is in the air, it is rotating, spinning. Now whenever, right now it is in my hand, it is head, but when it is in the air right now, is it head or tail? It is both at the same time. There are multiple possibilities of the same coin at the same time. What is happening now fundamentally, और ये तुम्हें कहीं नहीं मिलेगा इतना simplified, क्वांटम समझ में नहीं आएगा, समझना हो क्या रहा है. What is happening? These particles can represent anything between 0 to 1, any possibility between 0 to 1. That means, for example, 0.1, 0.2, 0.3, 0.4, anything. I am saying this is representing, I am saying just very crudely, although there are infinite possibilities, I am saying very crudely it is 2000 possibilities. 2000 possibilities. Up. Generally, whenever you talk about computer to supercomputer, you increase the bits fundamentally. Bits. ऐसे समझो bits बढ़ा दी. Earlier, it was able to just count for 2. You have doubled the bits, 0, 1, 0, 1. It will count for. In quantum, what is happening? This possibility, if I am doubling this increase multifolds, because you are doubling the possibilities what was earlier. Okay. So in quantum, the things are very fast because there are various possibilities at any given point of time. Understand this way. If there is a problem, let's say I'm writing on the board, x square plus 5x plus 6 is equals to 0. I want to solve this. What classical computer will do? It will first keep 0, will try to solve, will keep 1, will try to solve, will keep 2, will try to solve, and so on. That's what fundamental computer will do. What quantum computer will do? Quantum computer will keep all of them at the same time in this equation, will try to solve it one go. And that makes quantum computer much more faster in the process. Now, I expect you to know two terms in quantum computer or quantum technology. Two terms. Please do not speak here. Please do not speak. थोड़ा सा फोकस लगा लो वरना रटना पड़ेगा, फायदा नहीं है. Quantum tech, two things. First is superposition, and second is entanglement. What is superposition in the quantum computing? What is superposition in the quantum computing? That a single coin can be in multiple states at one time. At one time. That means it can solve multiple equation at one go. I will give you a very crude example. Have you solved the maze? भूल भुलैया बोलते हैं, है ना? For example, if you have to reach this center, maybe there are some roads like this maze. कहाँ से जाओगे and all those things, right? If I talk about the normal computer, how the normal computer will function? Normal computer will first take this path. Okay, I'm not reaching here. Come back. Then we'll explore this path. Okay, I'm not reaching. Come back. Then I'll explore this path. I'm not reaching. Come back. I'll explore this path. I'm not reaching. Come back. I will explore this path. Not reaching. Come back. This is normal computer. Quantum computer is like water. You release water here. Ultimately, some part will reach here. समझ में आया quantum computing क्या है? This is nothing but the quantum computer. You are doing multiple calculations at one time because it exists at one time in multiple states. This is nothing but the superpositioning of quantum particles. The single particle can be exist in the multiple positions. Okay. Then there is a process of entanglement. This says that if there are two particles, if there are two particles, and if they're entangled, if I am able to tell the position of this particle, or if I know the position of this particle, then the position of this particle is obvious for me. The position of this particle is obvious for me. I will explain you this. See on the board. Let's say your hometown is in Mathura. You got the invitation, or your family got the invitation, Papa and Mama. Okay, they got the invitation from two places. One is in Agra and one is in Delhi. On the board, please please please. फिर नहीं तो फायदा नहीं है, समझ में नहीं आएगा. Your family got an invitation from Agra and Delhi of some function in the evening at the same time, right? And on the same date. Let's say they have to reach on 1st February. Both of the events are important for your family. Close relatives के event हैं. Both of the events are important for your family. Up. Your parents decided, let's go at both the places. And how we will do it? Mama will go at one place and the father will go at other place. That is how they decided. If we have to attend both the functions, and one person will go at one place, the other will go at other place. What I am saying, if I am able to tell that the your mother is in Agra, then where your father will be? This is entanglement. That if I am able to tell the position of one particle, the other particular position is known to me. ठीक है, अभी बेसिक इतना लिखते हैं, डॉक्यूमेंट दिखाइए. ओके, प्लीज राइट क्यूबिट्स में please write qubits. Qubits are basic unit of information. Qubits are basic unit of information in quantum mechanics. Comma, existing in many states between 0 and 1. So this is a reference of classical mechanics between 0 and 1. Okay? Existing in many states between 0 and 1. Please write. Okay. Write the spelling. Fluxonium. Second, right? Majorana 0 nodes. Fluxonium, Majorana 0 nodes. Maybe same line or different line, anything is fine. Majorana 0 nodes are examples of qubits. 0 NODES nodes 0 NODES nodes, Mesorana, यार PYQ है ये तो, Mesorana chip, so Mesorana chip build upon the Mesorana nodes, 0 nodes, ठीक है. चलो, now you write under the superposition. Superposition, it allows quantum objects, quantum objects are nothing but the qubits, right? Quantum objects to simultaneously exist in more than one state or location, in more than one state or location. Make arrow downward or horizontal, whatsoever is our framework. दिखाइए कैसे बना रहे हैं, ठीक है. Either make a horizontal arrow or a downward arrow, both are fine. Please, right? This enables multiple calculations simultaneously, calculations simultaneously in quantum physics. Make arrow again a horizontal or vertical, makes quantum, make a arrow and then write makes quantum faster and accurate, faster and accurate. Then write quantum entanglement, लिखा है ना शायद, वर्ड तो है, please write. Please write refers to interconnectedness between particles, comma where state of one influence the state of another, on the board. See, I have not told you two locations A and B. What are these locations? I have not told you. Whatsoever is the difference between these two locations, I have not told you. But the concept remains the same, that your family has to attend both the events. Both the events are on same date at the same time. One place mother will go, one place your father will go. I am saying again, if your father is now at A, where your mother will be? B. Mother will be at B. So there is a beauty of these particles that irrespective of the distance, even if they are thousands and thousands of kilometers apart, irrespective of their distance, if I am able to tell right now this is the position of this particle, or this is the situation of this particle, I can tell the situation of the other particle as well, and this helps in communication. For example, I want to send you the message A. When I've typed it, you're at a distance, you're getting the message, because irrespective of the distance, the position influence each other. Okay, just remember this thing. Make an arrow and write irrespective of distance, comma, changing or altering, one bit one qubit will directly influence another, For example, let's say somehow the plan was the father was supposed to go at A and the mother was supposed to go at B. 2 days ago the plan changed and the plan is now the mother is going at A, where the father will go B. So you can tell the prediction also if the change is there. Done. Then you write please write एक बार कैसे नोट्स है, ठीक है. मेक अ एक्सट्रीक मार्क, अगर नीचे स्पेस है तो एक एक्सट्रीक मार्क में लिख लीजिए. doubling the qubits make a extreme mark. This is common to both superposition and entanglement. Somewhere you can write doubling the qubits, exponentially double the computing, because of the above properties, superposition and entanglement. भूल गया. अरे यार same thing. For example, here I am doubling the bits. The things are just being double, but these are infinite. So infinite into double will be again very high, very huge. Okay? So it will exponentially double the outcomes. And that is what I am trying to explain you. Okay? Chalo. Okay. Now on the board. So we have done this qubits, we have done the superposition, we have done the entanglement. Done. Now let's see the application wala part on the board. Beta, please. अरे सुन लो यार. On the board. मेरे से पूछ लो आप. मेरे को ज्यादा आता है. ऐसा नहीं है, बट पूछ सकते हो. थोड़ा आता है. So we have few topics of what I can say the applications of the quantum physics or the quantum technology. First is quantum computer. So whatsoever are the calculations being done right now by the computers or the supercomputers, we can make it more faster, more accurate, more reliable by using the qubits, because they can do the multiple calculations at one go. Done. Computers. They are, if I say, let's say the supercomputer is solving something in 5 years, they can do this in 5 seconds. That is the difference. Itna difference hai in quantum and in supercomputer. That is where I told you in the economy wala class also that once this quantum computers are out, फिर वो bitcoin सब side में रह जाएगा. You can then hunt them out in fraction of seconds, है ना? Right now bitcoin mining takes time, takes energy, takes computers, lot of computers. But once this quantum computer is practically implemented, then bitcoin and all those minings will be sided. 1 second में, or maybe in 5 seconds or 7 seconds, all the bitcoins will be mined, है ना? So that is the strength of quantum computers. Now in this quantum computers there is a word which is quantum supremacy, and please focus on the board. नजर हटी दुर्घटना घटी. ठीक है, कहाँ से क्वेश्चन आएगा you don't even know. You have to cover everything. So what I'm saying, there is a term quantum supremacy. Whenever a quantum computer outperform any of the supercomputer, faster calculation than the supercomputer, that phenomena is nothing but the quantum supremacy. That whenever the quantum computer is outperforming the supercomputer, and that is the case in almost all the quantum computers, the phenomena, that state is known as quantum supremacy. Then there is a quantum chip. Quantum chip are those inbuilt processors in these quantum computers also, quantum communication also, quantum satellites also, quantum sensors also sometimes. Quantum chips, these are the processors. Like you have the processor which is your brain. So the processor in the quantum computer is nothing but the quantum chip. So we have to see three types of chips, which are Willow, Majorana 1, and then we have 25 qubit QPU. Okay, these are three varieties of chips which we have to see, and UPSC has already asked the question from the Majorana 1, and I taught this last year verbatim. जो पूछा है वो एक ही slide पे I taught. ठीक है, so UPSC asked the question on this last year. Now second utility of this quantum technology is quantum communication. See, I am explaining everything at one go, then we'll write फटाफट. ठीक है, quantum communication. So for example, right now we are exchanging the messages. If you want to communicate with me, we are exchanging the messages. These messages are, sometimes you will see the word encrypted, right? That no one in between can encrypt the messages. Also that encryption, just understand one thing, is that encryption, is that, decryption, I mean decoding that message, is it always impossible? That decryption can be done, but there has to be various random calculations in between. For example, you send me the message, sir kaise hain aap? Yes sir. This message will be encrypted, encryption will done, and this will travel to me. At my point it will be decrypted with the keys which I am having. My phone will be having the keys to open it. With this we'll see in the ICT further. ठीक है, अभी अंडरस्टैंड बहुत सिंपल से, मेरे फोन के पास चाबी है इस मैसेज को खोलने की, तो my phone will apply that key, will open it and will read. Sir, what I'm saying, if some hacker comes in the between, the hacker can decode this message by doing the decryption, है ना, decoding this. But for this the hacker has to solve encryption, मतलब this has been decoded into various problems, bits में तोड़ के, बहुत complex सा puzzle है, puzzle. Encryption is nothing but puzzle. So if I want to solve this puzzle, I have to do the decryption, and this decryption is possible if I am able to solve this puzzle. I can read whatever you are conveying to the other person. What I am saying right now, this decryption is very difficult or almost impossible. Why? Because we don't have the supercomputers, right? The hacker will not be having the supercomputer, or maybe the computer with a very faster calculation, you know? But if the hackers are having the supercomputers or maybe the quantum computers, the hackers will be able to do the decryption in a fraction of seconds. वो solve कर लेगा जो भी puzzle है, the hacker will be able to solve that puzzle. Why? Because he is able to do the multiple calculation in fraction of seconds. Done. So to avoid this, in the quantum technology, we have quantum key distribution. That in the quantum field, you are distributing two keys to different people. Now in quantum, there is a beauty of quantum entanglement, that whenever that quantum particle is traveling, if you are interfering, the particle will change the state, and once the particle is changing the state, the entire thing will change at the other go. I told you, na, if the mummy is replaced with the father at Agra, then the entire thing will change. Okay, that is the beauty of the quantum encryption. So that is possible, the quantum cryptography is possible with the help of quantum key distribution. So this is nothing but the encryption by using the quantum technology, by using the qubits, by using the quantum particles, and this encryption is almost impossible to decrypt. Okay, now there are some protocols in use for this encryption, this we will see later. अब let's come to the quantum material. Quantum material, अच्छा पहले इतना लिख लेते हैं, ठीक है, फिर इस पे आते हैं. चलो, what is the quantum computers, please write. हाँ बेटा ये ऑन करो ना आप. Quantum computers, please write. There is a space, right? Quantum computers and quantum supremacy के बीच में space है. You have to write, you have to use that space between the quantum supremacy and quantum computers to write whatever I am dictating. Please write. Solve complex problems. Solve complex problems by breaking solve complex problems by breaking it into multiple possibilities comma all being solved multiple possibilities comma all being solved at once all being solved at once. In bracket you can write faster. Then write quantum supremacy. Please write please write state where quantum computers outperform supercomputers on the board now. On the board now. So this is a quantum computer of Google with the name Sycamore. Okay, so you will remember the name Sycamore quantum computer by Google. I will make you write. See how it is looking. It has achieved quantum supremacy by performing a calculation within a few seconds that frontier is nothing but the most powerful supercomputer right now in the world would take 47 years to complete. So what frontier supercomputer will take 47 years to complete? This supercomputer solved that in fraction of second. Done. ठीक है, not important. Done. इतना बहुत है ना? So please write now. In bracket you write quantum supremacy, in bracket you write Sycamore, 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 Sycamore. Please write supercomputer by Google. नहीं सर, ये क्वांटम सुप्रीमेसी में लिखना है. वहीं पे एक ब्रैकेट बना लीजिए, बॉक्स बना लीजिए अबाउट साइकामोर. साइकामोर इज नथिंग बट अ सुपर कंप्यूटर, सॉरी क्वांटम कंप्यूटर, सॉरी प्लीज दिखा दो. साइकामोर, हाँ प्लीज राइट क्वांटम कंप्यूटर, सॉरी प्लीज राइट क्वांटम कंप्यूटर बाय गूगल comma has achieved quantum supremacy. What is quantum supremacy? That the quantum computer is outperforming the supercomputer. The bracket close. Okay. Then the next is quantum chips. Please write first below quantum chip. In bracket you write first, sorry in bracket under that quantum chip write first. Please write below WILLOW below. Please write semicolon quantum chip by Google. Second you write Majorana 1, MAJO RANA, Majorana 1. Please write quantum chip by, very good, Microsoft. PYQ है क्वांटम चिप बाय माइक्रोसॉफ्ट। Second point, in Majorana 1 you write, Majorana 1 please write powered by topo conductors, topo conductors, topo conductors. Please write next. Built using built built PUILT built using arsenide 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 and aluminium particles, arsenide and aluminium particles. Underline topo conductor, mark it 1 star, mark it 1 star. ठीक है, topo conductor we will see in the materials, है ना. There is neither solid nor liquid, this is another state, topological state. ठीक है, we'll see this in the matters, अभी लिख के छोड़ देते हैं. So we have done the second step. Third you write, please write 25 qubit KPU, 25 qubit KPU, QPU, sorry, QPU is small, QPU, 25 qubit QPU. Please write India's oh, just allow me a minute. I forgot the name of the startup. India's first quantum chip, comma, developed by startup, the name of the startup is this QPI AI. So this is the name of the startup, QPI AI. This is important, indeed important. Again I am saying this is important. Okay, QPI AI is the startup. So it's not made by any ministry or maybe any other big organization. It's made by a small startup, QPI AI. Okay. See, this was praised by PM, India's PM. This particular India's quantum chip. So this was very much in news. Now you write. It is designed to power India's first India's first quantum computer. Quantum computer. This is the name. UPI Indus. UPI Indus. I will keep the things in perspective now. See, on the board, we have seen the supercomputers, faster calculation, multiple calculation, one go. Beyond supercomputers, we have seen the quantum supremacy. So whenever the supercomputers are outperforming whenever the quantum computers are outperforming the supercomputers, there is nothing but the quantum supremacy. Now in that we saw the Sycamore. Sycamore is nothing but a quantum computer of Google. It has achieved the quantum supremacy. Then we saw the quantum chip. Those are nothing but the processors or the brain of quantum computers. In quantum chips, we have seen 3: Willow by Google, this Majorana 1 by Microsoft, and then from India's point of view, we have seen this 25 qubit QPU. Just remember this qubit QPU. This is praised by the government, acknowledged by the government, and given the status of India's first quantum chip. But this is not made by the government. This is made by the startup UPI AI. And apart from this chip, that particular startup has also made this quantum computer with the name UPI AI Indus. Okay? So this is the story so far. Now let's go to the quantum communication. So please write in quantum communication, whatever is the space below the quantum communication, please write use of quantum tech for secure data transmission. For secure data transmission. Then you write the quantum key distribution. Please write quantum key distribution. Technique of secure distribution of keys. Secure distribution of keys for message encryption and decryption. For message encryption and decryption. So message encryption and decryption. Please write. Please write. Any tampering. इसी में लिखना है, कॉमा लगा के या सेकंड पॉइंट. एनी टेम्परिंग. Any tampering in the channel can be detected as quantum particles change the state if disturbed. See again on the board. I sent the particle, ऐसे समझो, I send the particle. If I am having one of the particle, I send one of the other particle, है ना? अब if that particle in the between is tempered, the particle will change the state. And if that particle is changing the state, the particle which is with me is also changing the state. अगर पापा जा रहे थे, by any chance मम्मी हो गए, मतलब ठीक है ना, let's say तो इधर भी वो चेंज स्टेट हो जाएगी, वो स्टेट चेंज हो जाएगी, ठीक है. And that is how the entire encryption can be aborted because it is tempered. Whenever someone is intervening to the process of the channel, the keys will be disturbed or the bits will be disturbed, ठीक है, because of the simple phenomena of entanglement or else the superposition. Done. चलो, then you write quantum cryptography. Is it there? अभी आते हैं उस पे, प्रोटोकॉल्स पे आएंगे अभी. क्वांटम क्रिप्टोग्राफी, it refers to creation of creation of theoretically unhackable secure communication channels. Secure communication channels by using, क्या यूज करोगे, QKD, by using QKD, quantum key distribution. So I told you general normal messages can be encrypted or decrypted by using the supercomputers or maybe by doing multiple calculations. Just puzzle solve करना है. But quantum में if I want to send the this message which cannot be theoretically hacked, I am using the quantum cryptography, which have the phenomena which incorporate the phenomena of quantum key distribution. I have one key, you have one key. If there is any alteration, there will be a change in the key, and the uh, entire process can be aborted. Okay. Now first you write these protocols, then I will first you write the protocols. Protocols BB 84. Please write BB 84. Right. Fundamental QKD protocol. Fundamental QKD protocol for quantum cryptography. For quantum cryptography. Second point, it generates secure qubits among two users. Among two users. ठीक है. Then you write second one, E91 protocol, and mark it 1 star, please. दोनों को. BB84 is more important than E91. BB84 protocol is more important than E91. पहले लिख लेते हैं, then I will explain. Please write. Okay. BB91 protocol. Please write. It is advanced protocol. E91 protocol. It is advanced protocol incorporating the entanglement entanglement. To securely share keys, to securely share keys. Up on the board. See, whenever you are communicating now, whatsoever message you are generating, let's say you generated the message, hi, I am good. You generated the message, hi, I am good. Now this message will be encrypted with certain set of rules. The message will be encrypted with certain set of rules. Rule book will be there done in your WhatsApp also, so that it can be uh, traveled through that bits 0101 के format में. So that rule book is known as protocol of transferring the messages. So in quantum we have two types of protocols. One is BB84, second is E91. The former one is BB84. BB84 is nothing again a rule book. This will convert your message into some encrypted keys which can travel in qubit form and then which can be decrypted at the user's end. ठीक है. Role of the protocol I am explaining you. Rule book है, it will encrypt your message, will make it travel and will decrypt your message at the user's end. Protocol है. Up there is an advanced version of this protocol BB84. It is E91 protocol. This, apart from superposition, E91 also have entanglement. E for entanglement. So superposition भी है, entanglement भी है. This is something which you have to remember, nothing more, nothing less. If UPSC will ask the question on this, UPSC will ask only about what is the like this protocol is related to what. That is it. You will see the PYQs now. UPSC is asked from quantum the PYQ on qubit. That qubit is related to what? Okay. So you have to just understand this thing, that BB84 protocol is a protocol related to the quantum technology. Whenever the messages are traveling, it helps in the encryption and decryption. So it's a rule book that how this message will be encrypted into the qubits, then will travel further. Okay. And the upgraded version of BB84 is E91 protocol. This was very much in news. BB84, this was in news. ठीक है. तो mark it 1 star, ये important है ना. चलो हाँ. So there is a governing body. So there was a person named Charles Bennett, if I'm not wrong. He invented this protocol. ठीक है. So not something which is national, this is international. So these are the international protocols that you have to use these rule books to encrypt or decrypt the quantum the message through the quantum technology. Okay, you just remember this, that these are the protocols to convert the message into the quantum bits, nothing else. है ना? Then we have the quantum material. अब quantum material, अच्छा, understand one thing. What will be the size of the qubit? Very small. It will be even lesser than the nano. Okay, it's the particle size, qubits you are traveling. So nanotech and quantum tech are interrelated sometimes. So what is happening, whenever you're taking a particle and the particle size is very small, quantum size or nano size, what happens, the particle start changing the particles has different properties from the parent particle. And especially these properties will be sometimes optical properties, sometimes mechanical properties, sometimes electroconductive property, all those properties which we will see in the nanotechnology. You understand one thing, out of that property we have some materials, and out of that material we have one material which is quantum dots. These quantum dots are of very small size. Okay, you might have heard about one LED type, QLED, सुना है? Ultra HD QLED. ठीक है. So quantum dots, what is happening, these are very small size dots. I will show you a video, उससे बहुत clarity आएगी. Okay, very small size dots. What is happening, whenever the photons are striking or the energy is striking, they are emitting the photons. And I told you, if you remember, photons could be a source of light also if it is in low energy bandwidth. If it is high energy, it will be other rays or all those things, right? X-rays. So it is emitting a photon. Now based upon the size, let's say the size is small, slightly bigger, and this is very bigger, the wavelength will change of the emitted photons. So maybe the smaller wavelength of the smaller photon, let's say this smaller, what is the particle, if this is emitting violet, this is emitting green, this is emitting red. So based upon the size, there will be different color which will be coming out of from these small particles. And whenever you place these particles on the screen, those are nothing but the quantum LEDs, right? Quantum dots emitting the lights. Then please just write it, quantum dots. Quantum material में please write quantum dots. Please write, when some light quantum dots में please write in quantum dots, quantum material का there is a type quantum dots, please write, when some light is shined on quantum dots, it absorbs and re-emit, it absorbs and re-emit light, it absorbs and re-emit light. Second point, dot color in bracket right during re-emitting, dot color during re-emitting depends on size of the dot, depends on size of the dot. Okay, whenever you are changing the size, the emitted light, re-emitted light will change. Okay, let me see if I have anything. Distribution. Oh. So it's nothing but a animation of the same thing which I have explained you about the quantum key distribution. So whenever the hacker is trying to encrypt your messages, the quantum particle will change the state, and when the quantum particle is changing the state, you will know at the source that the message has been disturbed. Then so it is unlike qubits. चलो इसमें ज़्यादा important कुछ है नहीं, I have explained you everything. Slide is on. ठीक है, क्वांटम सैटेलाइट देखते हैं. Quest project, just remember the name. So what is happening, this quantum communication is being used in the satellite now. So the same quantum key distribution and the quantum cryptography is used in the satellites to communicate between two places, and that is nothing but the quantum satellite. Okay, what is the use of quantum satellite for the communication? The tools used will be the QKD for the encryption and decryption. Done. What you have to remember? You have to remember one name which is MICIUS, MICIUS, MICIUS satellite. So MICIUS satellite, I will make you write, is the first quantum satellite made by China. Okay, and the project under which that satellite has been made is nothing but the Quest project. Okay, so in your document please write, दिखाइए, quantum dots, quantum satellite में please write MICIUS, world's first मिशियस, मिशियस में लिखिए वर्ल्ड्स फर्स्ट क्वांटम सैटेलाइट, वर्ल्ड्स फर्स्ट क्वांटम सैटेलाइट, कॉमा, मेड बाय चाइना under the see the name QUESS Quest project, under the Quest project. Second point you write enabling the communication, enabling the communication using quantum key distribution, QKD, enabling the communication using QKD. QKD. See, these are the quantum dots. Very tiny crystals they are. ठीक है? See how they emit the different light color. There are different sizes. Whenever the size will change, the colors which they are emitting will change, and this we will see further in the ICT, electromagnetic this waves I will discuss with you. Okay, why the particles are emitting the different light color. Whenever the light is striking, they are glowing up, but with that particular color only, red, green, blue. I need to rewind it. We can harness it to make little tags for imaging cells. We can use it to help us with cancer. The quantum dots I am saying, the quantum dots can travel in your body, right? We can use it for more efficient lightings, है ना? So I think there will be a photo here. Bulbs के बारे में he is saying that in bulbs what used to happen, there was a huge energy loss. So we came to what? We came to LEDs now. LEDs. Lesser heat loss, more efficient है. What he is saying, you look great under these lights, it's fine. But in LEDs, the issue is they reflect on your face like this. LEDs white हो जाता है ना? Now whenever you are using the quantum dots, this is problem is getting solved. The lights are coming natural lights. Your face is not getting white. This is what he is explaining with the quantum dots. So if you need a better picture quality, better clarity, there is QLEDs, quantum LEDs. With a more better, more brighter, more good picture. He is explaining the problem in the LED right now. Why? Because these LEDs miss the red color, and this quantum dots have red color as well. So please write it now. Quantum dots can also have red color, unlike LEDs. Unlike LEDs. In bracket you write more clear images. More clear images. This we will see further in the I will take a topic OLEDs, LEDs and QLEDs. Okay. So in 2023 these quantum dots they got a Nobel Prize also. Okay. So 2023 Nobel Prize in Chemistry was awarded to the quantum dots. If you want to write, you can write this. This is also, I mean, नहीं पूछेगा but ठीक है लिखो. Awarded 2023 Nobel Prize in Chemistry, quantum dots. Also the, if you can see, the phenomena is of physics. ठीक है. 2023 Nobel Prize in Chemistry. चलो. Now something from the quantum, this current affairs. Quantum tunneling, quantum clock, quantum echo. This year, quantum tunneling has been awarded Nobel Prize in Physics. ठीक है. This year's का Nobel Prize has been awarded in physics for the quantum tunneling. Anyone in the class who can explain me the quantum tunneling? I don't need the definition, I need the explanation. Quantum tunneling. It's fine, but what does that mean? ठीक है. Potential energy barrier. ठीक है. See, what is happening? I will explain you this through the example of neutrino only. I told you, if I have the neutrino, that neutrino can pass this wall, right? So quantum physics, this quantum physics works on the possibility aspect. It's not binary, it is possibility. Generally, when you throw a ball will pass this wall if the ball has the sufficient energy. Done. But let's say the ball is not having the sufficient energy, the ball will strike here and will ball will come back. मेरी बात समझ में आ रही है? This is nothing but the classical physics, that the ball, if the ball don't have the sufficient energy, ball will come back. But in classical, but in quantum physics or quantum this technology or quantum mechanics, there is a art of possibility, which says that the ball, even if don't have the sufficient energy, can pass this energy barrier. There is a possibility of this ball passing the energy barrier, and this is because this ball is not a matter, this is a particle. This is a wave, this is acting as a wave like phenomena. Done. And if this ball can pass this particular, what I can say, the wall, right, this is nothing but tunneling. So in quantum physics, physics says that since this is a wave like phenomena, it can pass the wall. Or crude karunga, although this is not right, but let me make it more crude. On the board, there is a wall, you throw a stone to this, the stone will go like this. Let's say horizontally thrown a stone will be blocked at the wall. But quantum physics says that this stone is a particle, this is not a matter, this is a particle. This will travel like this, and in certain cases it may sometimes cross the wall or the energy barrier. नहीं समझ में आया, कोई टेंशन नहीं है, ठीक है. नोबेल प्राइज मिला है, कुछ तो होगा उसमें, है ना, कोई बात नहीं. What you do, you write it right now, ठीक है, प्लीज लिख लो अभी. And this I will discuss again in the current affairs, and I will show you a video. I will show you a video of a glass. We'll see this again in the current affairs. As of now, let's write it. Please write. Please write. Please write. Also called barrier penetration. Also called barrier penetration, comma, phenomena of, also called barrier penetration, comma, phenomena of quantum physics where a particle with low energy a particle with low energy can also pass or penetrate higher potential energy barrier higher potential energy barrier due to due to wave nature wave nature of particle due to wave nature of particle at quantum level at quantum level on the board now. Last try. ठीक है, last try. This is a barrier, this is a barrier, potential energy barrier. What classical physics says that, for example, you are throwing some particle here, the energy is not sufficient to pass this particle, will stop. Quantum physics says that it is not the case. The particle at a very smaller scale do not go linearly, it goes like a wave. So when it goes like a wave, there is a possibility that it may cross the barrier. Understand this way ना, although it's not the right way, ठीक है, but फिर भी समझ में आ जाएगा ऐसे. Understand this way. If the particle is going like this, the particle may not pass, but there will be the possibility na, if I shift this to the right hand side, there will be the possibility, let's say this is the case, earlier this was the case, particle stopped, but I'm saying there is a possibility that this is the case. So since the particle is having the wave like nature at the quantum level, there is a possibility that the particle will penetrate the energy barrier, okay, and this is nothing but the quantum. Done, sorted. Chalo. Then you have quantum clock. First you write, then I will explain. हाँ, shall I take doubt after this, please? आप कहीं लिख लीजिए पीछे, है ना? Quantum clock. Please write. First you write, then I will explain. It measures it measures time using tiny quantum events such as atomic jumps, atomic jump, JUMPS, atomic jumps, or electron tunneling. Okay, please write then further. Please write. It is ultra precise. It is ultra precise. It is ultra precise. Please write. Can be used can be used for GPS, GPS, comma, comma, dark matter detection, comma, telecom networks, etc. etc. See, generally the normal clock, देखिए normal clock, not this, जो normal clock pendulum से time measure होता है ना. These atomic clocks measure time by using the measuring the time of the atomic jumps. You know the value of 1 second or 1 minute, how it is equated. All of it is calculated by using the quantum clocks. ठीक है. Please write last thing. इसको लिख लीजिए. Please write. Please write. 1 second. 1 second is equivalent to almost billion oscillations of radiation from write this word, radiation from cesium, CESIUM, cesium 133 atom, cesium 133 atom. See now on the board. For us normal human beings, we understand minute, second and hour. But if I want to break that second into very minute part, how you will do it? That is done through the quantum clock. If you want to break it multiple folds, seconds का भी 1/10 or maybe one by one, let's say 1 billion, 1 by 1 billion. That also you can measure through the quantum clocks. So these clocks measure the time by quantum jumps of the subatomic particles. So I told you they keep on changing the flavors or the types. So these quantum clocks measures that, है ना? Hence they are very precise. ठीक है? The error in the other clocks will be in seconds. Here the errors in 1 billionth of second. So I told you, a quantum clock which is nothing but cesium 120 atom clock. So this quantum clock, for this quantum clock, almost 1 billion jumps when this will calculate will be equivalent to 1 second. So this is the preciseness of these quantum clocks. And if they are more precise, they can be used in multiple places. For example, GPS. GPS may there is a importance of the timing. For example, right now, if online people are watching this video, there is a lag of maybe 4 seconds, 5 seconds, 6 seconds. Are you understanding this? So this lag is out of this delay in the time. This we'll see further in the ICT. If I decrease that lag, if I'm able to calculate that time more precisely, I can reduce this lag also. Okay. That could be achieved by nothing but the quantum clocks in GPS, in other sort of calculations. आपके लिए सिर्फ इतना important है, quantum clocks measure the time by using quantum jumps or electron tunneling. बस इतना बहुत है ना, and these are more precise than the classical clocks. Then you write quantum echo. quantum equals. Please write advanced quantum algorithm. Advanced quantum algorithm made by Google by using which chip? Willow chip. WILLOW by using Willow chip. WILLOW Willow chip. ऊपर लिखा है आपने 3 types of chips, उसमें पहली वाली. ठीक है. So this is quantum echoes is by Google by using the Willow chip. Please write then second point. इतना कॉम्प्लेक्स करने का फायदा नहीं है. इतना बहुत है. ठीक है. इसमें करंट अफेयर्स में बाद में आके आई विल मेक इट मोर कॉम्प्लेक्स, अदरवाइज आई हैव टू टीच यू एवरीथिंग. एनक्रिप्शन, डिक्रिप्शन, आईसीटी सब पढ़ाना पड़ेगा, फायदा नहीं होता. लेट्स कम टू, इज दिस इन योर डॉक्यूमेंट? स्पेस है लेकिन. अच्छा, क्वांटम सेंसर्स है क्या? लेट्स डील विद द क्वांटम सेंसर्स फर्स्ट. प्लीज राइट क्वांटम सेंसर्स. प्लीज राइट quantum sensors. Quantum sensors used to measure physical quantities with extremely high precision. With extremely high precision. Second point, they can measure time, gravity, magnetic field, etc. See, if that measuring time, what they will be called? Quantum clocks. Okay. So quantum sensors, they can sense even the gravity, even the time, even the height, even the image, even the surface, even the texture. है ना? So there are multiple applications. What you will do? You will write few of them. Please write applications like navigation, comma, how navigation, time and height they can measure very precisely, comma, geological exploration, comma, medical imaging, comma, medical imaging, comma, biological processes, दिस विल सी इन बायोटेक, बायोलॉजिकल प्रोसेसेस, है ना। तो क्वांटम सेंसर आप ऐसे समझो, छोटे छोटे डॉट्स मान लो, ठीक है, एंड दे कैन सेंस ऑलमोस्ट एवरीथिंग। वी हैव सीन टाइम, ग्रेविटी, हाइट, magnetic field, electric field, almost everything they can sense, है ना, and they can sense the things with much more precision. So they have the application in almost everything. Here is where the TRINETRA comes into the picture. If the question is coming, this quantum sensors could be used in which of the following? Almost all, ठीक है, because they can sense almost everything with the utmost precision, high precision, है ना, ठीक है। चलो, you do one thing, you write these four terms at the bottom, दिखाइए एक बार स्पेस, नहीं नहीं, ब्लैंक स्पेस है ना, वहां पे चार टर्म लिखिए, छोड़ दीजिए, टर्म लिख के छोड़ दीजिए। फर्स्ट इज क्वांटम कोहेरेंस एंड डीकोहेरेंस, quantum coherence and decoherence. Just leave two lines and then write quantum noise, quantum noise, then leave two lines and write quantum interference, quantum interference, leave two lines and then write quantum squeezing, लिख के छोड़ दो, we'll deal later with this, these are the terms, ठीक है। I'm giving you 1 minute, just revise the atom quantum, entire quantum. बात नहीं करो यार प्लीज, तो ऐसा लो, these are unconventional topics, let me tell you very frankly. बंद कराऊं सौरभ, ये बंद कर दो। सॉरी, हाँ, can be used in that also, and we are using some quantum clocks in some of the this navic में, in navic on the board, in navic सुना है नाविक, so in navic we are using the quantum clocks, है ना, so that is the use of quantum technology, so that we can improve the precision of the this GPS and all those things. हैवी तो नहीं लग रहा, हमने फाइंडिंग इट हैवी, ठीक है ना, एक दो बार रिवाइज करो, हो जाएगा यार, छोड़ के जाने का ऑप्शन नहीं है, हाँ हाँ हाँ, दोनों में होता है, क्या दिक्कत है। नहीं, क्लासिकल फिजिक्स में टनलिंग इज नॉट पार्ट ऑफ क्लासिकल फिजिक्स, इट इज पार्ट ऑफ दिस क्वांटम फिजिक्स, हाँ सेम है एकदम। हम्म, एक मिनट एक मिनट, हाँ हाँ पहुंचेगा। शी इज आस्किंग QKD में, if the hacker is intervening in between, will the information go to the user? Obviously yes, because there is entanglement, right, so there is a change। तो अगर इधर पहले फादर जा रहे थे, फादर की जगह अगर मम्मी हो गए, तो इधर मम्मी की जगह फादर हो जाएंगे, चेंज हो जाएगा, तो द यूजर विल नो। That doesn't matter, users will know that there is has been any what I can say, intervention, information may or may not change, डन, आगे बढ़े ऑन द बोर्ड नाउ. चलो लास्ट हैवी टॉपिक है बस, फिर बढ़ते हैं. ये जितना हैवी नहीं है. वी आर डन विद द टू डिस्क्रीट टॉपिक्स. दिस इज नॉट दैट हैवी, ये समझ में आएगा अच्छे से. लास्ट टू टॉपिक्स किसको समझ में आए हैं? मतलब किस किस को, एक बार ढंग से हाथ उठा दो, मेरे को पता चलना चाहिए. किसको बिल्कुल मतलब 50% से कम समझ में आए हैं? कोई है? नहीं? ठीक है, चलो फिर ठीक है. ऑन द बोर्ड नाउ, ऑन द बोर्ड. नैनोटेक. ठीक है. व्हाट आई एम सेइंग ऑन द बोर्ड प्लीज. छोटी चीज है बट कंसेप्ट से क्वेश्चन आ गया तो कर नहीं पाओगे फिर. छोटी चीज. लेट्स से दिस इज नथिंग बट अ मेटल. This is nothing but a metal or material. Metal or material. What I am saying, this metal will have some strength. This metal will have some strength. Maybe you are like how easily you are able to break it. This metal will have some conductivity. Done. This metal will have some, let's say conductivity के अलावा optical color or the feature, optical feature. ठीक है. Then apart from this, maybe other thing, reactiveness, reactivity of this metal. Done. What I'm saying, right now this metal will mostly follow the rule of classical mechanics or physics. Okay. But if I take a particle of this material, if I take a particle of this material at a very small size, nano size, this particle will start following the rules of this particle physics. Particle physics. Generally, what happens if this is a metal, if you crush it, let's say this is a powder, the powder. Generally, it happens with the gold. What is the color of the gold? Yellow or golden. When you crush it further, the color changes. क्या हो जाता है? Red. And when you crush it further, the color changes. And when you crush it further, the size of 10 to power minus 9 or below that, ठीक है, the color further changes. Again, this will be termed as the powder, but at the nano scale. So what is happening at the nano scale? The optical properties of this material is changing. क्या कलर है उसका, वो चेंज हो जा रहा है. The more you reduce the size, the optical properties are changing. Because right now what will happen, see, whenever the particle is getting very small, or the material is being crushed into a very small particles, now these particles will individually will either this particle will individually emit the lights, and when they will individually emit the lights, the individual lights will be nothing but the entire color of the powder. Are you getting my point? ठीक है. So what I'm trying to make a point is, in nanotechnology, when you go at the nano scale, the ideology is the size is reducing. The size is reducing. Apart from this, there is a term which is surface area. The area of the surface. Let's say the area of this surface is this height into this. When you're crushing it, the same metal is crushed, the surface area will increase, because now each particle will have the entire surface. अभी इस केस में क्या हो रहा है? Whatsoever is the this inside वाला particles are not able to interact at all. So what is happening? Now entire particle, whatsoever is present in the entire metal, is able to interact. So the surface area will be higher. समझ रहे हो? If I make the powder of this pen, as of now the surface is this बाहर वाला surface, but then if you will calculate the surface, you have to calculate the surface of every particle, this particle, all the outside particles also, and all the inside particles also. So fundamentally the surface area is increasing. And when this happens, there is a phenomena of chemistry that if the surface area increases, generally the reactivity increase. Okay. You have to understand this, that these three things, the outcomes, these three outcomes will have some positives, and will have some negatives. Positives like we have seen quantum dots, right? Positive like improved strength, positive like improved conductivity, right? Positives. But there will be negatives also. What could be the negatives? From the small size you have to, from the higher reactivity you have to, what could be negatives? Right, see, if the size is very small, you can inhale it, right? So generally this leads to higher toxicity because it is more reactive, and this also lead to bioaccumulation like phenomena. So there are some positives also, there are some negatives also. Positives will be derived from this because all these properties will start changing at nano size, and that is nothing but the nanotechnology exactly. Okay, so in your copy, in your notes, please write, in your notes please write nano scale, सॉरी नैनो क्या लिखा है ऊपर, स्केल, राइट? अंडर दैट नैनो स्केल प्लीज राइट 10 to the power 9 minus 9 meter, 10 to the power minus 9 meter. This or smaller than this is nano scale. Done. Then you write what will happen, size will decrease, surface area will increase, and this will lead to more radicals. Radicals are small ions, because you are breaking it into parts, there will be more ions oozing out. देखा था हमने, let's say electrons हो गए, कुछ protons हो गए, they will ooze out because you are breaking it, you are crushing it. So radicals will increase. So the radicals are increasing, what will happen, the reactivity will generally increase, not always, generally the reactivity will generally increase. Done. Now in your document there will be some positive and negative, that what are the positives and negatives of the this nanoparticles. Please write positives. मैकेनिकल स्ट्रेंथ क्या हो जाएगा, बढ़ सकती है. So see, these are the possibilities. There is not always कि always the mechanical strength will increase, but when I say the surface area and size, this is always, ठीक है, this will always increase, है ना? These are general, generally this will happen, mechanical strength will increase. Then you write thermal properties, heat conducting, है ना? So they may increase also, they may decrease also. When it is saying it is resistance, and when it is increasing, it is nothing but conductivity. Both can happen. Done. Then you write electrical conductivity, will generally increase. Why? Why the electrical conductivity will generally increase? Because of these free radicals. So there are the ions already available, and the charge is nothing but movement of ions, right? देखेंगे अभी, रुक जाओ, कोई टेंशन नहीं है, बैटरीज में देखेंगे how the electric current flows, है ना? So what I'm saying, electrical conductivity will generally increase, generally. Done. Then you write optical changes. Optical is nothing but color changes. Then you write improved reactivity. Example you write of aluminium. Example you write of aluminium. Improved reactivity. Example you write of aluminium. On the board. See, generally aluminium, if you consider as a metal, is not that reactive. But when I talk about the aluminium powder, it is highly reactive. Highly reactive. Done? Because of this phenomena. You know? Now we write the negatives, please. And UPSC has asked the question. Let me tell you very frankly on this. UPSC has asked the question. Okay? Change in color. For example, let's say I told you the gold is nothing in the yellow or the golden color. But when you crush it, it may change to red or maybe sometimes black and brown also. Done? It depends on the size. Then write negatives. Please write toxicity increase because they're freely moving into the environment, right? Please write bioaccumulation. Bioaccumulation. And then you write can enter food chain. Can enter food chain. On the board now. On the board. Generally, nanoparticles are differentiated on two categories, either on the basis of the dimensions or on the basis of the materials they are made of. For example, there could be carbon based nanoparticles or the carbon based nano material, or there could be non-carbon based nanomaterial, inorganic nanomaterials. So material wala is fine, that you will be able to figure out. What is my point of concern is the dimensions, that how the nanoparticles are segregated or the bifurcated on the front of dimensions. Although I don't think UPSC will ask this, but समझ लो क्या हो रहा है, ठीक है? Let's say if I talk about a single nanoparticle. Single nanoparticle. If I'm using that single nanoparticle for any activity, what you can do? Let's say a single nanoparticle is acting as a camera for you. You send it to your blood to take the imaging of the inner vessels. Single nanoparticle. That single nanoparticle may act as a, let's say, drug delivery carrier. So you are attaching your drug with that, and that is carrying the drug in your body. Nano missiles, we will see. Okay. So what I'm saying, if I'm talking about a single particle, quantum dots, single particle. So we're talking about a single quantum dot. It is nothing but 0 dimension quantum particle. Okay. After this, it comes. Let me tell you first 2D. So what I'm saying, these quantum dots I am arranging into a sheet, and I'm making a single layer sheet. Single layer of nano particles are arranged into a sheet. Paper dena. This. So all of them are nothing but the nanoparticles. And what is happening here? 2 dimensions it is nano. In this dimension and in this dimension it is nano. Sorry. ठीक है. So in 2 dimensions it is nano. So when this sheet I am considering, So this is nothing but 2D, right? 2D. Now I'm folding this sheet like this. I'm folding this sheet like this. Done. And when I'm folding this sheet like this, and what I'm making a nano tube, and this is nano only in one dimension. So we have 1D, which is nothing but a nano tubes. Nano tubes. And we have 2 dimensions, which are nothing but the sheets, also known as nano membranes, nano layers. Okay, 2 dimensions. Then we have 3D. For example, let's say if I take my bottle, water bottle, if I fill this with nanoparticles, there is nothing but a 3D. Generally, there are optical cables. In that optical cables, what you are doing, you are making a nanotube. Those nanotubes you are twisting together, and then you are making an optical cable. So when you are doing it, you are making anything which is usable. That is nothing but 3D use of nanotech. For example, the same tubes, if I twist them together and I make a single, what I can say, the wire, that is nothing but a 3D. If I fill all the nanoparticles in this bottle, that is nothing but a again 3D. ठीक है, 3 dimensional. इतनी बात क्लियर हुई? बस इसे लिख लेते हैं. प्लीज राइट, नोट दिखाइए. Nanomaterial, please write based upon dimension. Make an arrow and write based upon dimension. Based upon dimension. First you write 0D, 0D, 0D. Quantum particles, or sorry, nanoparticles, 0D, nanoparticles like quantum dot, like quantum dot. 1D, 1D. So nano in one dimension, 1D, nano in one dimension. Example, example, nanotubes, nanotubes. 2D, 2D, nano in, nano in 2 dimensions. Example, nanomembranes, nanomembranes, comma, graphene. We'll see, graphene, graphene. ठीक है, चलो. Then you write 3D, 3D, 3D. Please write 3D. Examples include, and examples include fibers, fibers, comma, pillars, pillars. So nanofillars. For example, nanoparticles are used for the 3D printing. Right? We'll see a video. 3D printing, we use the nanoparticles to make a 3D structure. That is nothing but a 3D use of nano. Done? Okay. Now, done. Now, we have to read 3 things on the board. From your exam point of view, You have to read the nano in three aspects. Okay. First is carbon and nano. Second, you have to read fertilizer, nano and fertilizers. And third, you have to read emerging nanotech, current affairs part. Emerging nanotech. For example, in your document, you'll find the technologies like nano missiles, nanoport technologies, nano bubble technologies, all those things. Done. First, let's understand the use of nano along with carbon. So, what is happening fundamentally? You are using the carbon atoms either to make the carbon sheets. When you're making those carbon sheets, those are nothing but the graphene sheets or graphene sheets. Done. Now, when you're rolling them, for example, if this is a sheet, when I am rolling it, it is nothing but carbon nano tube. Done. And then there are the 3D structures like fullerenes, which we will see under this heading. Up. Can you tell me what could be the utility of this sheet, nano sheet? Not carbon, any nano sheet. It could act as a protector. Let's say if I want to do the coating on this floor, I can use the nano coating so that it can act as a protector. Okay. Protector against maybe the dust, maybe the heat, maybe the electricity. It depends on the nanomaterial whatever I am using. Na? Nano coating. This tube, what could be the use of the tube? Nanotube, very small size tube. First of all, it could be used for the transportation. First thing. What you can transport through this nanotube? If the electrical conductivity is there, you can transport the electricity. If this tube can carry something inside, you can transport maybe the medicine or anything. Understand, the size is very small, so this can go into the body and into your veins also. So it can help to transport all those things into your body. Okay. So that is nothing but the use of nanotech through the membranes, through the tubes, etc. etc. We will write first. Please likhiye. Please write graphene. Please write 1 atom thick layer graphene. 1 atom thick layer. Next point. 2D allotrope of carbon. 2D allotrope. So it is 2-dimensional allotrope of carbon. Then you write chemically stable and inert. Inert matlab it do not react that easily. Chemically stable and inert. Next point. Strongest material. This you might have heard also, na? Graphene, strongest material. Then high thermal and electrical conductivity. High thermal and electrical conductivity. Done. Then write transparent. Transparent. Acha, what will happen if you make the layers of these graphene? 3D graphene is known as graphite. Okay, so if you make the layers of this graphene, the pencil which you use, the nib, graphite. Okay, not important for us. Next you write. Next is carbon nanotubes. Please write rolled up sheets of graphene. So carbon nanotubes are nothing but rolled up sheets. So if this is a sheet of graphene, if I roll it up, this is nothing but carbon nanotube. Rolled up sheets of graphene. Next you write can be single walled or multi-walled. Can be single walled or multi-walled. So I can use, see, I can take one graphene sheet and make a nanotube, or I can take multiple sheets and I can make a nanotube. So this is multi-walled, WALLED, walled, multi-walled. कोई बात नहीं, कोई बात नहीं, ठीक है, मल्टी वॉल्ड, सिंगल वॉल्ड और मल्टी वॉल्ड. Then then you write next point, high strength comma electrical conductivity next you write lightweight, next you write lightweight. Next is fullerenes. Fullerenes. Please write allotrope of carbon, allotrope of carbon comma unstable in nature, unstable in nature, okay. Please write comma unstable nature हो गया, comma except C60, except C60, C minus का साइन 60, हाँ, except C60. So fullerenes are nothing but again the allotropes of carbon, unstable है, except this is known as Buckminster, BUCK, Buck, MINSTR, Buckminster fullerene C60. नथिंग मतलब 3D फॉर्म है ना, 3D allotrope of carbon. Then last you write carbon nanofluorettes, carbon nanofluorettes. Please write this is from the current affairs now, carbon nanofluorettes. हाँ, पूरा ही 3D है fluorenes, carbon nanofluorettes, carbon nanofluorettes. Please write developed by IIT Bombay, developed by IIT Bombay, developed by IIT Bombay. Next write can absorb sunlight to generate heat, can absorb sunlight to generate heat. So see what this nanofluorettes are doing. They are absorbing the sunlight. Sunlight is nothing but photons, energy. They are absorbing that energy, and through the nanoparticles, nanofluorettes, they are converting into the heat. Okay, heat. This is nothing but nanofluorettes. अब these are made up of carbons. Last you write made only of carbons, made only of carbons. Done. फर्टिलाइजर छोड़ते हैं, इधर आते हैं इमर्जिंग टेक पे. अभी फर्टिलाइजर पे आएंगे, तो फर्टिलाइजर फैक्चुअल है, कुछ नहीं उसमें. इमर्जिंग नैनोटेक, फर्स्ट टेक्नोलॉजी गिवन इन योर नोट्स इज nanopore technology. Nanopore technology. See what is happening? What is happening on the board here, please? You understand pores? Okay. Let's say this is a sheet. What I have done, I have made a pore here. If you can see this, I have made a pore here. Whenever I'm making pass the particles through this pore, whenever I'm making particles pass through this pore, I am able to tell the nature of these particles. This is nanopore technology. Up where we are using it. For example, in biotech, we will read about the DNA sequencing or DNA sequence, how the DNA is arranged within the body. Done. So what is happening? The protein thread is sent through this hole, and whenever the protein thread is sent through this hole, the protein thread is encoded. What is the sequence in that protein thread of DNA? यार इतना तो पता होगा यार, DNA sequence है ना, ठीक है, amino acids and all those things. Although we'll see that in the next class, but थोड़ा basic I'm expecting. So whenever you are sending that protein thread out of this nano pore, small pore, this pore is able to tell me the sequence of the amino acids within these protein thread, and that is nothing but the nanopore technology. Please write. Please write. Nanoholes in thin membranes, comma, capable to detect changes in biomolecules when passed through it, okay. So next point, under this only, next point, it enables real time sequencing of DNA slash RNA. So nanopore technology, what is happening? There are pores, biomolecules are passing through that pores. Whatever is the nature of that biomolecules are being detected by those pores, and when the detection is being done, they are able to tell the sequence of the DNA or the RNA. DNA RNA is nothing but a component of the biomolecule. Now these are biomolecules also. Okay. Second technology is nanobubble technology. Bubble is related to what? Bubble कहाँ होता है? पानी में, water. So this technology is related to water, and in water also this technology is related to water treatment. So what is happening? Whatsoever the particles which are making the water dirty, what you are doing, you are using the nanobubble technologies. So in the bubbles, they are trapping the dust or the particles, and they are helping to clean the water. Okay? So this is nothing but a water treatment technology. Please write. Advanced technology for enhancing water quality. Next point. Nanobubbles attract and break down Nanobubbles attract and break down impurities in water. ठीक है. Next technology is, sorry, atomic stenciling. Okay. इससे पहले ना ऊपर जगह है. To do one thing, above nanopore whatsoever is the space, above nanopore whatsoever is the space, पर 2-3 लाइन का स्पेस है, मेक अ स्ट्रिक मार्क एंड राइट नैनो मिसिल्स. वो नहीं है इसमें. आई एम राइटिंग इट हियर. नैनो मिसिल्स. नैनो मिसिल्स. हेडिंग दे दी ऑन द बोर्ड नाउ. See, for example, this is a nanoparticle. What is happening? If you want to send in your body something which is, let's say, fat insoluble, fat insoluble. What is happening? This nano missile is having dual feature. On one side, it is having some arms, which is making it hydrophobic. Hydrophobic. Hydrophobic is water repelling or fear of water. Water repelling or fear of water. The other side of this is hydrophilic. This means this is water loving, water attractive. So let's say if I want to transport anything in my blood, and in that blood I understand one thing here, let's say the drug is water insoluble drug. What I will do, I will attach that drug, water insoluble hai, so I will attach that drug to this side, water loving, water insoluble. Okay, I will attach that drug to the this side. Hydrophobic hai, water repelling hai, water insoluble, so this will be attracted to this side. I will attach the drug to this side, and this nano missile I will send in the body through the blood, so that it can transport this drug at the targeted location. So nano missiles are nothing but small scale particles having both hydrophobic and hydrophilic nature or the properties. So whatsoever I want to send in the body, be it, let's say, something which is of the other variety, I will attach it here, I will send it with the nano missile, so it will deliver the drug to the body, because it has both the properties hydrophilic and hydrophobic, where the drugs can be attached. If the drug is of this variety, I will attach it here. If the drug is of this variety, I will attach it here, and I will send it to the nano missiles. ठीक है? Please write. These are structures. These are structures with both. अभी तुम्हें ड्रग डिलीवरी अगर समझ में नहीं आ रही, लेट मी कंप्लीट द हेल्थ एंड बायोटेक, देन कुछ नहीं, सब समझ में आएगा. ठीक है? once you have to understand protein and all those things, fat soluble, fat insoluble, all those things. ठीक है? अभी लिख लो बस. तो क्या लिखा हमने? these are the structures with both hydrophilic and hydrophobic ends, comma, making it useful in drug delivery, Okay, next is stenciling. Okay, Let's first write, then I will explain. Please write. Please write. Nanofabrication technology. Nanofabrication technology under atomic stenciling. You have to write nanofabrication technology helping to apply polymer patches polymer patches or mask over the gold nanoparticles over the gold nanoparticles. ठीक है. Let's decode the word first. Atomic stenciling. What is stenciling? Coating, painting, giving shape. Stenciling you are doing. Okay. See what is happening on the board here. Please. If this is a particle, I'm making a big size. Is a particle. If I am able to coat just half of this particle with, let's say, black color or green color, let's say, if I am able to coat half of this particle with green color, don't you think I will be again changing the property of the particle? Because the optical property now especially will be directed by this green color, coated green color. Okay. So what is happening at the atomic level? If I am able to coat this gold nanoparticle, that is nothing but atomic stenciling. And the idea is very simple, that if I am able to alter the shape, size and color of these gold nanoparticles or the nanoparticles through the atomic stenciling, I can further change the properties of the nanoparticles. Maybe with the help of atomic stenciling, what I am doing, I am changing the shape. Earlier it was circle, I made it square like this, or I have just cut the halves of it. This is nothing but atomic stenciling, that you are doing the painting, cutting and all those things at the atomic level of the particles, nanoparticles, especially the gold nanoparticles. Why? Because further we can alter the properties, we can control it better. I just wanted the, let's say, this nanoparticle, half of this to reflect the light. So what I will do? I will do the black coating on the other part. Then only half will reflect the light. Okay. So if I want to control it much better with much more precision, I am maybe doing the painting or maybe cutting or maybe doing all those activities, and that is nothing but atomic stenciling. Done? Sorted? Next is nanozymes. Array simple. Please write nanozymes. These are nanoscale enzymes these are nanoscale enzymes, comma with much better enzymic properties. In bracket you can write chemical reactions. Okay, enzymes we will do in the biotech. ठीक है. Write the applications. Write the applications. इसी में लिखना है applications of nano enzymes used in biosensing, comma targeted therapy and diagnosis. You write diagnosis. See, enzymes we have not done, we will be doing it in the biotech. So protein structures होते हैं, we will see. ठीक है, अभी लिख लो बस. Those who have studied will be able to relate, others fine, कोई दिक्कत नहीं. बचा nano sensors. So nano sensors, please write. Nano sensors, nanoscale devices to detect physical, chemical, biological information. हमने क्या लिखा अभी? नैनो प्लीज राइट. फिजिकल में एक एग्जांपल दे दो. कौन सी फिजिकल प्रॉपर्टी? टेम्परेचर, प्रेशर. So in physical, make a arrow and write like temperature and pressure. So these nano sensors can measure temperature and pressure. Chemical में toxicity, pH, very good. So they can detect pH levels, they can detect the toxicity. Biological में detect virus, comma DNA, etc. Mark one star to the nano sensors application. So whatever we have written here, this is important. ठीक है. Physical में temperature, pressure, all those things. The applications of nano sensors are important. Done. ठीक है. Now we are left with urea and nanotechnology. So nano fertilizers, nano urea, nano depth. ठीक है. अब on the board बेटा. On the board please. On the board. Nanotech इतना difficult नहीं है. You have to just remember the nano types of nanotechnology. ठीक है. That is it. And the properties, positives, negatives. That is it. On the board please. Now you will see ना different types of nano names in the what I can say nano के साथ names in the news. For example, nano fiber. So generally now the material is being made by using the nano fabrics. So what will happen again? Again, you might have seen the advertisements of the shirts which can be cleaned, which do not get dirty. Water उस पे stick नहीं होता है, water is flowing down. You might have seen some videos, random videos, है ना? ठीक है. So what is happening when you are using the nanoparticles in the material and you are making the fiber? That particular fabric is nothing but nano fabric or nano fiber. ठीक है. And you have to understand the properties will change. ठीक है. Maybe the color, maybe the strength, maybe the let's say हाइड्रोफिलिक था तो हाइड्रोफोबिक हो जाएगा, और मे बी अदर एक्टिविटीज. ठीक है. बुलेट प्रूफ एक्सेट्रा, है ना. सेकंड इज नैनो ड्रोन्स. So right now the drones which are being which you can see from your naked eyes, okay, which you will see in the defense tech. Now there are other types of drones, nano drones. So if you want to send the camera which is almost not visible to your this this enemies, so you can use the nano drones. Then multiple use cases. Then your nano solar cell also. Again I told you nano fluorates, yaad hai? So what is happening? Sunlight into heat. So nano solar cells. Then we have some nano pesticides also. Fertilizers, pesticides will cover together in the current affairs वाला part. अभी आप ये छोड़ देंगे. These three are important from the current affair point of view. This I will cover later. ठीक है? Then there could be other nano uh, nano types, मतलब कुछ भी हो सकता है ना in news. What you will do? Just write here whatever you're getting from maybe some test, maybe some material. Just keep on writing here. इधर ही side में डंडा like make a vertical what I can say the mark and write है ना. अब this space from now until April, whatsoever the current affairs, I will help you to write here from the nanotechnology. This space will use for the current affairs. Done. So we are almost done with the nano technology ka basics and some important current affairs. I have left the fertilizers which I will cover in the current affairs. Done. Now I will give you 5 minutes. Just revise these 3 pages. I will give you 5 minutes. Just revise these 3 pages. उठो मत यार, कंप्लीट करने दो, ब्रेक कुछ नहीं होता. Other things will keep on becoming easy, है ना. At the smallest level, if you further want to change the properties, you use the atomic stenciling. आपने उसको कवरिंग दे दी, आपने उसको काट दिया, आपने उसकी शेप चेंज कर दी, and that is being done through the very much high precision. We will see further this in the current affairs. हाँ हाँ, you are having a better control over that particle. आप उसकी शेप चेंज कर पा रहे हो, कलर चेंज कर पा रहे हो, है ना. तो फॉर एग्जाम्पल गोल्ड का पार्टिकल एट नैनो स्केल, यू आर नॉट एबल टू कोट इट, बहुत छोटा है, ठीक है. सो यू आर यूजिंग एटॉमिक स्टेंसिलिंग टू कोट इट, कोटिंग कर पा रहे हैं हम. I'm opening the timer. We'll resume when the timer is over. Hello. बहुत ज़्यादा वैसी हो रखी है ना. Last 1 minute. Please revise. चलो. Nuclear tech, very important topic. Nuclear tech. First of all, what do we mean by nuclear tech? मतलब क्या है? हाँ? What do we mean by nuclear tech? See, we have seen a term. Wait, we have seen the term nuclear force. Have we seen this term? Nuclear force are of two types: strong, weak. Strong by gluons and weak by W and Z bosons. So whenever the nuclear force is broken, the force is broken, this broken force will be converted into heat or energy, because of the simple principle that the energy should be conserved. If earlier the energy was there to bind them together, but now they are not binded, so that energy will be released in form of heat or some other sort of energy. And this released energy is nothing but nuclear energy. Nuclear energy. Ab, understand one thing. See, the ideology is very simple. This nuclear tech is nothing but a subset of particle physics only, or because the energy which you are getting is out of the energy of the subatomic particles or the elementary particles only. Okay? When the bond is getting broken, that broken bond is being converted into heat or energy. अब these are of two types. These are of two types. First is nuclear fission. So what is happening in nuclear fission? You are hitting the atom. This atom is broken into two smaller atoms. Now when this is happening, there is some energy which is being released. Second category is nuclear fusion. What you are doing, you are breaking the bonds. What you are doing, you are breaking the internal bonds and then you are compressing them to make a new atom. ठीक है? इस atom के internal bonds you are breaking, you are compressing to make a new atom. You are fusing them together. So if you are fusing them together, two small atoms are coming together to make a big atom. If that is the process, again this big atom will be out, and then in the process the energy will be out. The energy is simply coming from the strong nuclear forces and the weak nuclear forces. Done. Particle physics वाली concept है ना. अब let's keep this aside. We have to give the almost the 1 hour to this nuclear. This is fission. You have to give the 1 hour to this. Let's understand what is happening in nuclear fusion. So what is happening? You are combining two hydrogen atoms, you are bringing them closer, and then you are making a new what I can say, the atom. First of all, can they combine together that easily? What is happening? Two small atoms, let's say I am saying the hydrogen atom. First of all, you should understand they cannot combine this easily. First reason is because they are stable. They are stable. They don't want to react with anything else. They are stable, independently stable. Second reason is the same concept which I told you in the particle physics. The electrons are going around them, and then proton is trying to come near to them. Like electron is trying to come near to the electron. पास में आना चाह रहे हैं. There will be a repulsion. Same charge is coming nearby each other. There will be a repulsion. See, this atom is trying to combine to this atom, so there will be some electron. These electrons will repel each other. So generally they cannot combine that easily. First of all, they are stable. Secondly, the electrons will repel each other. So if you want to combine them, the first condition should be that you should bring them under high pressure. You should pressurize them, both of them together. High pressure लगाना पड़ेगा. Second, you have to keep them under high temperature. And third thing, very important, very important, that if you want to initiate this, you have to give some high initial energy. Otherwise you cannot overcome these two things. First of all, both are stable. Second, electrons will repel each other. So you need very high initial energy. Please understand this, please. तो ये तुम करके चले जाते हो जनरली, उसमें भी सिर्फ न्यूक्लियर रिएक्टर्स कहाँ कौन सा अवेलेबल है. Understand this technology, nuclear fusion. What is happening? Two atoms are coming together. I am saying two atoms will not come together. Why? Because of the simple reason, both are stable and both have the electron layer, so they will repel each other. So if you want to bring them closer, you have to put them under the high pressure, high temperature, and then some energy you have to give from the outside. Further, more energy और थोड़ी energy कि भाई आके fuse हो जाओ. You have to fuse now. So once they fuse, again when they are fusing, there will be release of energy. Same from the strong nuclear force and the weak nuclear force. Okay. And if they are able to fuse, they will make bigger atom, helium. That is what you see in the stars. In stars, what is the reaction? The reaction is fusion. Small hydrogen gas which is in abundance in the universe, that hydrogen gas is combining together to give you the energy of the sun, the energy because of which all we are alive, the light which is there, the electricity which is there. This is a subset of that energy only, है ना? The energy which is coming from the sun, it is being transformed, right? Everything which is operating right now, it is nothing but transformed energy out of sun only. Sun is the only source of energy right now for us. Okay. So what is happening in sun? This is the phenomena going from billions of years. Okay. And that phenomena is giving the energy. This energy is coming to the earth. But in sun there is high pressure, high temperature, plasma state में है पूरा, done. Then high initial energy, big bang and all those things. Okay. High initial energy was there. So the reaction started and that led to the current energy which is continuous. The helium atoms are coming together, fusing together and bringing the, these hydrogen atoms are coming together, fusing together and bringing the helium and the energy. Make sense? Up. I will ask you a question now. Is it possible on earth that easily? Is it possible on earth that easily? See, right now we have some experiments going on, but the ideology is, understand one thing, I want you to focus upon here, that I have to give some energy, then I am getting some energy. I have to give some energy, then I am getting some energy. So this we have experimented on earth. I have written the reactors. This we have experimented on earth, but ideology is that the net energy output is still less than 1. For example, if I'm giving this setup 1 joule of energy, I'm just getting zero point 0.7 joule here or zero point 0.5 joule here. Is it of any use to me? Why? Because energy which I'm giving to start this is much more than energy released. So we are not able to bypass that what I can say na Q is equals to 1. We are not able to get this phenomena as net energy positive phenomena. The energy which I am giving to this phenomena is much more higher right now on the earth than the energy which I am getting out of this phenomena of fusion. Up. This fusion on earth is being undertaken under some experiments. One of them is uh, ITER, International Thermonuclear Experiment Reactor. See, all these reactors are nothing but tokamak. Tokamak, you might have heard this term tokamak. These tokamak is nothing but an artificial sun. So what we are trying to do is we are trying to mimic the sun-like phenomena on earth, and the equipment in which it is being done is nothing but tokamak. The reactor in which we are mimicking it is nothing but a tokamak. Now currently on earth we have so many reactors which are mimicking the sun, which are mimicking this nuclear fusion, which are doing the nuclear fusion. One of them is International Thermonuclear Experiment Reactor. The others are this JT60 SA, Jet Facility, HS70, and East. East is nothing but tokamak of China, also known by the nickname of artificial sun. You have to understand this. All of them are functioning on the nuclear fusion, where small atoms are brought together. In order to bring them together, you have to give them initial energy. Ab you will get some energy, but if the energy which you are getting is not higher than the energy you are giving, it is of no use to you, right? And this nuclear fusion needs high pressure, high temperature, and high initial energy in the starting. So right now this is not viable. This is not viable. But if we are able to achieve this, understand, if we are able to achieve this, if we are able to make Q, why not viable? Because Q is less than 1. That is, whatever energy I am getting upon whatever energy I am investing is less than 1. If I am giving 1, I am just getting 0.7 joule in return. But if I am able to make this Q greater than 1, net positive, the target of ITER is to make Q to 10. Q to 10. That if I am giving 1 joule, I should get 10 joule of energy. Just understand this. If you are able to do this, there is nothing which is radioactive which is being used in the starting or as a fuel. You are just using the simple hydrogen atoms. Are you getting a point? So this is seen as the future, what I can say, the source of energy on earth. But the difficulty which we are facing is that the Q is less than 1. The initial energy which is required to fuse them together is much more higher than the energy which I am getting out of it. ठीक है, भूलोगे तो नहीं, the entire concept of nuclear fusion. Now come to the nuclear fission. अब चलो पहले इतना लिख लेते हैं, पहले ये लिख लेते हैं, न्यूक्लियर फ्यूजन लिख लेते हैं, ठीक है, then we'll come to nuclear fission. So just show me the document. So what? Under what? Make this diagram. Under what? Make this diagram. A small atom is forming a big atom. Example you can write of hydrogen. Big atom like helium. Done. You will make similar 3 arrows. Please write high temperature. So you need to give it, you need to put it to the high temperature, high pressure, and high initial energy. You have to impart some initial energy also. Done. Now on the right hand side you will see the challenges. Okay, so in challenges please write currently challenges, second column challenges. Currently net energy output is और currently energy output, net हटा दो वहां से, currently energy output is, net हटा दो, just remove the net word. Currently energy output is lower than the energy given, comma, making it infeasible, making it infeasible. Advantages, what will the advantage? No radioactivity is fine, then no greenhouse emissions, right? There's no greenhouse emissions. So please write the advantages. Advantages, please write no greenhouse gases, no greenhouse gases. Second, no long lived radioactive waste. See, right now in nuclear power plants you have the radioactive waste, है ना, which is being disposed on some of the, let's say, poorer countries, or maybe on their coastlands. It has to be dumped, it has to be buried deep. But in this we are not having no long lived, we are having no long lived radioactive waste. Then you write almost limitless fuel, almost limitless fuel, almost limitless fuel, comma, providing renewable like energy, renewable like energy. Done. Then you write about the tokamak. Please write about the tokamak. Tokamak, right? This is the machine. This is the machine for for the machine for controlled thermonuclear fusion, controlled thermonuclear fusion. Done. Now whatsoever you will be writing after tokamak are nothing but the types of tokamak. So all these are nothing but the machines for the nuclear fusion, controlled nuclear fusion, types of tokamak. You write ITER, International Thermonuclear Experimental Reactor. Please write tokamak device, tokamak device, comma, comma, under construction in France, not constructed yet, right? Large Hadron Collider कहाँ था? Geneva, Switzerland. So I was confusing that with this. मेरे मुंह से फ्रांस निकल रहा था, ठीक है? So this is in France, that is in Geneva, Switzerland, and this is not constructed yet. This is under construction, right? A future tokamak device. Now, is India part of this? Please, right? UPSC asked a direct MCQ on this, PYQ on this, and in prelims, this ITER is for. The answer was nuclear fusion. Simple. इतना simple question पूछा UPSC ने, ठीक है? So please write, India is a member. India is a member along with US, Russia, China, Japan, EU, and Korea. South Korea. कोरिया में नॉर्थ तो हो ही नहीं सकता ना, साउथ ही होगा, साउथ कोरिया. Please write. Please write. India formally. You have ITR India ना? हाँ, ITR India में लिखिए प्लीज. India formally joined ITER in 2005. ITER in 2005. Then right. ITER is an agency under Institute for Plasma Research. Under Institute for Plasma Research. कहाँ है ये? Not important. गुजरात अहमदाबाद, comma under Department of Atomic Energy. Under Department of Atomic Energy. So Department of Atomic Energy किस मिनिस्ट्री के अंडर आता है? It is not under any ministry. It is under the PMO. ठीक है, directly under the PMO. चलो. So we have seen the ITR India. Now you have the some other tokamaks written. Please read them. It is in your document. I've given the sufficient information. Please read. You have JT60SA. So this is in Japan. World's biggest experimental nuclear fusion reactor. Joint initiative of UN, Japan. Then JET facility. Again, this is also a tokamak by UK. Then you have HS70. This is China's. This is world's first high temperature superconducting tokamak device. Then इतना याद कर लो बस, चाइना का है, tokamak है. Then East experimental advanced superconducting tokamak. This is by China and referred as artificial sun. Done. So this is nothing but an image from the, चल रही है या नहीं चल रही? अच्छा वेट यार. ऑन द बोर्ड नाउ, देख लो बस, याद रह जाएगा. दिस इज almost a cylindrical equipment. Done. If you can see this is nothing but the plasma which you see generally in the sun's energy. So what you are doing, you are heating the things at a very high temperature, at a very high pressure, then externally you are giving it an energy to ensure that whatever the hydrogen atoms revolving here, they are binded together, and to produce what? Energy. Again I have told you, as of now non feasible in nature, okay? But we are doing the experiments. है ना? This is nothing but the plasma, ठीक है? So, अब इससे पहले let's understand fission. ठीक है? Now understand the nuclear fission. Fusion में fuse हो रहा है, बस इतना याद रखना. Two atoms are fusing together. In fission, what is happening? An atom is splitted into small atoms. Done. For example, let's say if there is an atom. This atom has some number of protons and this atom has some number of neutrons. Let's say at this stage, if this atom is getting another neutron from the outside, this atom will be readily splitted into two small atoms because they are much more stable in nature. समझो, if this atom is radioactive, unstable or maybe fissile, ठीक है, fissile है, so this is unstable, this atom is unstable, and once I have given one more neutron to this atom, this can easily split into two stable atoms, and this process is nothing but the nuclear fission. So unstable atom, because I am giving it extra neutron, this is getting split into two stable atoms. Now if the splitting is there, what will happen? Strong nuclear force, weak nuclear force will lead to the nuclear energy. So that nuclear energy is coming out. Up. In this, what is extra? The extra is these neutrons. Although neutrons and the neutrinos were evolving, see, this will also evolve the neutrinos, this will also evolve the neutrinos, because both are having the decays, right? Here the neutrons or the neutrinos were not of that importance, but in this case the extra coming neutrons, they are important, and the reason is very simple, because these extra 3 neutrons will now hit some other atom and will release 3 more neutrons. This neutron will hit some other atom and will release 3 other neutrons. This neutron will hit another some atom and will release 3 other neutrons, along with 2 stable atoms, 2 stable atoms, 2 stable atoms, along with energy, 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 energy. Now this will have 3 more, what I can say, the neutrons. So this will further hit the other atoms, and this is nothing but the chain reaction. ठीक है? तो आपने क्या किया? You brought the neutrons from the outside, you made them hit to the unstable atom. This unstable atom is splitting into 2 stable atoms and 3 more neutrinos. Just for the simple calculations कि भैया neutrons का total composition should be same at the end, है ना? Let's say this is having neutrons. This is having 220 neutrons. You are giving one more neutron from the outside. Small atom. This is having, let's say, 108, and this is having, let's say, 108 neutrons, and this is having, let's say, 110 neutrons. This is another atom, this is another atom, color are different, ठीक है? Another atom, both अलग अलग atom है. इसके पास 108 है, इसके पास 110 है न्यूट्रॉन. प्रोटॉन भी होंगे कुछ. प्रोटॉन will also split. Maybe there are, let's say, 300 protons, or let's say, 225 protons, they will also split. Maybe this is having now 115 protons, so this will have 110 protons. Protons में we are not concerned. Let's focus on the neutrons. 108, 110, कितना हो गया? 218. 218 plus these 3, 221. 220 plus 1. Although not important for you, let me tell you very frankly. You have to understand this. If one neutron is hitting the atom, that atom is subdividing into 2 small atoms. Since the breaking of bond will be there into the picture, so there is a release of energy, and that release of energy, along with that there are 3 neutrons also, 3 to 4 or many, like it depends on whatever fuel you are using in between. on the board. Tell me, if I am having some sort of fuel here, fuel is nothing but, let's say, generally known by the name of yellow cake in nuclear power plants. Okay, what I'm saying, let's say this is 10 grams or 1 kg of the fuel. If I started the reaction, I sent one neutrino, I made that neutrino hit that fuel. Don't you think in a very small time my entire fuel can be blasted, combusted? Because neutrinos are multiplying, और this neutrinos निकल रहा है मुंह से, neutrons, ठीक है, please take it. Neutrons are multiplying at a much faster scale. 1 से 3 है, तो 3 से कितने होंगे? 9. That 9 will lead to 27, that 27 will lead to 81 and so on. The reaction is very fast. If the reaction is not controlled, what will happen? It may blast. It may blast because the uncontrolled energy in large amount may lead to the blast. So first of all, whatsoever phenomena is happening, it should be controlled, right? It should be controlled. Up. Control generally through two ways. First, you are controlling it to the rods, that you are stopping it all together. You are controlling it through the rods. You are stopping it all together. Now no more neutrinos will come inside. You are stopping the entire reaction. You are removing the fuel from that particular chamber. Second control is, you are slowing down. Oh, wait. What you are doing? You are slowing down the speed of neutrons, and this is being done through moderators in the chamber. Okay, these two things. Up. What is happening? Understand this way. Understand this way. On the board, this is a chamber. Okay. Let's say these are the rods, and here you have kept your fuel, cake, fuel. When you're picking up this rod, the fuel is exposed to the neutrinos and the reaction will start. Now what you did, you send some moderators here. Some fluid is there, moderator is there. That moderator will slow down the process. We need it for the electricity. We don't want to blast everything. We need for the electricity. So please give the energy in the slow form. Moderators. You have filled this with the moderator. These are the rods. When you want to completely shut the reaction, what you will do? You will put the rods down. Are you getting my point? These moderators are there to slow down the reaction. Itna clear hua? Ab, whenever the reaction is there, what will happen? The reaction will generate the energy. So this energy should be absorbed. The energy should be absorbed. This energy is absorbed in another material inside this chamber, known with the name of coolant. What I am trying to keep a thing in front of you, that this nuclear power plant has three things: rods, moderator, coolant. Rod controls the reaction entire of it. It will either stop or will initiate. Moderator slow downs the process, and coolant transfers the energy. For example, coolant, you assume it like a water. What is happening? The water is there, the water will heat, water will move out. Continuous running water which is being heated, moved out, heating, moved out, heated, moved out of energy. Okay, coolant hai. So coolant will transfer the energy, and that energy will now be used further for other purposes. See on the board now. See this now. Okay, this is a nuclear reactor. It will not control, it will be blast, right? In tiny amount of mass. Generally, mass is converting into energy because of the breaking of the bonds. These are the rods which you were seeing in the between. So neutron will come and will hit this. This will split, and this is the chain reaction which is starting. है ना? So wait. See, these are the rods. Done. इधर fuel रखा होगा. So what is happening? Inside the rod, reaction is happening. This is the moderator in the coolant ka chamber. This coolant will transfer the energy in form of heat. For example, running water is there. This will be heated. This will be transferred further now. Let's say into this chamber. Into this chamber. So what this is happening? This is boiling water. This boiling water will generate what? Steam. Okay. Now whenever the steam is going, the steam will be rotating what? A fan. This fan is rotated, and that is how the entire electricity is being produced, right? So from this chamber, whatever is the coolant will transfer the heat. That heat will maybe the water, heated water will lead to the steam. Steam will go to the fans, turbines. Turbines will be rotated to produce the electricity. Done. So this is nothing but the nuclear fission. What you will write here, please write. Make this what होगा इधर, what लिखें. Saurabh. So neutron hitting the fuel or the atom, breaking into two small atoms. They may be different, leading to further more neutrons, which will further hit the other atoms and leading to energy. क्या हो गया? So this is controlled and moderated through this rods, moderator, coolant. Please write rods में. लिख लिया? Rods में please write. Make an arrow and write rods. Help to control chain reaction. Rods help to control chain reaction. So what you will do? You will stop the exposure of this fuel. You will bring the rods down. If the fuel is not exposed, it will not be consumed. The chain reaction will stop. आप इन rods को नीचे ले आओगे. And you want the fuel to be exposed, you will take the rods up. Done. Then you write moderator. Moderator. Slow down. Slow down the reaction. Slow down the reaction for limited energy, right? We don't want it to blast. We want limited energy. So it will slow down the reaction. Slow down the reaction for limited energy. Then coolant, COOLANT, coolant. Please write. Responsible to transfer heat from responsible to transfer heat from reactor to turbine. So this is the reactor, and I showed you the video. The thing should go until the turbine, right? from reactor to turbine. चलो next is in your document क्या है अगला, nuclear energy. Okay, okay, look on the board. Even for example, if you want to reduce the exposure, आपको इतनी बड़ा केक है आपका, if you want to just expose let's say 20%, so you will stop your rods until there. Not important, टेंशन मत लो. न्यूक्लियर फ्यूजन में तुम करना भी नहीं चाहते हो ना उसमें, तो यू वांट बिग एनर्जी. अभी एनर्जी कम है उसमें, इतनी उसमें कोई जरूरत नहीं है. ठीक है, उसमें कोई जरूरत नहीं है. यू जस्ट लिमिट योर फ्यूल, वॉट एवर हाइड्रोजन यू आर प्रोवाइडिंग, यू लिमिट इट, कंट्रोल हो जाएगा. ही इज आस्किंग ऑन द बोर्ड यार, ही इज आस्किंग डोंट वी नीड द कंट्रोल इन द न्यूक्लियर फ्यूजन. द आइडिया इज दैट यू आर सप्लाइंग द हाइड्रोजन, यू स्टॉप द सप्लाई ऑफ द हाइड्रोजन, इट विल बी कंट्रोल्ड. आपने हाइड्रोजन डाला ना उसमें, तभी तो फ्यूजन हो रहा है. You control the supply. This we will see further in the fuel cells also, where you are controlling the supply of the hydrogen, it is controlled. हो ही नहीं रहा ना, combustion नहीं हो रहा. Okay, on the board, nuclear energy, we have to see at two levels. First of all, see, now I am going into some stats, not relevant with science and fact, but लिख लेते हैं अभी. Stats are at global level. Right now, nuclear energy is second largest energy source, providing 9% of the world's energy. But when I talk about the India में nuclear energy is fifth largest energy source, responsible for almost 3% of our energy requirement, and in words it is 8,800 megawatt. ठीक है, and all these stats are important. UPSC has already asked for the solar energy, the stats, India's ranking, so this is important for us. Done. अब पहले इतना लिख लो. What you will do, to your notes, न्यूक्लियर एनर्जी में ना यू विल डिवाइड दिस इनटू टू हाफ्स, पहले ऊपर ग्लोबल, नीचे इंडिया. ठीक है, तो ग्लोबल में जस्ट राइट सेकंड एनर्जी, सेकंड लार्जेस्ट एनर्जी सोर्स. सॉरी, टोटल इफ आई एम नॉट रॉन्ग, आफ्टर हाइड्रो पावर, लार्जेस्ट इज हाइड्रो पावर. ये टोटल ही है. ठीक है, एज फार एज आई नो, है ना. ठीक है, देख लो, सेकंड लार्जेस्ट एनर्जी सोर्स 9%. इफ यू वांट टू क्रॉस चेक जस्ट गूगल. ठीक है, देन यू राइट top nuclear energy producers, top nuclear energy producers or nuclear electricity producers, you write nuclear electricity producers. Who might be at the top? US, please write US. So this is US, then you write US के बाद China, then France. वैसे only if you are able to remember US, the things will be sorted, है ना. Since India is not into the picture, UPSC will be just concerned about the top. ठीक है, US इतना बहुत है. Then we will see fuels, right? Fuels for the nuclear this fission, है ना. Under that fuels we will read about the uranium, we will read about the plutonium, we will read about the thorium, right? So as of now you have to write the uranium deposits, which is the where we found the largest deposits of the uranium. Please write uranium deposits, make semicolon. Who is having the largest deposits? Kazakhstan. Please write uranium deposits, uranium deposits, semicolon. Please write Kazakhstan. Highest is Kazakhstan, then Namibia, Namibia, then Canada, Namibia, then Canada, sorry, then Australia, then Australia. I'm not talking about who is able to extract the highest. There Australia comes at the front. I'm saying who has the most of the deposits. Most of the deposits are with the Kazakhstan. Okay. Now you write India and please write fifth largest energy source. Fifth largest energy source in bracket 3% of total. 3% of total. So whatsoever is the electricity production, 3% of it is nuclear energy. Then you write please this 8800 megawatt. So right now nuclear energy production is 8800 megawatt, right? Then we have to write the goal. What is the goal? Please write the goal. Oh. We have the goal for the this renewable energy, right? So please write part of target of 100 gigawatt by 2047. अच्छा नहीं, this 100 gigawatt is nuclear energy का target. ठीक है, तो क्या लिखा हमने, दिख रही है, एक बार चेंज करना पड़ेगा. गोल टारगेट ऑफ पार्ट ऑफ हटा दो बस, टारगेट ऑफ 100 gigawatt by 2047 through nuclear energy, ठीक है. Then next is nuclear reactors and plants. कितने reactors हैं हमारे पास? Functional I am talking. There are around 25 nuclear reactors in 7 locations. ठीक है, 7 to 8 locations. So please write currently 25 nuclear reactors functional at 7 locations. Currently 25 nuclear reactors functional at 7 locations. You might have heard about Tarapur, Rawatbhata, है ना, then this Kudankulam, Kalapakkam, है ना, Kakrapar, Kaiga, ठीक है. So all these are nothing but the places of nuclear power plants. At one place we are having maybe 4 reactors, 5 reactors. Board पे देखो, you have written 7 places. 7 places having how many reactors? 25. So at a single place we can see somewhere we have 2 reactors, somewhere we are having 6 reactors. So at a single place there are multiple reactors. देखा था ना वो? We saw the video. So those multiple reactors at a single place, there are multiple reactors. So right now total reactors functional in India are around 24 to 25 at 7 different locations. Done. So next we have uranium. Please write uranium. Uranium. Please write found in Kudappa Basin. CUDDAPAH. CUDDA Kudappa PAH पे Kudappa Basin. कहाँ है? in bracket you write Andhra Pradesh, AP, comma Mahadek Basin. The spelling is MAHADEK, Mahadek Basin. कहाँ है? वेरी गुड, मेघालय. महादेक बेसिन, MAHADEK, MAHADEK, महादेक बेसिन, मेघालय, comma and in areas of Rajasthan, comma Karnataka, comma Chhattisgarh, comma झारखंड. झारखंड के ब्रैकेट में राइट जादूगुड़ा, JADUJUDA, जादूगुड़ा. इन जादूगुड़ा, JADU जादू, GUDA गुड़ा, जादूगुड़ा. In, so this is the area in Jharkhand, Jadugoda in Singhbum belt. Please write SINGH. This we will see again in geography. With Kuldeep sir you will see all these belts. SINGH, Singh, BHUM, Singhbum belt. सुना है? कितने लोगों ने सिंघभूम बेल्ट के बारे में सुना है? बहुत लोगों ने. ठीक है, चलो. Now look at the board. On the board now, please. This is the most painful part now. Fuels. देखो बोर्ड पे. We have to see 3 types of nuclear fuels. First is uranium. Second is plutonium. And third is thorium. Those who have not done this topic earlier, I want you to increase your attention level in the class now. थोड़ा सा attention बढ़ा लीजिए, है ना? See, when you're putting an element in this chamber, you cannot put anything. You have to put the fissile material, the material which is radioactive in nature, the material which when given the neutron can be further decayed into 2 other different atoms. You cannot keep any material here. You have to keep the fissile material in this cake, right? Up. What I'm saying, there is one form of uranium. Generally, there are 2 forms of uranium. Uranium 235 and uranium 238. Then we have one more form, uranium 233, which I will come to later. आऊंगा मैं इस पे, ठीक है? Understand now, when I talk about this uranium 235, this uranium 235 is highly fissile in nature. That is, this is my fuel. अब uranium 238 is not fissile. This is not a fuel, but is fertile. Fertile means that whatever are the free electrons, it will consume and will keep those electrons with itself. What I'm saying, it will consume those free electrons and will keep those free electrons with itself. That is, can consume electron बोल रहा हूँ यार, neutron, ठीक है, sorry, can consume neutron. Tell me, if a material is consuming a neutron, I'm taking now to very basics, I mean from where I started the class, what will change? Atomic number or atomic mass? If the atomic mass is changing, the chemical property will change or no? No. open the notes now. Go to the very first page. Go to the top right corner. कवाड़ा मत करो. Atomic number will have the, if the atomic number is same, the chemical properties will same. अब अच्छा wait, मैंने गलता कर दिया. What I am saying, in this case the chemical properties will change now. Sorry, थक गया मैं अभी. एक चाय बोल दे. नहीं ब्रेक नहीं यार, नहीं होगा कंप्लीट यार, मानो ना प्लीज, मानो मानो मानो. एक्स्ट्रा क्लास कितनी लेंगे? मेरे को साइंस एंड टेक में तो एटलीस्ट नहीं लेनी. बेटा सौरभ एक चाय बोल दे मेरे लिए बस. देखो what I'm saying, the chemical property will change, है ना, because the atomic mass is changing, the chemical property will change. So these uranium 239 with the new chemical properties will turn into plutonium 239. Plutonium 239. And again this plutonium 239, this is not naturally available. Not naturally available. But this is fissile in nature. But this is fissile in nature. थोड़ी सी रामायण है, सुन लो. I will conclude. पहले सुन लो. This is fissile in nature. Now let's come to this thorium. Before coming to thorium, let's come back to this. Two types of uranium is there. Uranium 235, 238. Whatever you find in the rocks, you find the uranium. This uranium have both 235 and 238. Out of these two, only this is fissile, this is not fissile. So what is happening right now? Naturally in uranium, this is just 0.9%, 0.7%, 0.9 or 0.7, 0.7%. This is just 0.7%. And this uranium 238 is 99.3%. So what is happening? If you are keeping a 1 kg of cake, in that 1 kg, only this 0.7% of 1 kg will react and will give you the energy. Up. If you are enriching it, what is the process? Centrifugation. Okay? Centrifuge technology. What I'm saying, if you are increasing the percentage of this in the uranium, that is nothing but the uranium enrichment, that you are increasing the U235. For example, let's say in case of enrichment, the uranium 235, if this is 6 to 8%, the uranium 235 could be 20%, or the uranium 235 could be, let's say, 70%. Are you getting my point? In these scenarios, whenever the uranium is getting enriched, that means uranium 235 is increasing. The weightage of uranium 235 is increasing. What you are doing, you are removing the U38. ये तुम रुक जाओ, तुम हमें U38 नहीं चाहिए. Will increase the U235. What will happen if the cake is enriched? It will be more explosive. It will be more explosive. Out of this, if you are using normal uranium, you are able to use just 0.7% of it. So it is controlled. But if you are enriching it, it will become almost uncontrolled in nature. So what happens? As you keep on enriching the uranium, this moves towards the bomb. And the lowest form, the normal enriched levels of 6%, 8%, 4%, 5%, 3% is used to produce the electricity. Okay. This is the concept of the uranium. Why I am teaching you plutonium, why I am teaching you thorium, is just because of the stages of nuclear power plants in India. Right now, we have 3-stage nuclear power plant program in India. We have 3-stage nuclear power plant program in India. Right now, most of the power plants across the India are pressurized water reactors or pressurized heavy water reactors, PHWRs. What is happening in those stage 1, stage 2, stage 3? You have to understand one thing. You have to understand one thing. In these stage 1 pressurized heavy water reactors, what you are using? You are using the uranium or enriched uranium. You are not using a pure form of 235 or pure form of all those things. You are using the uranium or you are using the enriched uranium, maybe 6% of 235. Done. What we are planning? We are planning from this stage to second stage, which will be using this fast breeder reactors, and then they will be using the plutonium which is coming out as a byproduct of this. If you remember, when this will go or this will merge with one of the neutron, what we are getting? Plutonium 235, and this plutonium 235 is fissile. So what this stage 2 is saying, that whatever is the byproduct of this, which is plutonium 239, we will use this as fuel, MOX fuel. We will come to this. MOX fuel नाम दिया जाता है, ठीक है? We'll use this as a fuel. Up further, the things are not envisioned until here. The things are envisioned further. For the thorium based power plants. Now you have to understand this very carefully. क्यों ऐसा? Right now, if I talk about India, this thorium in India is almost 25% of world's reserves. ठीक है? 25% of world's reserve, and this is nothing but largest in the world. Please understand this. There is nothing but largest in the world. The only difficulty is in thorium based nuclear power plant, this thorium is converted into uranium 233, which then further convert into sometimes plutonium, sometimes into other fissile materials. But the ideology is from there to reach until here. This is almost unreactive in nature, stable in nature. Thorium is unstable in nature, but thorium can be converted into uranium 233, which I wrote here, as a byproduct. This uranium 233 can be further used for the other fissile material. So there are the phenomena, decays, beta decays. So the cycle is there, maybe of 2 weeks, of 3 weeks. एक और neutron निकल के चला जाएगा, so it will be now fissile. It will decay automatically. So out of those phenomena, this uranium 233 can be converted into fissile material. So what I am trying to make a point is, India is trying to reach from this stage and this stage to the third stage, and the only logic is we are trying to achieve this stage because we are having the 25% of world's reserves of thorium. And if we are able to crack this, let me tell you right now, China is the leader in this. China has made the world's first thorium based salt melting nuclear power plant in Gobi desert. ठीक है, पहली बार उन्होंने अभी बनाया है. But India is trying to achieve this, है ना, thorium based nuclear this power plant. Reactors we are making, we are in the experimental stage, but we have not made the first fully commercially viable power plant. Difference समझ रहे हो? Reactor experimental है, but nuclear power plant उसका बनाना is something which we have not achieved yet, even not the China, है ना. So thorium based power plants we are planning to move until this stage. Now on the board please, last 5 seconds or 7 seconds. If I talk about this stage, this is fully operational, and maximum of the power plants are प्रेशराइज heavy water reactors. ठीक है, maximum. If I say out of all, which is the highest? PHWRs are the highest. This fast breeder reactors, we have just made a single, and which we have made a prototype. Only one in Tamil Nadu. कहाँ पे? Kudankulam. ठीक है. We have achieved this also. But right now we are at the prototype stage. That is where you will see in the news prototype fast breeder reactor. We have made just one out of it. And कहाँ जाना है हमें? यहाँ तक. So we have to make this commercially viable, commercially feasible. We have to make some, let's say 5 plants, 6 plants. Then we will reach to the third stage. So अभी थोड़ा दूर है. So right now if I make a statement, if I frame a statement in your exam that India has achieved all the stages of its nuclear power plant. No. Right now we are at the second stage. In that also we have just made a single nuclear reactor which is prototype in Tamil Nadu at Kudankulam. ठीक है, which we are saying with the name of this PFBR, prototype fast breeder reactor. Prototype है, एक बनाया है अभी, and is working fine, है ना. So these are the stages of nuclear power plants in India. Just show me your notes. Let me dictate now. Okay, uranium, please write. Uranium में please write. Uranium, please write. Available naturally. Uranium in fuels. Fuels में, sorry, न्यूक्लियर फ्यूल है ना, उसमें यूरेनियम सेमीकोलन प्लीज राइट. अकर नेचुरली एज U235 in bracket you will write 0.7%, comma fissile U235 in bracket you will write 0.7%, comma fissile. So if this is fissile, this can be used as a bracket close and bracket close and U238 uranium 238 uranium 238. अरे यार इतनी देर से हैंडआउट की वजह से क्लास डिले हो चल रही है. चलो ठीक है, यूरेनियम 238 in bracket राइट 99.7%, 99.3%, comma fertile, comma fertile, ठीक है, comma can consume neutron or can combine with neutron, fertile, comma can combine with neutron to make Pu minus 239. So it will take one neutron, so 238 से it will go to Pu. It will change the chemical property. Pu minus 239 यार 239. ठीक है. Okay. Now second point here in uranium. In uranium, please write increasing. Second point, increasing the percentage of uranium is increasing the percentage of U235. Increasing the percentage of U235 in uranium is known as enrichment. Is known as enrichment in bracket 6 to 8%. 6 to 8% enriched uranium is sufficient to produce nuclear energy. Is sufficient to produce nuclear energy in bracket right electricity. Beyond this it will be converting towards the bomb. ठीक है, nuclear bomb. So it may explode, है ना. Enrichment बहुत ज़्यादा है. Then second is plutonium. Please write in plutonium. Do not occur naturally. Do not occur naturally, comma. Yeah, make second point. Second point. Fissile material released as byproduct of fissile material released as byproduct of first stage in bracket you write P H W Rs. बहुत है इतना, बहुत है. P H W Rs. फुल फॉर्म आई विल टेल, डोंट वरी, बस शॉर्ट में लिखो, बहुत है. ठीक है, बाई प्रोडक्ट इन PHW Rs. थर्ड राइट थोरियम. Please write thorium. Please write derived from monazite, MONAZITE, monazite sand, SAND sand. ये मिट्टी होती है एक टाइप की जिससे थोरियम मिलता है. सेकंड पॉइंट यू राइट India contains world's largest thorium reserves. In bracket you write 25%. Third point, found on India's east and west coast. Along with some inner areas like Bihar. Last point in this जगह है last point in this. Please write it is a fertile material and upon decay can be converted into U233, and all these words are important. U233, U235, U238, Pu239 and here thorium. ठीक है, so अब U233 make a write in the bracket of U233. U233 is fissile. Please write in bracket fissile, so it can be used as a fuel. Fissile. Now any doubt in this to anyone? Shall I brief again? नहीं आ गया समझ में? Fertile is now he's asking what do I mean by fertile and fissile. Fissile is something which I can directly use as a fuel. Fertile is that can be converted to some fissile material. For example, if I have this on the board, this is, see, I'm marking it with pink. This is fissile. this is fissile and this is fissile. And if I talk about the fertile, I will mark this with blue. This is fertile, then this is fertile. It can be converted into something which is a fissile material, which can be directly used as a fuel. ठीक है. So thorium upon some decays, the reactions are not important at all for you. कितने दिन में होता है, कैसे होता है, not important. Thorium on decay, beta decay होता है, can be converted into uranium 233, which is fissile, which can be used. Done? Got it? चलो. Sorry. वो पूरी रिएक्शन फिर देखनी पड़ेगी यार, क्यों जाना है उसमें, जाने दो. ठीक है. चलें आगे. बीटा डिके होता है एक्चुअली, उसकी वजह से आता है, बट फायदा नहीं है उसमें जाने का. बीटा डिके है ना. चलो. तो थोरियम फ्यूल साइकिल इन फ्रंट ऑफ मी, दोज हु वांट टू सी कैन सी. I explained everything just for the calculation, like for the much better understanding on the board. If you want to see, you see. Otherwise, I explained everything. The beauty of thorium is, I mean, the power loop will not be curtailed. The same thing can be used again and again. That's the beauty of thorium. This video will explain. Raw material into power in thorium fuel cycle. It all starts with a simple ingredient, thorium 232, a natural and abundant isotope. When it engages a neutron, a magical transformation begins. This turns into thorium 233. Next, through beta decay, it turns into protactinium 233. Not important for you at all. This is what I am explaining. ठीक है, ये आपके लिए important नहीं है किससे क्या ट्रांसफॉर्मेशन हो रहा है. Just see that ultimately thorium will be converted into what? Uranium 233. Then this will be converted into uranium 233. So these are chain of reactions. Sometimes beta decay, sometimes through the neutron. Finally, what you are getting uranium 230. That is important, nothing else. कैसे हुआ, क्यों हुआ, not important. What are the in between components, not important at all. This uranium 233 is the best fission capability and energy output you can find as the thorium fuel cycle progresses. See, this thorium is converting into this into this into uranium. Uranium is giving the energy to the heavy water. This converting, getting like again converting to thorium, and this cycle is never ending now. Not important. ठीक है. हाँ. Fertile means it can be converted into a fissile material by giving a neutron or maybe beta decay. Beta decay बाद में देखेंगे. U233, ठीक है, it is a fissile material. हाँ, can be used as a fuel. In thorium, that has to be used as a fuel, है ना? But this activity from here to here, this is challenging right now for India. How we have to reach from here to here. ठीक है? चलो. Now I'm starting a very important part, nuclear reactors in India. ठीक है? On the board. On the board. Whenever we are dealing with the nuclear reactors, on the board beta, whenever we are dealing with the nuclear reactors, things which will make the nuclear reactor different are threefold. Three things will make them different. First and most prominent is the fuel. First and most important, the fuel. In the first stage, which fuel we are using? Natural uranium or the enriched uranium. फर्स्ट स्टेज याद है, that will lead to the plutonium 239. 235 this 235 will be converted into energy, but whatever is 238 it will be converted into plutonium 239. That plutonium 239, which is a byproduct, can be further used in the stage 2 for the energy generation. ठीक है, plutonium 239 which is a byproduct can be used in the energy generation. So first is fuel. So in stage 1 we are having uranium, stage 2 you are having MOX fuel in which plutonium is a part, stage 3 you are having thorium which will be converted into uranium 233. Thorium cannot be used directly as a fuel, let me tell you, thorium has to convert into uranium 233. ठीक है, इतनी क्लैरिटी आ रही है, इससे ज्यादा क्लियर तुम्हें कहीं नहीं मिलेगा, पूरे इंटरनेट पे देख लेना, because this is the most confusing part, है ना. You should have the whatever names I have given you on your tips, the things will be crystal clear. ठीक है, so stage 1 the fuel is uranium, stage 2 MOX fuel in which plutonium 239 is a part, stage 3 thorium which will be converted into uranium 233. ठीक है, in stage 1 also, although it is using uranium, natural uranium, only 235 will be consumed, but 238 will be converted into plutonium 239. Then there are other micro players. Those micro players are moderators and coolants. So if I'm changing the moderators and the coolants, then what I'm doing, I'm changing the reactor sometimes. ठीक है, for example, earlier the very first prototype was these two, pressurized water reactor and the boiling water reactor. You can see both of them are having water as the coolant, water as the coolant, and the moderator also. Water is the moderator, water is the coolant in these reactors. Now what is happening, water heats up very quickly, water heats up very quickly, so you have to get a very huge amount of water to keep them operating. That is why you will see majority of the power plants are located near the sea or the ocean, either near the ocean. So we have 3 power plants, the other 3 places near the ocean, Kudankulam, this Kalapakkam, and one I think is Tarapur. I think these 3 are on the sea, this oceans, the rest are along the sea. Koi sea, let for example this Narora कौन सी river पे, Ganga, so they will see some river, ठीक है, flowing. Why? Because they need continuous flowing, big supply of good supply of water, boiling water plants. Now in order to reduce some sort of supply of this water, what we are using a pressurized heavy water reactors. So we are replacing one of the moderator or the coolant with the heavy water. Heavy water is D2O, H2O से we have heavy water D2, another form of water, so that you need not to use that much of water, that much quantity of water. See, this is also pressurized, this is also pressurized. What is changed? Heavy water. This is heavy water, this is normal water. So right now in India, stage 1, these two are not counted. We started our journey, we started our very first power plant, if I am not wrong, with the boiling power reactor, boiling power water reactor, and this we established at Tarapur, Maharashtra. ठीक है, boiling water reactor. But then we gradually upgraded, we established the first India's pressurized heavy water reactor at Rawat Bhata, Rajasthan, ठीक है, 1960s. So what I'm saying, these were nothing but the things of past before 1965. But although operating, some of the reactors are operating here also, some of the reactors are operating on this phenomena also. But India की जो stage है, like the program, the nuclear program of India has 3 stages. First is this, second is fast feeder reactor, and third is ठीक है, कोई बात नहीं, लास्ट इज एडवांस. आपके नोट्स में जस्ट टर्न योर पेज, it is advanced heavy water reactor. So these are nothing but the thorium based reactors. So understand, is boiling water reactor a part of India's stage of nuclear reactors? No, it's not a part. This is the stage 1, stage 2, stage 3. These are other types of nuclear reactors which are not part of India's stage 1, stage 2 or stage 3 or the India's stage of nuclear power reactors. ठीक है, पहले वाले पावर प्लांट्स इस पे कुछ बने हुए हैं, This is what you have to keep in mind. What you will do now, you will write the fuel. So in bracket, please write fuel used, pressurized water reactor. So this is not part of 3-stage program. So this is not part of 3-stage program. मैंने bracket में लिखा भी हुआ है. Please write the fuel used. Fuel used, please write enriched uranium. Enriched uranium. Moderator क्या होगा? Ordinary water. Coolant, ordinary water. Ordinary water. Okay. Then you write boiling water reactor. Just repeat the same. Enriched uranium, ordinary water, ordinary water. Coolant, moderator also, both are same. Ordinary water, ordinary water. Enriched uranium, ordinary water, ordinary water. Now can someone explain me the difference between these two? If everything these three are same, what is the difference? See, in boiling water, what is happening? This is the chamber. The water is boiling in the chamber itself. The water is boiling in the chamber itself. But if you can feel, if you can sense that the water is boiling in the chamber, it may lead to the explosion sometimes. It may lead to the explosion sometimes, right? What is happening? The more evolved version of this boiling water was the pressurized water reactors. That you give a lot of pressure on this reactor from the above side so that the temperature do not increase. If you increase the pressure now, the temperature will not increase. This is the basic physics. Okay? If you are keeping it under very high pressure, the temperature of this chamber will not increase. Okay? PV is equals to nRT करके, how many of engineers you might have heard? Thermodynamics, right? So if the pressure is high, the temperature will not increase then. It will be compensated. So whenever you are increasing the pressure such that the temperature inside this, आगे नहीं, either in the chamber is not increasing, that is nothing but the pressurized water reactor. Fuel is same, coolant is same, moderator is same. It's just in pressurized water reactor, you are increasing the pressure in the middle chamber so that the temperature do not rise. Now the story starts from here. This is a part of India's 3-stage nuclear power program. First is PHWRs. PHWRs, pressurized heavy water reactors. Please write the fuel. It is uranium. So not to use even the enriched uranium, you use the simple uranium. Please write fuel uranium. Uranium. So natural uranium can be used directly. Done. Then write the moderator, heavy water, and the coolant, heavy water. Moderator and coolant both are heavy water. Whatsoever is lying in the chamber, see, either you fill this with the heavy water. The whatever is filled in the heavy this chamber is acting as a moderator also, is acting as a coolant also, heavy water. Done. Chalo. Now what you will do, beta? In pressurized, पहला वाला जाओ, pressurized water reactors PWR में, the right column, please write, column खाली रह गया ना, box खाली रह गया. In that box, please write operational at Kudankulam. Operational at Kudankulam. स्पेलिंग बताऊं? अरे यार इतना बेसिक तो पढ़ के आना चाहिए. लिखो, अब इसकी भी स्पेलिंग लिख लो. KUDAN. अरे तो बहुत न्यूज में रहते हैं सारे. कुदनकुलम, कलापक्कम, कायगा, ककरापर. कुदनकुलम, KUDAN, KULAM, कुदनकुलम. कुदनकुलम, ऑपरेशनल एट कुदनकुलम न्यूक्लियर पावर प्लांट. कहाँ है? तमिलनाडु. इन ब्रैकेट यू राइट TN, तमिलनाडु. खुदन कुलम. Now nuclear power plant you will write NPP forward. आगे जहाँ भी आप लिखेंगे आप you will write NPP, है ना, nuclear power plant. In boiling water reactor please write operational at Tarapur NPP. Tarapur NPP. कहाँ है तारापुर? In bracket you will write MH Maharashtra. Semicolon. Built by US assistance. So US helped us. Built by US assistance. So if I now frame a statement, consider the following question. Consider the following statement regarding pressurized water reactors, or let's say consider the following statement regarding boiling water reactors. Statement number 1. ध्यान सुनना. Statement number 1. India's 3-stage nuclear power plant comprise of boiling water reactor. No. Second, India do not have any functional boiling power plant right now. False. Okay, so you have one at Tarapur, and let me tell you, this is the first nuclear power plant of India. Commercial. I will make you write. Don't worry. We'll write in the evolution. Okay. Now under PHWRs, please write most prominent in India. So सबसे ज़्यादा अगर nuclear reactors I ask which of the following is the most prominent nuclear reactor in India, it is PHWRs. Stage 1. Pressurized heavy water reactors. So pressurized मतलब inside the chamber the heavy water is not at higher temperature, is not at a boiling point, है ना, because of the high pressure. Then write output. In bracket you write byproduct. Output. In bracket you write byproduct. Keep your pens down now. What is the output of this? Pu239. ठीक है. So first stage का output is plutonium या Pu239. Then you write managed by NPCIL. NPCIL क्या है? Government PSU है for the nuclear power plants. I am making a statement now on the board. Everyone on the board. All the power plants in India are managed by NPCIL. TRINETRA लगाओ. And I will tell you why. This NPCIL is majorly seeing towards stage 1 nuclear power plants. For stage 2, we have made a new body altogether, new PSU altogether. Anyone can tell the name? Bhavini. So there are now 2 PSUs, and there are many PSUs for the nuclear water consider energy. NPCIL is mostly concerned about the first stage or PHWRs. For the second stage, we have another agency with the name Bhavini. We will see. Okay? So all the power reactors are not managed solely by the NPCIL. याद रहेगा? ठीक है. Then write first PHWR. First PHWR constructed at कहाँ हुआ था? मैंने बताया, ये बताओ. रावत भाटा. कहाँ है? In bracket you write RJ. In bracket you write RJ, Rajasthan. रावत भाटा. See, boiling water में we made the first at Tarapur. That was nothing but the first nuclear power plant of India, commercial power plant of India. This is nothing but the first India's pressurized heavy water reactor. ठीक है? This is made with the help of anyone? Please write. Yes. No, with the help of Canada. With help of Canada. ठीक है? It's not Russia, it's Canada. Okay. Then fast breeder reactors. What will the fuel? Please write. Please write. Mixed oxide fuel. MOX. Mixed oxide. MOX. MOX fuel. Mixed oxide fuel. See on the board. This is termed as mixed oxide because you cannot separate the plutonium 239 from the uranium 238. Uranium 238 has converted into plutonium 239. So you have to use the same cake for the fission. है ना? So the same cake contains both plutonium 239 also and uranium 238. So in bracket you write contains both MOX fuel. MOX fuel is nothing but it contains both mixed oxide fuel contains both uranium or U238 U238 and Pu239. And use this. Okay. Please write the moderator. Write no moderator. No moderator. Can anyone give me the reason? नहीं, coolant is liquid sodium, but moderator क्यों नहीं use कर रहे हैं? Because you want the reaction to be faster. Uranium 238 is there. The more the neutrons, they will hit more of the this more the neutrons will hit more of the uranium 238. है ना? So we generally don't use the moderator. So moderator you write no moderator. In coolant you write liquid sodium. In coolant please write liquid sodium. Then come to the last column, last cell. Please write prototype stage. Prototype stage. माइनस का साइन लगा के लिखिए. Only one prototype FBR. Only one prototype FBR is built at Kalapakkam. KALAPA double KAM. Kalapakkam. कहाँ है? Tamil Nadu. So in bracket you can write TN. Tamil Nadu. So in this we have only one right now, and that is also a prototype. ठीक है? Stage 3. Stage 3. So not functional yet, no prototype, nothing. It's just theoretical right now in India. है ना? Please write. Fuel में write thorium 232. Fuel में you write thorium 232 in bracket. So this is not a direct fuel. है ना? This is converted into, in bracket you write converted into U or uranium 233, right? Do not confuse this with 235 and 238. है ना? Then you write moderator, heavy water, moderator, heavy water, coolant, normal water or heavy water, anything we can use. Normal water or heavy water, anything we can use. Normal water or heavy water. Last में you write under development. है ना? This is under development in India. Stage 3 is not functional yet in India. Okay. Now some factual information. Open the page 1 of nuclear technology, page 1, last page, like the pehla wala page 1 of nuclear tech beta, previous page. Here we have the nuclear energy का timeline, है ना. Factual है, I can't help much, it's just you have to write in the notes. Story goes like this. India's first institute related to this research was TIFR, Tata Institute of Fundamental Research, located in Bombay in 1945. Then in 1948 we had the formal, what I can say, the Act, Atomic Energy Act 1948. Then we have the Atomic Energy Commission which was set up. Done. Then 1954 there was an entire Department of Atomic Energy created directly under the PMO. Then we have the APSARA. This is important now. APSARA is nothing but India's first nuclear research reactor. So see, there is not a nuclear power plant. This is a reactor. We are doing some sort of research and all those things. So APSARA is first nuclear research reactor. Then 1969, India's first nuclear power plant, as I told you, was established in Tarapur Atomic Power Station or Tarapur Nuclear Power Plant, and it was nothing but the boiling water reactor. In 1973, at Rawatbhata, our first pressurized heavy water reactor was established. Then 1974, from energy we shifted toward the strategic deterrence or the nuclear this bombs and all those things. Done. Nuclear test. So India's first nuclear test was conducted, although this I will deal in the current affairs, okay, with all NPT and all those things, energies and all those things. India's first nuclear test was conducted with the code name Smiling Buddha Pokhran 1. Then further we had another test in 1998, right, where we declared ourselves as the nuclear weapon state. 1998. Further we did the testing and we declared ourselves as a nuclear power state. So this is the timeline which is important. Please write. Fatapat se write it in your document. So this act set up this. Right now this works under this Department of Atomic this Energy, है ना? This Atomic Energy Commission अभी के लिए this is working under Department of Atomic Energy. Not important but ठीक है. I'm just linking the facts. You make it horizontal like this, है ना? Make it horizontal. ऑनलाइन सब ठीक है. All good. लिख रहे हो अभी, लिख लो. ब्रेक. इनके चाय समोसा का क्या हुआ बेटा? हैं? तेरे साथ टाइम पे आते हैं अभी आजकल? आती है बोले यार चटनी तो घर से लाया कर हाँ एक और मैं बता रहा हूँ प्लीज राइट 1998 लास्ट में लिखिए 1998 1998 आगे वाला बता रहा हूँ मैं these are some facts this Apsara Tarapur Rawat Bhata these three facts you should know दो जगह लिख लिया अब हमने ये facts Tarapur and Rawat Bhata we have written it to at two places right 1998 at the end please write 1998 India declared itself as a India declared itself as a nuclear power state. So we declared ourselves. This we'll see more in IR. Nuclear power state. That we have the nuclear weapons with us. मैम 1998 बस इंडिया न्यूक्लियर वेपन स्टेट बन गया इतनी सी बात है हमने खुद को बोल दिया हम न्यूक्लियर वेपन रखते हैं यार मैं सच बताऊं इससे ज्यादा सिंपल तो साइंस को नहीं कर सकता पूरे फैक्ट्स होते हैं साइंस में बट दैट इज हाउ इट इज आई टोल्ड यू कंसेप्ट्स फैक्ट्स करंट अफेयर्स देन कुछ ना है तो त्रिनेत्र ठीक है साइंस में यू हैव टू रट्टा फायदा फैक्ट्स बट आई एम ट्राइंग टू मेक देम एज सिंपल एज आई कैन लिख लिया लास्ट 30 सेकंड यार देखो वो टहलने निकल जा रहे हैं डॉक्यूमेंट दिखाना क्या क्या बचता है अभी हम्म डन अरे यार चलो in the document you have the space for the India's nuclear reactors right number one factual है अब nothing much is right is right number one तारापुर तारापुर कहाँ है इन ब्रैकेट राइट महाराष्ट्र इन ब्रैकेट राइट महाराष्ट्र मेगा एरोन राइट small arrow mega arrow right first NPP first NPP what the first nuclear reactor Apsara and what the first nuclear power plant Tarapur in there is a difference ठीक है there is a difference okay Apsara अलग है वो nuclear reactor था will make nuclear reactor and when you are using it for the commercial purpose that is the nuclear power plant you are generating the electricity out of it that is was established in Tarapur and what was the type boiling water reactor please write make iron right BWR किसकी असिस्टेंस ली थी प्लीज राइट with US assistance with US assistance second रावत भाटा कहाँ है? राजस्थान. In bracket write RJ, Rajasthan. We have seen the fact. First pressurized heavy water reactor, PHWR, इतना लिखेंगे यहाँ पर. First pressurized heavy water reactor, and this was made with the help of Canada. Please write with the help of Canada. With the help of Canada. Third, you write Kudankulam. 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 कहाँ है? Please write in bracket TN. TN, Tamil Nadu. This is the largest NPP, largest nuclear power plant of India, largest NPP. Then Kudankulam is कौन सा है? फास्ट ब्रीडर है क्या है? It is PWR and PHWR. In this, one reactor is PWR, the other reactors are PHWR. I told you, at one location you may have 4 or 5 reactors. At one location you may have 4 or 5 reactors. One of them is PWR. We wrote it in the PWR. The others are PHWR. ठीक है? Please write made with. किसने असिस्ट किया है? Very good. Made with Russian assistance. Made with Russian assistance. तुम लोग मानते नहीं हो ना? Then you write Kalapakkam. 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 कौन सा है? आंध्र प्रदेश नहीं है, तमिलनाडु है. Kalapakkam, Tamil Nadu. Please write. What is the type? Fast breeder reactor. So it is P prototype. This is known by the name prototype fast breeder reactor. FBR. PFBR. So who has helped in Kalapakkam? Second stage है, किसने help किया? नहीं. This is indigenous. No one has helped us. Please write indigenous. ठीक है, हमने खुद बनाया. Second stage is indigenous to India. And who is handling this? Bhavini. Please write BHABINI. Bhavini. भाविनी के ब्रैकेट में लिखिए PSU. This is a PSU made for this Kalapakkam, है ना? PSU made for this, so that it has some expertise over the second stage of this nuclear reactors. Now, not in news, not major. Please write, just लिख लो इनको. काइगा, KAIGA. काइगा कहाँ है? कर्नाटका. तो काइगा in bracket you write KN. काइगा in bracket you write KAIGA. काइगा. आई एम एक्सपेक्टिंग यू शुड नो एट लीस्ट यार कि कुछ काइगा एग्जिस्ट करता है, इतना तो पता होना चाहिए, है ना? KAIGA. काइगा nuclear power plant. So KAIGA in Karnataka. Just one piece of information I am giving you, that it is around the Kali river. For this power plant, just write the river name, Kali river. I told you na, power plants need water, so some of them will be around the ocean. 3 of the power plants are around the ocean. Those 3 power plants are, do you have a different color pen? Different color pen से just circle 3 power plants. That is 1, 3, 4. Tarapur, Kudankulam, Kalapakkam. 1, 3, 4. These 3 are near the ocean. Rest all of them are nearby the sea or river. The rest all of them are nearby the river, not sea. Okay. So Kaiga is near Kali river. Very good. Then you have Kakra Par. KAKRA PAR, काकरा पर, काकरा पर, की KAKRA, काकरा, जो होता है ना घाघरा गुजरात में, काकरा, ठीक है। हाँ, खाकरा भी होता है, राइट। तो ऐसे याद रख लो इसको, ठीक है, काकरा, घाघरा, खाकरा, खाने वाला होता है एक खाकरा कुछ तो, ठीक है, जो भी है। तो काकरा पर, PAR, दिस इज वेयर, गुजरात, काकरा, याद रखना इसको। काएगा, के फॉर कर्नाटक, के फॉर काएगा, वैसे याद रखो, है ना, के फॉर कर्नाटका, के फॉर काएगा। देन यू राइट नरोरा, नरोरा, नरोरा इन यूपी, वेरी गुड। Narura in UP. Now, if you have extra time, if you want to retain much more information, what you can do for rest 4, for rest 3, एक की रिवर मैंने बता दी, काली फॉर काएगा। For rest 3, you can hunt for the rivers if you have the extra time. Otherwise, let's not bombard our head with the rivers. फालतू की information नहीं रखना, इतनी इंपॉर्टेंट है, मैंने लिखवा दिया, ठीक है। अब if you can see this, there is a space in this column. Right side पे what you have to do, you have to make a map. This is homework. Just ये right side है, there we will make a line like this. We'll make a India's map, है ना। तुम्हारा भी बना दूं, and we will mark all of the nuclear power plants on the map, ठीक है। मेरा मैप कैसे बना है, इसमें देख, ऐसे देख रहे हैं लोग, ठीक है, हो गया। नाउ अगला क्या है, न्यूक्लियर टेक इन अदर फील्ड्स। अब सी before coming to nuclear tech in other fields, what we will do, we will write the terms in nuclear fission, terms used, ठीक है। राइट साइड वाला कॉलम प्लीज राइट फटाफट से। फर्स्ट टर्म इज क्रिटिकलिटी, क्रिटिकलिटी, CRITICA, क्रिटिकलिटी, LITY, CALITY, क्रिटिकलिटी, ठीक है। क्रिटिकलिटी, हैव यू हर्ड अबाउट द क्रिटिकलिटी बीइंग अचीव्ड इन द न्यूक्लियर पावर प्लांट्स? व्हाट डज दैट मीन, हाथ उठा के बताओ किसको पता है। हाँ, so see, whenever in the nuclear power plant, on the board yaar please, whenever the nuclear power plant, the number of neutrons which are coming out is self sufficient to conduct the entire activity, to complete the entire activity, that is nothing but criticality in the nuclear power plants, ठीक है। So please write steady state, steady state nuclear fission, nuclear fission in nuclear reactors, steady state nuclear fission in nuclear reactors. In bracket you write in bracket you write in bracket you write self sustaining, self sustaining chain reaction, self sustaining chain reaction, comma comma neutron loss, neutron loss is compensated by, is compensated by neutron production, is compensated by neutron production. समझ में आ गया ना क्या हो रहा है, कि जितने न्यूट्रॉन्स हम दे रहे हैं और जितने चाहिए आगे के लिए पूरी रिएक्शन को सेल्फ सस्टेन करने के लिए, द एंटायर चेन रिएक्शन टू गेट ऑटोमेटेड इज नथिंग बट द क्रिटिकलिटी, ठीक है। So you will see in news that particular nuclear reactor has achieved the criticality. This nuclear reactor has achieved the criticality. Let me tell you on the board. In some current affairs magazines, random, you will find here this nuclear power plant has achieved the criticality, and then this has achieved, then this has achieved. No need to remember that. No need to remember it. Just remember one thing. What do you understand by the term criticality? This means self-sustaining chain reactions. The number of neutrons which are needed is equal to number of neutrons which are coming out. Okay. Second is becquerel. 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 Semicolon. Please write SI unit of SI unit of SI unit of radioactivity. So you have this kilogram, seconds, right? Or maybe kilometer. Those are nothing but the SI units of measurement. So how you measure the nuclear radioactivity? You measure with this becquerel. Okay, it is similar to kilogram, seconds, hours, minutes, and all those things. SI units. Third is yellow cake. Yellow cake. Please write refined form of yellow cake. Refined form of uranium ore. Refined form of uranium ore. Remember, I was referring to that nuclear fuel as cake. So yellow cake. Whatever is the ore you are keeping at the center is nothing but yellow cake. So you may see this uranium ore. See, ORE, ore. There will be a rod which will be set up. Okay, uranium key. That is being referred here as the uranium ore. ORE. Next you write ये भी लिखी लो fissile material. Fissile material capable of nuclear fission. Capable of nuclear fission. Just write the examples. What are the fissile materials? Please write. We have seen uranium 235. Then we have plutonium 239. Then from thorium you will have uranium 233. So these three will write with commas in bracket. Fissile. Then you will write last fertile. Fertile. Fertile material. Fertile material. Please write which can be converted. Which can be converted into fissile material. Into fissile material. Just give me two examples in bracket. Uranium 238, comma thorium 232, TH 232. ठीक है? Uranium 238, comma thorium 232. Thorium 232 can be converted into uranium 233, and uranium 238 can be converted into plutonium 239. We have seen all of it now. Now what you have to see, beta on the board now. On the board, we have seen that these are some fissile materials which can be used for the nuclear energy, because they are nothing but the radioactive. They can be broken, right? We have the other materials also which are used for the other purposes. Okay? For example, we have some elements of cobalt, है ना, used for the cancer therapy. Okay? So we have some other elements being used for the other purposes. What you will do, you will write that particular metal and then you will write the use case on the left hand box. Left hand mein there is a box na, nuclear tech in other fields, right? So please write first cobalt 60. So write cobalt 60. These are the radioactive metals. Cobalt 60. Right. Radiation treatment. Radiation treatment for cancer. radiation treatment for cancer. Iodine 131. Iodine 131 semicolon treat thyroid cancer. So again a radioactive element. So what will happen? This will go, this will strike with the cancerous cell and will destroy it. Okay, radioactive element है. Iodine 131. Then you write okay, TC 99M. TC 99M. The full name of the metal is technetium. Technetium. Used for medical imaging. Used for medical imaging. Then you might have heard about this radon 222. Radon gas सुना है? So this gas is being emitted from the rooms, the soils. ठीक है, please write radon 222. Please write gas in. So this is also radioactive. This is gas in soil and homes. Gas in soil and homes. Then next you write potassium 40. Potassium 40. Radioactive decay in bananas. Now let me ask you the very complex question. Very complex question. What among the following could be the natural source of neutrinos? First, humans. Second, let's say tree. Third, water. Fourth, banana. All नहीं होगा. You cannot do the radioactive decay. Radioactive element should be there. I told you atoms in themselves have the flavors of neutrinos, not the neutrinos. Flavors हैं. So they will emit the neutrinos, the free neutrinos, upon the decay or in fusion or in fission. ठीक है? So the bananas are natural source of neutrinos. ठीक है? Are you getting this point? You are not the natural source of neutrinos. You cannot emit the कोई decay थोड़ी हो रहा है in your body, right? हाँ, in carbon dating there will be neutrinos, but carbon dating carbon 14 का वो देखेंगे. But right now if I am talking about carbon or trees, carbon 12 I am talking about. ठीक है? Let's not make it complex, है ना? Next you write carbon 14. Carbon 14 used for, so the isotope है ना of carbon, used for carbon dating, to know the life of the things. Carbon dating. ठीक है? चलो. Then please write PET scan. Last नीचे कहीं लिख लो PET scan. Medical term है. Those who are from the medical background, they should know about this PET scan. Please write PET scan. Please write use radioactive traces. Use radioactive traces to detect cancer. to detect cancer. PET scan. Use radioactive traces to detect cancer. Done. Chalo. That is for the day in the this I mean on this topic. No, we are not calling it off. I mean for this topic. These two topics we'll see in the current affairs. Nuclear energy mission and Bharat small reactors or small scale reactors. Done. Let's come to the energy and fuel tech. Again I am giving you 5 minutes. Please revise. ठीक है 5 मिनट है. I will start the fuel. अरे सुन लो यार please. I will start the fuel tech and this energy tech. ठीक है in next 7 minutes I am giving. 7 मिनट बहुत है. 10. ठीक है I am giving you 10 minutes but we'll start. Please come sharp otherwise उड़ जाएगा पूरा. Starting fundamental are not clear. बैटरी और फ्यूल में क्या डिफरेंस है उड़ जाएगा. ठीक है come in next 10 minutes. सौरभ Am I audible? Chalo, we are starting the topic of fuel tech. Very important. Last year you got 2 questions directly from this topic, है ना? Although all the topics are important, you never know कहाँ से क्वेश्चन आएगा कहाँ से नहीं आएगा, ठीक है? अब when I talk about this fuel tech, understand on the board what is the basic requirement of this fuel tech. क्या मिलेगा आपको इससे? What is the basic requirement? Basic requirement is from fuel you will get energy, and one of the form of energy, see, heat is also a form of energy. One of the form of energy is nothing but electricity. Electricity. Done. So from fuel, the ultimate aim is electricity or energy. Energy could be of various forms. For example, let's say it could be potential energy, it could be heat energy, it could be some other types of energy. One of them is nothing but electricity. Now, when I talk about electricity, electricity is nothing but flow of electrons. क्या है electricity? Flow of electrons. So whenever the electrons are moving, this will generate the electricity in the circuit. इतनी बात समझ में आई? Electricity is nothing but flow of electrons. अब I just use the word circuit. ठीक है? For example, these are two chambers, chamber 1, chamber 2, separated by the separators, and then there is some electrolyte in between. Two chambers are there. This is chamber 1 and this is chamber 2. What I'm saying, if from this chamber to this chamber I have connected a circuit like this and until here, if I am able to generate the electrons here, what the electrons will do? Electrons will move through this circuit. This circuit is complete. I mean, maybe there is some bed. चलो पूरा ही ले लेते हैं ऐसे, ठीक है? इधर से there is bulb. There is some bulb. So what will happen? These electrons will start moving through this circuit, and what will happen in the process? This bulb will light up. इतनी बेसिक सी चीज समझ में आई? So the ultimate agenda is through the battery or the fuel or through the fuel tech, what I have to do? I have to move the electrons. Now let me tell you one thing. In order to move these electrons, we have two things with us. First is battery, and second thing is fuel cell. If you are my student, I want you to clearly know the difference between a battery and a fuel cell. Clear difference, conceptual difference should be there in your head. ठीक है? कोई रॉकेट साइंस नहीं है? कितने बच्चों को क्लियर पता है कि यार क्या डिफरेंस होता है? नहीं? So you know the clear difference of battery and a fuel cell. Understand this now. For example, if this is my phone, generally सबको पता होगा इसमें बैटरी है या फ्यूल सेल है? बैटरी है. So what is happening in this? There are same chamber 1, chamber 2. This chamber is known by the name of anode, and this chamber is known by the name of cathode. What is happening right now, sir and ma'am? In the phone's battery, इतना पतली सी होती है फोन के साइज की बैटरी है. So there will be a chamber. Let's say this side is anode, this side is cathode. Then battery है. अब this anode has some metals or maybe carbon, metal or maybe carbon element, graphite, metal or maybe carbon element, generally graphite. What happens? This metal, at anode can or do have the capability in normal conditions, have the capability of oxidation. When I say oxidation, what will happen? These metals will break and these will release free electrons in the circuit. Normally, if my phone is not charging, the anode part of this battery has the capability to go with the oxidation. For you, oxidation is simply nothing but breaking of the metal to release electrons, free electrons. What will happen in normal condition? Just focus here. In normal conditions, these free electrons will move towards the cathode and will give the power or the electricity to my phone. इतनी बात आपको समझ में आई? Now these cathode have some oxides generally of metal, and they undergo reduction. What is happening? Whenever the electrons are released, along with these electrons, see, I am not putting the formulas or the chemical reactions, that will not make any sense at all. No sense for the UPSC at all. I am making the things very crude, and this is important for you. इतना समझ लो बस सारे क्वेश्चंस हो जाएंगे. Anode is there, metal or carbon. It is undergoing the oxidation. In oxidation, electrons are coming out, and in oxidations, some ions are coming out. What will happen? These ions may move in this direction or in this direction in the electrolyte. This is electrolyte. This could be solid, this could be liquid. In my battery, electrolyte will be solid or liquid? Solid. So the ions in my battery will move through the solid electrolyte. In this electrolytes, ions will move. For examples, ions are moving from this direction to this direction. Generally, the ions move from cathode towards anode. Ions and electrons move from anode towards cathode. That is how the things work. Okay. Not important for you. Just understand. These ions will move in the electrolyte, and these electrons will move through the circuit. These electrons moving in the circuit will give you the electricity. And now, what is the role of these ions? Understand this thing. These ions will move to this direction and will make these whatever are the एक और इसमें आएगा metal oxides. So this will make it stable. This will move this side and this make this stable. We'll combine, we'll make some compound which is stable now. Why the ions are coming out? Why the this electrons are coming out? Because whatever was there was unstable in nature. So it will oxidize, it will break, electrons will start moving, ions will attract these from the metal oxides, these ions from this side. ठीक है, ions will move this side, electrons will move this side. इतनी बात clear हुई. अब this is the normal condition when my phone is not charging. My phone is normal. अब what happens in this? This is nothing but a chemical reaction. So out of some chemical reaction, out of some instability in this and this, it started moving this side. Yeah, the ions started moving this side, electrons started moving this side. My circuit is giving the electricity. Now what is happening? Whenever my battery is getting discharged, I am putting a plug into this. And whenever I am putting a plug into this, whatever ions move toward this side, I am forcing them to go back. Whatever ions move this side, I am forcing them to go back, so that my battery is charging back. Again, when I am removing the charger, when I want the electricity, again they will start traveling from this direction and the ions will start traveling in this direction. Okay. Then again I will charge, this will start traveling in this direction, and whatever is the compound, this will be recreated, and this compound will be again unstable in nature. This is nothing but battery. So in battery, again I am explaining, oxidation is going on at this anode, in metal or maybe at carbon. Then at cathode, metal oxides are undergoing reductions, ions are moving in the circuit, and then electrons are moving from anode towards the cathode to make the current flow through the system. This is battery. Now see how the fuel cell will change. How the fuel cell will change. I am using the writing the fuel cell with pink color. Okay. In fuel cell, I will give the fuel from the outside. Generally, let's say the hydrogen. In fuel cell, I will give the hydrogen. At this anode, this hydrogen, let's say, this hydrogen will go to the towards the oxidation, and this will break into hydrogen ions, and the electrons break ho gaya. On this side, I am giving the sufficient supply of oxygen. I am giving the sufficient supply of oxygen. What is happening now? This half of oxygen is combining with hydrogen ion to make the byproduct, which is water or water vapor, H2O. H, again one H, half O. So H2 convert into H plus, and 2 electrons. These 2 electrons will move in the circuit. This 2H plus will combine in the through the electrolyte medium with half O2 to make what? H2O. इतनी बात समझ में आई. Now I'm asking you a question, very simple, plain forward question. If I stop the hydrogen supply in the fuel cell, if I stop the hydrogen supply in the fuel cell, what will happen? Everything will stop. My energy supply will stop. In fuel cell, there is no concept of recharging it. You have to supply the fuel to it, and the fuel here is hydrogen. Okay, hydrogen. It could be something else also, but prominently right now, since this is a new technology, we only have the hydrogen as a fuel. That is where you will talk about the types of hydrogen: green hydrogen, blue hydrogen, gray hydrogen, and all those things. That is where you will talk about the National Hydrogen Mission. Okay, National Green Hydrogen Mission. Okay, by the government to produce the hydrogen so that can be consumed in the hydrogen fuel cell. So if I am using hydrogen as a fuel in the anode, which can be oxidized to H plus and 2 electrons. Electrons will move in this circuit. Hydrogen ion and oxygen will come together, will release the water. But the ideology is in the battery, nothing has to be supplied from the outside. It is having the concept of charging and discharging. So it is discharging when I am not charging it. It is giving the electricity or whatever is the power requirement to my phone, battery. Okay. In fuel cell, what you are doing, you are supplying the fuel. Once you stop the fuel, power is cut. Once you again supply the fuel, the power is on. So until and unless you supply the power or the fuel, the power will be on. And you cut off the supply of fuel, the power will be cut off. I am giving you 15 seconds. Just think whatever I told you. Just reflect upon it. नहीं समझ में आता है तो मुझसे कुछ पूछो. I will make you revise it again. Just see this. Battery में already there is something which is stored, and this is nothing but metals or carbons which will oxidize. Here is something which is stored. These are nothing but the metal oxides or something else which we'll see right now. अभी रुको, अभी complex नहीं करते. कुछ यहाँ पे store होता है chemical, यहाँ पे एक store होता है chemical. This chemical will go to the oxidation, will release the electrons because this is unstable. Oxidation हो रहा है, electrons आ रहा है, electrons move हो रहा है. अब जब मैं charge कर रहा हूँ, so what charging में what is happening? The ions which were moving in this direction starts moving in the opposite direction, and these are again becoming unstable. So battery is charged again now because this section is again unstable now. Okay? So when the battery is not charging, this is moving towards the stability. Stable होता जा रहा है. Ions यहाँ से इकट्ठे कर रहा है, oxidize हो रहा है, getting into stable compound. And when I am charging it, it is again getting destabilized. So whenever it is destabilized, it is getting charged. है ना? And whenever I will remove the charger, that destabilized position will again start releasing the electrons so that it can move towards the stabilized position. ठीक है? Fuel cell में energy is not stored. Energy is supplied through the fuel. ठीक है? There is no storage of energy in the fuel cell. So as far as you supply the hydrogen, the energy will be produced. There is no concept of storage like this. Here the energy is stored. Here the energy is supplied. but both of them, if you can see, are nothing but the chemical energy turning into electric energy. Okay, here also the chemical energy is there turning into electric energy. Here also the chemical energy is turning into electric energy. Hydrogen fuel cell, sorry, हाँ हाँ, नहीं कार के इंजन सी, अब ही इज कॉम्प्लेक्सिंग द थिंग्स. अब सुनना आप, ठीक है, ऑन द बोर्ड यार, on the board, although he is making the things complex, but you will now go into the practicality. वो कह रहा है ultimately you will go into the practicality now. See, इसके अलावा भी एक दुनिया एग्जिस्ट करती है ना, and that world is nothing but the world of LPG, CNG, then this biogas, then diesel, petrol. And I hope you are aware about this world also. What is happening in this world? In this world, all of them, you are using the combustion. You are using the combustion. What you are using? Your carbon compound. Hai. All of them are carbon compound. You are putting a heat to it. For example, this is also a carbon compound. If I will heat it, what will happen? The energy will come out. अगर मैंने इसे आग लगाई तो क्या होगा? Heat आएगी बाहर. So similarly, if I am fueling it, the heat is coming out. The energy is coming out. So this is another world where you are using the combustion. You are firing it up to release the energy. I'm not concerned about this world right now. I'm concerned about two other worlds, which are battery and fuel cell. But this is comprehensive now. If he has brought this into the picture, this is comprehensive now. Whatever are the source of vehicles or the power of vehicles, either it is battery, you might have heard about lithium-ion battery, the this EVs and all those things, okay, batteries, or it is a fuel cell. Right now there are vehicles coming up with the fuel cells, hydrogen as a fuel cell. Why? Because it do not emit any of the greenhouse gas. See, these will release the greenhouse gases. These are the carbon compounds. Carbon matlab there is some element of carbon in it. So if you will light it up, this will release CO2, it will release CO, it will release the other greenhouse gases. So all of this world, this is under the combustion, and this will release CO2 or the other compounds of carbon, greenhouse gases. But if you will see this world of fuel tech, fuel cells, this is having hydrogen as the fuel, then oxygen, which is naturally available in the air. You're just putting hydrogen and oxygen together to generate the energy. Okay, whatsoever is the electricity or the energy being generated, be it in the form of heat or be it in the form of electricity, anything is fine, is used to fuel up the power vehicles. Then we have the battery. In battery, the energy is stored. Okay, there are two compounds. One is unstable, the other is metal, let's say oxides. This unstable will release the electrons and then will try to come into the stable positions by taking the ions. Ions is moving towards this, electrons are moving towards the other side. है ना, इतनी बात समझ में आई? एनीथिंग एल्स, एनी अदर कंफ्यूजन? हाँ हाँ हाँ, फ्यूल सेल आल्सो हैज द इलेक्ट्रोलाइट्स, उसमें बहुत सारे कंपोनेंट्स होते हैं, बट ठीक है, बहुत क्रूडली, ठीक है. Electrolyte should be there. Then that electrolyte is nothing but a medium through which ion will travel. Either also the ions has to travel, hydrogen ions, they have to travel. So electrolyte has to be there. So in fuel cell, electrolyte is there, in battery electrolyte is there. Anode is there in the fuel cell, anode is there in the battery. Cathode is there in the fuel cell, cathode is there in the battery. The only difference, the basic difference is battery is nothing but the stored form of energy. You have some compound here, you have some compound here, unstable here, so it will release the electrons and will try to come to the stable form. That is how you have to remember. Okay. Fuel cell mein what you are doing, you are giving cathode the fuel. That fuel will oxidize. Let's say hydrogen will oxidize into H plus ions and electrons. How this is being done? This is being done through the catalyst. Generally platinum is being used. So when the hydrogen coming in touch with the platinum, it is breaking into hydrogen ions. So तो देयर रॉड होती है प्लेटिनम की. सो हाइड्रोजन इज सप्लाइड, हाइड्रोजन इज स्ट्राइकिंग दैट रॉड, हाइड्रोजन इज ब्रेकिंग इनटू H plus ions and the electron will start flowing now. Now these H plus ions are unstable, they will start moving. They will start moving through the electrolyte and then they will combine with half O2 and then they will make the H2. So no greenhouse gas, nothing, pure form of clean energy. This is hydrogen cell. I am done with the fuel. I am done with the entire page now. Just dictation बचा है. कोई doubt है तो पूछ लो. I am done with the entire thing. Sorry. हाँ, direct combustion. I need to look. मेरे को देखने दो एक बारी. ठीक है. Anything else? ठीक है, आगे बढ़े. Open your document now. Open your document. Battery. Please write the components. Please write the components. There are 3 components which we will be writing, although there are many more components, separators, all those things. Minute wale we are not writing. We are writing 3 major components: anode, cathode, and electrolyte. For our exam, this is important. Please write. In components, you write anode. First is anode. In anode, please write site of oxidation. Site of oxidation. SITE, site of oxidation. यहाँ पे oxidation होता है. Second point you write release of electron. Release of E minus you will write electron. Third point you write metal slash carbon. Metal slash carbon gives up electron. Gives up electron. Last right. Last right. तो मेटल और कार्बन लिखा था ना. What could be the metals or what are general metals and carbon used? Please write. Make a underline that and make a arrow under. क्या है? Example क्या है उस मेटल और कार्बन के? Please write. Zinc, lead, 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 graphite. Zinc, lead, metals. Then carbon का graphite. Graphite is also used as a anode. Then you write second, cathode. Cathode. Please write site of electron gain. Site of electron gain. Site of electron gain. Next you write metal oxides. So these are oxides of metal. So electron is coming from here, see, and that part is gaining the electron. Okay, so cathode will gain the electron. So site of electron gain. In bracket you can write reduction. Okay, reduction happens here. Site of electron gain. In bracket you can write reduction. Metal oxide लिख लिया. Then write the example of some metal oxides. Please write metal oxides. Lithium, sodium, manganese, nickel, NiCl, nickel, manganese, nickel, cobalt, COBALT, cobalt. Then you write electrolyte. Conducts ions. Conducts ions. Write some example. Sulfuric acid. Sulfuric acid, लिखना है लिख लो, वैसे छोड़ भी सकते हो. NH4Cl. ठीक है. नाउ फ्यूल सेल के कंपोनेंट्स लिखिए. कंपोनेंट्स ऑफ फ्यूल सेल. एनोड, एनोड में Site of oxidation. Site of oxidation. Second point you write release of electron. Release of electron. Third point you write H2. H2 gives up electron. Gives up electron. कैसे? H plus electron. So H2 will be broke like H2 will be broken in this fashion. H plus electron. So 2 electrons every H2. ठीक है? अब there's a catch here. Important point है. See, the catalyst here is required, but in the batteries catalyst is not required. I mean, it may be there but not mandatory. But here you need something so that stable H2 can come in contact with. Catalyst is nothing but which is making a reaction faster. So that platinum rod at anode breaks hydrogen into H plus ions. So here the catalyst is platinum. So please write catalyst is equals to platinum. So whenever the hydrogen will come in contact, it will be broken into H plus ions and the electrons will start moving through the circuit. Just understand this circuit. Electrons are not moving through the electrolyte. If you're getting in the exam the question, although I don't know whether the UPSC will go this technical or not, electrons do not move through the electrolyte. Ions move. If you are confused na, electrons kya hai, ion kya hai, just Google one simple reaction for the battery. Okay, so you will see some ions. For example, H plus, here are the ions. Similarly, in this metal or maybe carbon, you will find the ions of carbon, ions of metal. Okay, then the electrons. You will see the chemical reaction. Just Google it. Some chemical reactions for battery, some chemical reactions for fuel cell. You know, ions. So these ions move through the electrolyte, not the electrons. Electrons will go up, will move through the wire. You know, and since the electrons are moving through that wire, that is nothing but the current or the energy. Done hai? Chalo. Now you write cathode. Catalyst was platinum. Now you write cathode. Please write site of reduction. Second point, oxygen is supplied. In bracket you write generally from air. So it is not stored. Oxygen is not stored. It is supplied from the air. Okay, generally from air. Then you write ठीक है, इतना बहुत है, क्या थोड़ा मिलना पड़ता है. Electrolyte. Just write one example. So again it will conduct ions only. Electrolyte will conduct the ions, not electrons. It will conduct the ions, H plus ions. Electrons will move through the circuit. Conduct ions. Example you write phosphoric acid. Phosphoric acid is an example of electrolyte. ठीक है. अब can I say both battery and fuel cells are an example of chemical energy turning into electrical energy? I am framing two sentences. Battery is an example of chemical energy turning into electric energy. Fuel cell is an example of chemical energy turning into electric energy. सही है? Yes. In both the cases, chemical energy is turning into electrical energy. ठीक है? So if you want to write, you can write in the bracket of both battery and fuel cells. Battery के नीचे थोड़ा सा space है ना? Write in bracket chemical energy turning into electric energy. Chemical energy turning into electric energy. I am giving you 30 seconds. Just read the slide on the board. The difference between battery and cell. I am reading it with you. Okay? A battery is a device which stores and releases electric energy. Stores and releases electric energy acquired by converting other forms of energy primarily through chemical reaction. So chemical energy converting into electric energy. A fuel cell is a device that generates electricity by a chemical reaction. So chemical reaction is common both of them, but it is generating the electricity once the fuel is sent from the outside. Hydrogen, you have to supply the hydrogen to get the electricity. Working principle, it stores energy chemically and releases it as electricity. Generate electricity through an electrochemical reaction between hydrogen and oxygen. So it is not storing any energy. Energy density, it is having a lower energy density, meaning shorter range and heavier weight for the same power output. Very important that the batteries have a lower energy density. For example, बहुत crudely, if I am carrying a 5 kg ka component of fuel cell and 5 kg ka component of battery, component I means these anode, cathode and all those things, components, battery and fuel cell. The 5 kg of fuel cell will give me much more thrust and much more energy than the battery. The higher it is having a higher energy density. Done. Then if I talk about the efficiency, it is having a lower efficiency and this is having a higher efficiency. Just because the energy is stored, it is converting into one form or the other. Here maybe some of the hydrogen atoms are being lost, or some of the hydrogen, what is it, the molecules are being lost, not being converted, not being oxidized. So it is having a lower efficiency due to energy losses in hydrogen production and conversion. Basic चीज है. So if I talk about efficiency, this is more efficient. Recharge requires recharging from external power sources, which takes comparatively more time. Here requires hydrogen refueling. Recharging कुछ नहीं होता. Hydrogen you have to supply. You have to keep the hydrogen in the tank so that you can start the same diesel petrol की तरह है. You have to keep it in the tank so that you can supply it. Lifespan degrades over time and requires replacement. Comparatively longer lifespan. Then emissions may produces no emissions during use, but battery production, this leads to the e-waste. You are making a battery from the metal oxides and metals, it will lead to the e-waste. It produces only water as a byproduct, making it a near zero emission technology. Done. Then you have applications so common in electric vehicles, portable electronics, grid storage. This is heavy duty transport, aerospace, backup power due to higher energy density, etc. etc. You can use it to run the this whatever the power we are having right now in this premises, okay? Because the energy density is high, it can give you more power for the same weight. Done. So what you will do, shall I dictate or you will write? मैं dictate करता हूँ, तुम लिखो. दिखाना कहाँ लिखना है, ये अच्छा क्वेश्चन है. ना ना नीचे मत लिखना, नीचे बहुत कुछ लिखना है इसमें. ओके. टाइप्स, बैटरी के टाइप्स के साइड में लिख लो. बैटरी के टाइप्स के साइड में राइट बैटरी वर्सेस फ्यूल सेल. बैटरी वर्सेस फ्यूल सेल. टाइप्स के साइड में देयर इज अ बॉक्स खाली, सेल खाली. प्लीज राइट बैटरी वर्सेस फ्यूल सेल, है ना. बैटरी वर्सेस फ्यूल सेल. फर्स्ट यू राइट stored energy. So battery में you will write stored energy versus supplied fuel. Stored energy versus supplied fuel or hydrogen. Second difference is low energy density versus high energy density. Low energy density versus high energy density. Third is higher efficiency higher efficiency versus lower efficiency. So I told you in hydrogen cell the things will be lost obviously, but here the things are automatically stored अंदर ही है, तो loss होने का chances are less. So these are more efficient, these are less efficient. So if you are, let's say, giving 1 kg of hydrogen as a fuel, some of it will be lost. Please write. ये common sense है, recharging versus fueling, है ना. We are not writing it. Next you write lifespan. Please write lifespan lesser higher. lesser versus higher. Fuel cell have a comparatively more lifespan than battery because this degrades, battery degrades over time, है ना, जंग लग जाएगी या कुछ भी हो जाएगा. Then emissions, no emissions versus no emissions. ना मेरा फोन एमिट करता है ना फ्यूल सेल एमिट करता है. आई टोल्ड यू फ्यूल सेल में हाइड्रोजन एंड ऑक्सीजन आर कंबाइनिंग टुगेदर टू गिव द H2O, वाटर है प्रोडक्ट, बाय प्रोडक्ट. नो एमिशन एंड नो एमिशन, both में there is no emission, no emission of greenhouse gases, but byproduct are there. If you can see, this may not have any byproduct, but this has the byproduct as water. There is no byproduct, the byproduct here is water. So please write no byproduct versus byproduct as water. Let's see some two illustrations now. देख लो बैटरीज. So anode, cathode, ions are moving this direction, electrons are moving in this direction. ठीक है, anode, cathode, ions, then these are electrons. Electrolyte is in which ions will move. So these are ions and the electrons will move through the circuit. ठीक है, conceptual array. ठीक है, बस hydrogen fuel cell. This is fuel cell. What you're doing, giving a fuel hydrogen. This will be broken into H plus electrons. H plus will move to the electrolyte. Electrons will move to the circuit and will go to this, and they will combine together. They will make what? Water. And the outcome here will be water. ठीक है, I told you ions may move this side also, ion moves may move this side also. It depends, है ना? It depends. Okay. समझ गया? It will combine, will make H2O. Water will come. ठीक है. Now, do you have the clarity between fuel cell and the battery? Third thing which we have to remember are these what I can say: petrol, diesel, biogas, CNG, LPG. What you are doing? You are burning them. For example, when I burn this paper, the heat will be produced, and that heat will be used to rotate the whatever is the component in the vehicle to make the vehicle moving. ठीक है. So these are nothing but the combustion based fuels. You are combusting them. If you are combusting them, like you are doing the combustion, what is happening? These are carbon compound. Carbon will, when the air is mixed with the carbon, what will released? CO2, CO and all those things. ठीक है, ये हम बाद में देख लेंगे, अभी आज मुद्दा इतना ही है ना. चलो, ओके, नहीं, वेट. अब here you will write types में, first you write lithium ion battery. We will see 3 batteries: lithium ion, sodium ion, and then metal air batteries. Lithium ion batteries. Lithium ion batteries. Please write anode. क्या है इसमें? Anode, what is the anode here? Graphite. So please write anode is equals to graphite. Anode is equals to graphite. Secondly, right, cathode is equals to lithium oxide. Cathode is equals to lithium oxide. Okay. Electrolyte, some salt of lithium. Electrolyte is nothing but some salt of lithium. Then you write the features. Please write rechargeable. अभी तो बेसिक लगेगा तुम्हें, रिचार्जेबल है, बैटरी है तो रिचार्जेबल हुई, राइट. If I talk about hydrogen fuel cells, are they rechargeable? Now you should have the fundamental clarity. अब ये नहीं कि मेरे को पढ़ाया नहीं है, मैंने पढ़ा नहीं है और मैगजीन में नहीं आया, उसमें नहीं आया, कुछ नहीं, ठीक है. रिचार्जेबल ये है, वो नहीं होगा. फ्यूल सेल में क्या है, फ्यूल डालोगे आप, रिचार्जेबल का कंसेप्ट ही नहीं है उसमें, ठीक है. प्लीज रिचार्जेबल, कॉमा कॉमा हाई एनर्जी डेंसिटी. कॉमा हाई एनर्जी डेंसिटी, कॉमा कॉमा better efficiency. Better efficiency. I am not comparing anything. I am saying the energy density is good. I am not comparing it with the fuel cell. मैं कुछ compare नहीं कर रहा हूँ. If I compare it with the fuel cell have the better energy density but lesser efficiency. ठीक है? I'm not comparing. I'm saying generally this is having a good energy density. Why I'm saying, when we will compare it with the these other batteries, we'll see why I'm saying this. ठीक है? Then right. Next point. 2019 Nobel Prize for Chemistry. 2019 Nobel Prize for Chemistry was awarded for lithium-ion batteries. Just you write this much. 2019 Nobel Prize for okay. Then you write about lithium. Make a box. Write about lithium. Make a box. Write about lithium, please. Okay. Non-ferrous metal. Non-ferrous metal. Comma. Lightest metal. Lightest metal. Comma. Very reactive. Very reactive. जल्दी से रिएक्ट कर लेता है, ठीक है. So it is very reactive. Obviously, it will be, when it is unstable, the electricity flow will be there, है ना. Second point you write. Second point you write. Generally found in brine deposits. BRINE, brine deposits. So brine deposit is nothing but salted water, ठीक है. So in some aquifers, in some places, these are accumulated as part of salt. Lithium भी मिलता है ना. Third point you write. Third point you write. Let me fetch it. Does not occur as metal, but is found in combined state. Okay. Now write lithium producers globally. Lithium producers. Next point. Lithium producers. Who is the largest producer? Who is the largest producer? Lithium. Australia. Australia. Then you write Chile. 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 Then you write China. We are not talking about the reserves. We are talking about the producers. Producing. See, India may have the highest reserve of something, but it doesn't mean that India is the highest producer of that particular metal. Producer is different, reserve is different. Then you write, please, next point. Then you write next point. Major reserves. Major reserves. Semicolon. Semicolon. Right? Lithium triangle. Lithium triangle. कहाँ है? किस कॉन्टिनेंट में? South America. Please write in bracket. Lithium triangle in bracket. You write South America. The countries are ABC. Argentina, South America. Semicolon you write Argentina. तो दिस इज अबाउट द डिपॉजिट्स. अब सबसे ज्यादा डिपॉजिट्स कहाँ है लिथियम के? वो यहाँ है. वो 50% ऑफ द वर्ल्ड्स डिपॉजिट इज अवेलेबल इन दिस lithium triangle, which is in South America, and the countries are A, B, C. Argentina, Bolivia, and Chile. Argentina, Bolivia, and Chile. Do India has any lithium reserve? If I make the statement India do not have any proven lithium reserves, false. Please write India semicolon. India semicolon. India semicolon. First lithium reserve. India semicolon. First lithium reserve found in, कहाँ मिला था? JN के वाला तो फर्जी है. ठीक है, JN के में भी मिला है. कुछ ना कुछ करते रहते हैं. फर्स्ट प्रूवन रिजर्व क्या लिखा हमने? फर्स्ट लिथियम रिजर्व इन मांड्या MP. MAN DYA Mandya. Sorry, it is not MP. It is in Karnataka. Sorry. Karnataka. Mandya, Karnataka. ठीक है. Then you write last point. Recently LI reserves, lithium reserves have been found in एक डिस्ट्रिक्ट है जम्मू एंड कश्मीर में, रियासी डिस्ट्रिक्ट. REASI, that is the spelling, right? REASI, रियासी डिस्ट्रिक्ट. In bracket you write Jammu and Kashmir. Done. So we have done the lithium वाला part also along with the lithium-ion battery. Do you have the space now? नहीं. कोई बात नहीं. Right में ना you have the space beyond battery versus fuel. In that space give a heading of sodium-ion batteries. Sodium-ion batteries and mark it 1 star. Sodium-ion batteries. Mark it 1 star, please. Okay. See, right now on the board here, please. On the board. त्रिनेत्र cannot be applied if your concepts are not sound. नहीं लगा सकते. ठीक है. TRINETRA can only be applied if you are conceptually sound. Then the TRINETRA will start working. Okay? And I have told you in my very first class, without TRINETRA, you cannot even think of clearing prelims. भूल जाओ. You will just reach 80-85. Knowledge से नहीं, उससे ज़्यादा हो सकता है यार. Knowledge नहीं आएगी काम. और 5 से 6 क्वेश्चन एक्स्ट्रा चाहिए to cut off the, to clear the cut off. So what I'm saying, sodium ion batteries. Second thing, the ideology is, when I talk about lithium ion battery, the metal lithium, the metal lithium is not available in India in that sufficient quantity, but the consumption is huge, because simply we are moving towards the EVs and all those batteries based upon the lithium ion. But India don't have the good reserves or sufficient reserves of the lithium. Up. The thing is, we are trying to switch towards the sodium ion batteries. The beauty of these sodium ion batteries are twofold. Beauty matlab positives are twofold. First is, sodium ion or sodium is abundantly available in India, like thorium. This is abundantly available in India. Second thing is, sodium ion batteries are cheaper than the lithium ion batteries. So you will write these 2 points. Sodium ion batteries, please write, sodium is abundantly available. Sodium is abundantly available. Then you write cheaper. Second point is cheaper. Now one more aspect of this, again on the positive side, that this is safer than the lithium ion battery. We have seen the cases of lithium ion batteries exploding, and the simple reason is that lithium ion is very reactive in nature. Sodium ion batteries are safer alternative to lithium ion. Where you have written the cheaper, comma लगा के please write safer, comma safer, cheaper and safer. But the drawback lies in the energy density. The energy density of sodium ion battery is poor than the lithium ion battery. That means you need a big batteries to give the power to your vehicle. So in the vehicle the space for these batteries should be huge, बड़ा होना चाहिए, है ना? These are not that compact, not that small as the lithium ion batteries, because of the simple factor, the energy density, and this is the most important point of sodium ion batteries, the energy density of sodium ion battery is poor than the lithium ion battery, and that is where I made you write the high energy density in the lithium ion battery. Here you write low energy density or poor energy density, lesser energy density or poor energy density as compared to Li, as compared to Li. So what will happen? The energy density is lower. What will happen? The size will increase. So please make a arrow and write increase size. Increase size. बेटा this is important, कर लेना ये सोडियम आयन वाली कर लेना, ठीक है? Increase size. Second is increase weight. Very good. Heavy. तो heavy हो जाती है ना? Battery is heavy. Because you need more condensed, what I can say, the weight of the anode and the cathode to produce the same amount of power. So the battery is heavy. Third thing is charging is slow. So the energy density is high, low. Charging becomes slower. Ions बहुत slow move करेंगे, right? Charging is slower. Done? Sorted? ठीक है. So we are done with the sodium ion battery. What will be the anode here? Graphite. What will be the cathode here? Sodium oxide. And electrolyte, any salt of sodium. ठीक है? So cathode, anode and all those things are not important here. These 4 points which you wrote in your document is important. Then you write the last. जगह है? नहीं तो ऊपर टॉप पे कहीं लिख लो, बहुत छोटी सी बात है. मेटल एयर बैटरीज. मेटल एयर बैटरीज. मेटल एयर बैटरीज. Wait. Please write anode is equals to metal. So anode is metal here. In bracket you can write zinc, Zn, zinc, comma aluminium. comma iron, Fe, iron, comma even lithium you can use. Lithium here you can use at the anode, है ना? Although in the other batteries we are seeing the lithium being used at the cathode, here you can use the lithium as metal at the anode. Done. चलो, and cathode में please write cathode equals to oxygen from here. That is why the name is metal air batteries. Metal air batteries. Done. That much is enough for this topic. Now we will write the types of fuel cells. Please write type of fuel cells. First give a heading. First give a heading. Hydrogen cell. Hydrogen cell. फटाफट लिख दो कैथोड एनोड क्या होगा. एनोड क्या होगा? हाइड्रोजन, एंड कैथोड विल बी ऑक्सीजन. वेरी गुड. Okay. Then you write the application. Used in high power scenarios. So whenever you need a very high power, see, for medium power you can use the batteries, lithium-ion batteries, but उससे भी थोड़ा ज़्यादा power चाहिए. Although the fuel can be used, okay, the fuel cell can be used to replace the lithium-ion battery in the vehicles. But let's say if you want to generate the power for this classroom, you can use the fuel cell, है ना? For very, because the fuel cell have a higher energy density. Done. So please write like trains, comma buses, comma aerospace, buses, comma aerospace, comma power generation. ठीक है, power generation. If you want to generate the electricity for this classroom, you can use the fuel cell. Right? High energy density. ठीक है. So we are done with the fuel cell. Now on the right hand side, there is a column. Done. For example, if this is your page is divided into 3 sections. 1, 2. This we have done. इसमें 1 we have done, 1 we will do later. बाद में करेंगे. अब इधर what you have to do, you have to write about the hydrogen, then you have to write about the types, and then you have to write about the national hydrogen mission. First write about the hydrogen. Right में जो blank column है. First write about the hydrogen. Please write first point, non-toxic, comma non-metallic. तो non-toxic है, non-metallic है, comma tasteless, comma tasteless, comma colorless. Physical properties है ना, comma colorless. Then you write zero emission fuel. Then you write can be stored can be stored as gas or liquid. Can be stored as gas or liquid. Please write. Produced through produced through process like process like electrolysis of water, electrolysis of water, comma, coal gasification, coal gasification, comma, steam methane reforming, STEAM, steam methane reforming, steam methane reforming. Please write in bracket and mark it 1 star. Underline this steam methane reforming. Underline this please. And you will remember this term now. ठीक है, इसे कुछ अच्छे से मार्क कर लो, एक 1 star या 2 star. Steam methane reforming. In bracket you write producing hydrogen from natural gas. Producing hydrogen from natural gas. On the board now. See, the very first and simple most way of producing the hydrogen is from the water. You do the electrolysis of water, oxygen will be separate, hydrogen will be separate. Electrolysis, those who don't know, there is a process. Just Google out, read about it. लिख लो कहीं पढ़ लेना, ठीक है. Electrolysis. First way is from the water. Second way is from the coal. What is happening? You are burning the coal. The coal is nothing but a carbon compound. So when I say the carbon compound, it has carbon, it has hydrogen also. If you don't know, I mean, every carbon component generally have carbon, hydrogen, oxygen. These are nothing but the basic blocks of the carbon compound. So when you're doing the gasification as you are breaking it into parts. One of the byproduct could be the hydrogen, or else you have written a process. That process steam reform, steam methane reforming. Okay, I am very bad at facts. Steam methane reforming. This process is used to make the hydrogen out of natural gas. Not important for me, but important for you. मेरे को याद नहीं है, इसका मतलब ये नहीं है तुमको भी याद नहीं होना चाहिए. You have to remember this process. That steam methane reforming is a process related to, is a process of forming the hydrogen out of natural gas. And let me tell you one thing, government is focusing a lot on the green hydrogen. And when I say green hydrogen, most of it is nothing but this electrolysis, or else some part is this second wala, steam methane reforming. ठीक है, so these both two things are important for you. चलो हो गया. Then you write types. Shall I complete and take? Okay. Types. First you write green hydrogen, and this, if possible, please write like this. Types like this. Make the arrows like this. Okay. Types, make the arrow like this. Right? Green hydrogen. Green H2. Just this much. Green hydrogen. Please write green hydrogen produced through, or H2 produced through electrolysis. H2 produced through electrolysis. ठीक है. Then you write blue hydrogen. Blue hydrogen H2 from natural gas or coal gasification. Natural gas or coal gasification, comma, very important now, but emitted CO2 is captured and stored. See, we are saying it blue because whatever are the emissions, we are not letting it in the atmosphere, we are capturing it and we are storing it, maybe in the aquifers and all those, ocean and all. You might have done this in the environment, right? Okay. So we are storing it. Third, you write gray hydrogen. Gray hydrogen please write H2 from coal or methane or coal or methane or steam methane reformation. That is nothing but the steam methane reformation is natural gas से, ठीक है. तो ईथेन मीथेन रिफॉर्मेशन. तो स्टॉप, सॉरी, अरे लिखवा रहा हूँ, आगे तो लिखो, कॉमा मोस्टली कार्बन इंटेंसिव process. So if I ask you now, what is the difference between the blue hydrogen and the gray hydrogen? In blue you are capturing the carbon, in gray you are emitting the carbon. ठीक है, sorted. चलो, then you write two homeworks you will write. लिख लो, क्या करा दूं, लिख लो, चलो. Write white hydrogen. Can anyone tell me right now? So I will dictate. अभी कोई बता सकता है what is white hydrogen? White hydrogen is nothing but the natural hydrogen. Please write natural hydrogen. Natural hydrogen. In bracket you can write, also known as aka also known as aka. शॉर्ट में लिखो ना यार, सीख जाओगे. aka gold or geologic hydrogen. Gold or geologic, geologic, geologic hydrogen. You can open another bracket, एक और bracket लिख लो या कॉमा लगा लो, जो भी whatever the pattern you are following, please write. Produced in, so naturally occurring hydrogen produced in Earth's crust. So this hydrogen coming from the Earth's crust out of the natural processes, that is nothing but the white hydrogen, also known with the name of gold hydrogen or geologic hydrogen, है ना. Now last you will write black or brown hydrogen. This you will search on your own. Black or brown hydrogen. Black or brown hydrogen. Okay. Next you write नेशनल ग्रीन हाइड्रोजन मिशन. स्पेस नहीं है, मेरे को लिखवाना भी नहीं है. दिस विल कवर इन द स्कीम्स, बट यू राइट नाउ द नेम. नेशनल ग्रीन हाइड्रोजन मिशन. नेशनल ग्रीन हाइड्रोजन मिशन. जस्ट अ स्ट्रीक मार्क कहीं नीचे, make be side में, if you have the space write it there itself, make a streak mark and write. Make a streak mark and write. ठीक है, प्लीज राइट. India's first India's first indigenous green hydrogen power plant. India's first green hydrogen power plant कहाँ establish हो रहा है? Very good. Please write. Make a arrow and write. Establish that Kandla, Gujarat. So Deen Dayal Port you can write. Establish that Deen Dayal Port, comma Kandla, comma Gujarat. Establish that Deen Dayal Port, comma Kandla, KNDLA. यही बोलते हैं, कंडला बोलते हैं. ओके, सॉरी मैम, आप गुजरात से हैं तभी हंस रहे हैं आप. चलो डन. ये नेशनल ग्रीन हाइड्रोजन मिशन पे 3 पॉइंट लिख लें. 3 पॉइंट लिख लो. नेशनल ग्रीन हाइड्रोजन मिशन, प्लीज राइट. 2023 व्हाट द मिनिस्ट्री? एनवायरमेंट या फिर रिन्यूएबल एनर्जी? प्लीज राइट. मिनिस्ट्री ऑफ न्यू एंड रिन्यूएबल एनर्जी. मिनिस्ट्री ऑफ न्यू and renewable energy. Then write target. Last point, target. Production capacity of just underline the target. 5 million ton 5 million ton per year by 2030. by 2030. ठीक है. You remember this slide? In this slide, apart from this and this, there is one important thing in current affairs which you will see, and that is nothing but ethanol. Not only ethanol, you will read about E20, E27, E100 and even E90. Last two are not important for us. E27. Then you will read about ethanol blending. Then you will read about flex vehicles, etc., etc. So this is very important for this year. Very important for this year. The current affairs part of this, let's say the global biofuel alliances and all those things, that I will deal in the Samadhan. Here I will take the science and tech part of it. Okay? Basic science and tech part of it. Done. And I'm giving you the homework. What you will do at home, you will see about the LPG, CNG and biogas. So please write it somewhere in the homework. LPG, CNG and biogas. So these three combustion fuel you will see. Petrol and diesel I will cover in the economy. I will tell you why. Sorry, flammable. Hydrogen is a, sorry, no, it's not reactive, but the hydrogen ions are reactive. Hydrogen gas individually is a flammable gas. Okay, on the board now. On the board beta, please, on the board. कौन था ये, कौन था ये, कौन था, अपने आप बता दे. ये था सूरज, ये था या तू था, कौन था, बोल बोल बोल, आगे से दोबारा मत कर दियो. बेटा ये कॉलेज में करते थे हम, कॉलेज वाली क्लास नहीं चल रही है, चाहे जाए तो उठ के चला जाए यहाँ से. थैंक यू बोल रहा है. ऑन द बोर्ड. मैं अपने लिए थोड़ी पढ़ा रहा हूँ यार, मेरा क्या जा रहा है बता. मैं छोड़ दूंगा एथेनॉल, कर लो अपने आप. बाकी लोगों का नुकसान हो जाएगा ना, जो सीरियसली बैठे हैं सुबह से लेकर शाम तक तुम्हारे थैंक यू के चक्कर में. मस्ती मत करो क्लास में. इथेनॉल, see what is ethanol? Ethanol is nothing but a carbon compound. And if I say more crudely, ethanol is nothing but the alcohol. Ethanol is alcohol, and not only alcohol, it is 99.9% alcohol. Almost suicidal if you drink it neat. 99.9% alcohol. ठीक है. अब जो थोड़े प्रो लोग हैं उनको समझ गए होंगे क्या बोल रहा हूँ, है ना. very condensed form of alcohol. अब what is happening, this ethanol, whatsoever is the compound, have two properties. First is high octane number, and I will explain what it is. But at the same time, the energy density is lower as compared to petrol and the diesel. That means the thrust energy density is nothing but the thrust per kg, whatever it is producing, is lower than the petrol and diesel. Okay, is lower than the petrol and diesel. But the beauty here is of ethanol, the octane number is much more higher than the petrol or the diesel. I hope all of you might have visited to these petrol pumps. On these petrol pumps, other than these petrol and diesel, you will find the very high superior quality petrol, extra, all those things, whatsoever it is. Okay, superpower and all those things. High quality petrol with a premium charge of ₹5 per liter or maybe ₹6 extra. Those supreme or the premium petrols or diesels, whatever you are seeing at those petrol pumps, why they are superior? Because they have the high octane value or high octane number. What is this octane number? This octane number is simply a phenomena which helps in the combustion of the engine. If the octane number is high, the combustion will be much more faster. कभी बाइक चलाई है? बाइक रेस पकड़ती है, बाइक picks up the race, so the pickup improves, it picks fast. Whatever race you are trying to give to the bike, it pick up fast because of the higher octane number. Same with the car. If the octane number of whatever you are using in the vehicle is better, superior, it will pick up fast. So what this ethanol is doing, it is bringing that more pickup or the easy combustion in the whatever is the mixture. Easy combustion है, बहुत जल्दी पिकअप हो रहा है, बहुत जल्दी combustion हो रहा है. But the thrust, the density is poor. That means you need more of it for the energy, same amount of energy. पहली चीज डिफरेंस समझ में आया या नहीं आया? मेरे से पढ़ने के बाद you should understand each and every news article, you should understand whatsoever is going in the कि क्या डिबेट है, क्या नहीं है, क्या खराब है, क्यों नहीं है, all of it, है ना? So the conceptual soundness is important. So two things are there: octane number, how fast it will combust is the octane number, how much energy it will produce is nothing but the energy density. So energy density is poor, but the octane number is higher. So what government is saying, that first of all, you blend this ethanol with petrol. Mind you, if the question is mentioning both petrol and diesel, that is wrong. So ethanol blending is only for the petrol. First thing, very clear shot. This will be a trap. Only for the petrol. What is happening? You're taking some quantity of petrol and then you're taking some quantity of ethanol. If let's say in 100 liter, this is 80, this is 20, that means the fuel is 20% ethanol and the fuel is E. Understand one thing, this blending is having some positives. What are the positives? First of all, the positives first of all will come from the octane number, that the combustion will be faster. Second, when it comes to the petrol, and I told you petrol and diesel we will see in the economy, just for the simple reason that we are importing the crude oil. Okay, so most of this petrol right now in India, although refined, but the raw material is being imported, and what is happening, that we have to give the forex reserves in exchange. पैसा जा रहा है बाहर. So if we are blending the ethanol with the petrol, that 20% you are saving, the 20% you are saving in the forex reserves. So what this is helping, this is helping to improve the balance of payment. Not only this, beta, understand, whatsoever is the ethanol is being produced, this ethanol as a compound, carbon compound, so it is being produced from the carbon matters. For example, there could be corn, rice, maybe any form of sugar cane or sugar, let's say sugar cane, a form of sugar, maybe maize, whatever you eat right now is nothing but a carbon compound. What you are doing the fermentation of all those carbon compound. Ferment होने दे रहे हो आप उनको, ठीक है? अब those who don't know the fermentation, just go home, search about the fermentation. You should know about the fermentation. Okay, so you are keeping the things for a longer period of time. Some bacteria are coming, some yeasts are coming, fermentation is happening, and that is how you are producing the ethanol. Ab in the process, if I am saying that farmers who were supposedly, supposedly were wasting some sort of, let's say, grains or maybe produce, what they can do, they can now produce the ethanol out of it. Let's say they produce some rice. They were not getting a good buyer for the rice. Rice सड़ने लगा. Rice started deteriorating. What you do? You pick up that rice, whatever is the waste, you start producing the ethanol out of it, out of rice grains, broken rice grains. Okay. Or maybe whatever stubble you are collecting from the ground. Stubble is also carbon compound. You let it ferment. When it will ferment, that stubble, which is the waste, is giving you extra money in return. So what I'm trying to make a point is, the positives of this could be increase income to the farmers or better agriculture. And this statement, if coming in the exam, will be true because this is from the government document. Ethanol blending program may one of the component is this, that increase the income of the farmer. Does that make sense? Okay. Chalo. Now, when I see the negatives, what are the negatives? First of all, energy density is there. So this energy density is reducing. So you need higher amount of, or your mileage may decrease. Mileage may decrease. For example, initially your bike or the vehicle was moving, let's say 100 kilometer for maybe let's say 20 in 1 liter, but right now it is moving 18 in 1 liter. Mileage is decreasing because energy density is lower. The second thing could be compatibility with engines, and that is where you are seeing the protest. ठीक है, कि जंग लग जा रही है, खराब हो जा रहा है, जल्दी दिक्कत में चला जा रहा है, because of the poor compatibility with the engines. For the obvious reasons, engines are compatible with the pure petrol, but right now you have started using the ethanol, so it may be uncompatible with the engines. Now understand this. After this अभी इसमें the general problem which the government is seeing, or which the from the technology perspective which is visible, is this problem. So in order to deal with this problem, you will see a term in news, and those are nothing but flex engine vehicles. So what are these vehicles? These flex engine vehicles can use the input from maybe E5 or E20 to E100 anything. They can use anything without deteriorating with the health of the engine. So they are compatible with any sort of blending of the ethanol, and these are nothing but flex fuel engines. Flex fuel engines. Okay, so this is nothing but the idea line of these ethanol and all those things. Ab isme we have to understand one thing. First of all, from India's perspective, ethanol blending program, EBP. Then we have Global Biofuel Alliance, which I will cover in the current affairs. What you do, you write in your what I can say the handout. दिखाइए. You divide your handout into two parts, है ना? Divide your handout into two parts. On the right hand side, please write, give a heading. On the right hand side, please write, give heading. Ethanol blending. Give a heading. Ethanol blending. And just keep on writing with me, okay? Ethanol, in bracket you write ethyl alcohol. Please write this name also, because the UPSC may frame the name. See, UPSC may not ask you ethanol. पता है बच्चे पढ़ के आएंगे. UPSC will ask the name ethyl alcohol. You should know ethyl alcohol is nothing but ethanol. So this is nothing but alcohol around 99.9%, and this is made from fermentation of organic compound, made from fermentation of organic compounds like sugarcane, corn, maize, ज्वार, बाजरा, maize, ज्वार, बाजरा. Then maybe any biomass like stubble. ठीक है, biomass. अब this is big arrow like this, right? Clear, comma, colorless. Clear, comma, colorless. First property is high octane number. High octane number as compared to petrol. Higher octane number. So make arrow and write faster combustion. Generally the faster combustion is not a right word. It's like engine jaldi start हो जाएगा, ठीक है? Faster combustion. Okay. In bracket you write plus. This is a positive thing. Second is low energy density as compared to petrol. Low energy density as compared to petrol. Done. Then make an arrow and write what are the positives. Please write circular economy. Can I say this is having the phenomena of circular economy also? Whatever the waste, you are using it for the energy. Comma, you write lesser greenhouse gases. Lesser greenhouse gases, comma, lesser carbon monoxide, CO, carbon monoxide, comma, increase forex, comma, see, in this ethanol we are moving towards the E20. Have we achieved the target? See, with just this year achieved the target. Target was supposedly 2025 and 2026. Just from the government documents I am quoting, we have achieved 19.7%. We have not achieved the 20%, okay, completely. But nevertheless, government has said we have achieved. So E20 is nothing but 20% blending of ethanol in diesel, petrol. If you find diesel, that is wrong. First thing. Now, government is trying to push it towards the 100%. 100%. पूरा long term plan लेके बैठे हैं, है ना? कौन? हमेशा कहाँ? नितिन जी. 100%. This 100% or E100 will have 95% ethanol. This 20 is having 20% ethanol. Just remember 100 is not having 100% ethanol, it is having 95% ethanol. ये थोड़ा ध्यान में रखना. Done? चलो. Now, in order to achieve this, we have ethanol blending program, EBP. EBP. Ethanol blending program. नेशनल ग्रीन हाइड्रोजन मिशन किस मिनिस्ट्री के अंदर था? MNRE, ठीक है. एंड दिस इथेनॉल ब्लेंडिंग प्रोग्राम लॉजिकली मिनिस्ट्री ऑफ पेट्रोलियम, ठीक है. तो प्लीज राइट द ईयर 2003, कॉमा PNG, MOPNG, मिनिस्ट्री ऑफ पेट्रोलियम एंड नेचुरल गैस, कॉमा, एंड दिस इज फॉर ओनली पेट्रोल, only petrol. Okay, done. Now it has some targets, ठीक है. Targets we will see in the current affairs. I'm not touching the schemes right now, if you can sense, right? For example, in the quantum we have a scheme, national quantum mission. What we will do in the current affairs, I will revisit all those schemes, है ना. Nanotechnology missions, national quantum missions, all those things we will see in the current affairs. Abhi let's focus on the science and tech. ठीक, चलो. So we have seen this from the science point of view. Schemes I will cover later. Okay. On the right hand side, now write about the ammonia. Ammonia. Right side space बचा है. Give a heading ammonia. सॉरी, फास्टर कंबशन इज नॉट अबाउट कि यार जल्दी जल्दी कंबशन होके खत्म हो जाएगा. अगर फास्टर कंबशन है तो इट विल मूव एट अ फास्टर स्पीड इन वेरी शॉर्ट स्पैन ऑफ टाइम. जल्दी स्पीड पकड़ेगी व्हीकल. ठीक है. हाँ, यही तो है. ये नॉकिंग एजेंट है, एंटी नॉकिंग विच इज ब्लॉकिंग इट. नॉक मतलब टू मेक इट स्टार्ट. नॉक कर रहे हो आप उसको, लाइटर दिखा रहे हो. ठीक है. सर्च कर लेना, नॉट इम्पॉर्टेंट यार. बहुत सारे टेक्निकल टर्म्स हैं ऐसे, तो फिर खत्म ही नहीं होगा, है ना. ठीक है. नॉकिंग इज रिलेटेड टू कंबशन, नथिंग एल्स. बस इतना ध्यान रखो. चलो, प्लीज राइट. पहले लिख लेते हैं इसे. अमोनिया, मेक अ स्टिक पॉइंट एंड राइट. फ्लेमेबल फ्यूल, फ्लेमेबल फ्यूल. आई विल एक्सप्लेन. पहले लिख लो. कॉमा टॉक्सिक, कॉमा टॉक्सिक, कॉमा हाईएस्ट एमिशंस कहां से होता होगा. एग्रीकल्चर. हाईएस्ट एमिशन is from the agriculture. Then right, used in production of, used in production of fertilizers, comma acids. In bracket you can write nitric or nitric acids, acids, comma dyes, dye, comma explosives, comma pharma, etc. So almost used, in all the industries. Almost in all the industries we will see the use case of ammonia. Almost used in all the industry in one form or the another, either in the crude form or at the form of fertilizers. ठीक है. Used in almost all the industries. Please write. Last and very important point, produced through the, produced through the किसी को नाम याद है प्रोसेस का. वेरी गुड. हैबर बॉश process. The process is not important, just write the name. Hydrogen were produced by using electrolysis, coal gasification and natural gas वाला जो मैंने बताया था, steam, methane, जो भी है. ठीक है. Done. This is produced through the Haber-Bosch process. चलो, now forms लिख लेते हैं फटाफट. फॉर्म सेम है. You can compare the hydrogen with the ammonia. Forms: green, so green H2 plus N2, H2 plus N2. So there is no CO2 which is coming out. No CO2 which is coming out. Green. You're bringing the hydrogen atom in closer with the nitrogen atoms. Then you write blue. Blue, what you will do? You will capture CO2. Whatsoever the process, you will capture CO2. Then you will have gray from fossil fuels. So you will not capture the CO2. Very simple. From fossil fuels. Now, इससे ज़्यादा important है. Please write. Please write. Give a heading and write ammonium, ammonium nitrate fuel oil. Ammonium nitrate fuel oil. Please write. Please write. Is an industrial explosive is an industrial explosive in bracket you write greater than in bracket you write greater than 45% ammonium nitrate. Next point. Next point. Ammonium nitrate is a high nitrogen fertilizer. High nitrogen fertilizer. So generally in the ammonium nitrate NPK is 34:0:0. Okay. अब see on the board now. Please, 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 please. 1-2 मिनट लूंगा. And understand one thing. I have to cover the, let's say, bamboo bio ethanol plant, है ना? So what I'm saying, I'm not covering all those right now. I will take them up in the समाधान. ठीक है? Don't worry, I will not leave anything. We'll take them all those things up in the समाधान. ठीक है? Right now static पे I'm inclining a little bit more, है ना? तो bamboo बाद में कर लेंगे. अब ammonium nitrate fuel oil. अब this ammonium nitrate individually is a good fertilizer or fertilizer which has NPK in, let's say, 34:0:0. But when I mix this ammonium nitrate, whenever the ammonium nitrate percentage is greater than 45%, along with some percent of fuel oil, petrol, diesel, anything of fuel oil, this is nothing but explosive. Understand what happened at the Red Fort? हुआ क्या? Those people took ammonium nitrate. ठीक है? Ammonium nitrate लिया. अब this ammonium nitrate individually is nothing but a form of fertilizer. But when you keep this fertilizer along with some fuel oil, you mix and you ignite the reaction. Maybe by a small process आपने आग लगा दिया, कैसे भी flammable है, you ignite it. It will get into a big explosive. ठीक है? So more than 45% if the ammonium nitrate is mixed with any percent of fuel, and generally 95% is ammonium nitrate and 5 to 6% or 5% is nothing but fuel oil. Whenever this is there, ammonium nitrate and fuel oil, this is nothing but a explosive, and that is what is claimed to be used at the Red Fort explosion. ठीक है? All those people were able to get the ammonium nitrate very easily from the market on the behalf of fertilizers. Here fertilizers ले रहे हैं, है ना? But they mixed it with the fuel oil and they used it as a explosive. Got it है? चलो ठीक है. So we are done with this fuel tech. जरा दिखाइए. Done. AI. थोड़ा थोड़ा कर लो, चलो कर लो यार, मानो ना मानो, थोड़ा सा. अरे मैंने डायग्राम बना दिया यार, इतना तो कर लो एटलीस्ट, फिर अगली क्लास में बनाना पड़ेगा. देख लो, बहुत बेसिक है, बहुत बेसिक, मजा आएगा. अरे क्या है यार, बेसिक सी चीज है. on the board. See, you might have seen a robot or maybe a machine or maybe ChatGPT. ChatGPT तो अभी almost all of you are familiar, right? कोई बैठा है पिछली सदी से? नहीं, ठीक है. A form of AI. If you will talk with the ChatGPT or will give the prompt to the ChatGPT, one thing is there that it behaves like or it replies like a normal human. That means that particular chat GPT or maybe that machine is thinking on the similar lines of human. Now, when I talk about human, what makes us special is this brain. That this brain is able to process the things, then give the reply to the other person. क्या हो रहा है यहाँ पे processing हो रही है. Why the processing is being done? Because of the neural networks in the brain. So if you are not aware about the neurons and the neural networks in the brain, just watch some video on the YouTube. ठीक है, घर जाओ आराम से, रात में सोने से पहले चिल करो, 2-3 वीडियो देखो. ठीक है, neural networks in the brain. So these neural networks in the brain process the things for us so that we can give the reply. Right now, if I'm teaching you, the processing is being done in the brain out of those neural networks or the neurons. Done. Up. If I'm able to replicate the same thing, if I am able to replicate the same thing in machine, that is nothing but the artificial intelligence. You have the intelligence, so artificially that has been replicated into some machine. So what is happening right now in machine, there is a basic block which is artificial neural network. It is nothing but a neuron in human brain, a single neuron in human brain, able to get transfer the information, single neuron in the human brain, artificial neural network. So this neural network, the neurons are combined together making a network, ANN. ठीक है, इतनी बात समझ में आई. Now these artificial neural networks, what they are doing, they are stacked into the layers बना दी जाती है. Why? So that they are able to process the information. A single neuron cannot process the things. It has to transfer the information, process the things between the different neurons, and then take out the reply. So what I'm saying, these layers of artificial neural networks, these are stacked. And when they are stacked, these layers are stacked. This is nothing but deep neural network. That it is able to think on the deeper front. थोड़ा ज़्यादा process कर पा रहा है. So this is nothing but when you are stacking it, when you are bringing the artificial neural networks in different layers, bringing them together, placing them together, they are able to process now the things. They are having the processing capabilities. ठीक है, you gave the command, they are able to process the thing. बहुत basic I am covering, then I am leaving you, है ना. ठीक है, अब where the neural networks, these neural networks are stored, that is nothing but the transformer. For you, it is your brain. ठीक है, I want you to have the clarity on this because now UPSC will evolve. Basic UPSC पूछ चुका है. If the question will come, on these keywords. You should know the clear cut, and बहुत ज़्यादा complex है नहीं. ठीक है, बहुत simple सी चीज़ है. Artificial neural networks are similar to neurons. These are stacked into layers, and when these are stacked into layers, this is deep neural network. And whenever they are stacked, everything which is stacked in my brain, this is able to process the things. Processing capabilities are built through these neural networks. Now how things are processed, that we will see maybe in the next lecture. Okay, processing capabilities, and where there is stored, that is nothing but a transformer. Okay, in chat GPT, the last T stands for the transformer. Okay, the last T in chat GPT, transformer. Then so transformer is nothing but the brain where the entire things is getting processed. Now there is another word which you will see, large language models. Understand now, you have made the brain. A child also has the brain, you also has the brain, but is the child able to process the same thing like you do? Why? Because you have been trained on this over the period of time by your family, by the same ethics wala, sources of ethics. You have been trained over the period of time, and through that process, this has started processing the things. So whenever I am training this transformer, the brain made out of this process transformer, through the language models, what I'm doing, I'm feeding the data, I'm training it with an ample amount of data, बहुत सारा data. ये आया तो ऐसे react करना, ये आया तो ऐसे react करना, this आया तो ये, this will be the combination. If someone is asking this letter prominently, this should be the outcome. So I'm training the transformer. So when you're training a transformer on the language, this is nothing but the large language models. For example, chatbot. Chatbot. What you're doing? For example, maybe in some banks, I have now activated the chatbot, or you might have interacted with the chatbot, right? Yeah, I'm not able to retrieve my password. The chatbot will send you the reply, prompt reply, instant reply. It will see the information whatever is stored, जैसे उसे train किया गया था. It will give you the instant reply. Large language models. Done. Now understand one more phenomena. Whenever these large language models are trained on the multi-modes, first is text. Is my account blocked? There will be a reply. Yeah, why my account is blocked? There will be a reply. Text. Second could be voice. You're recording your voice. Is my account blocked? Voice. So if the large language model is trained on multi-modes, text also, voice also, image also, that is nothing but multi-modal LLMs. अरे यार कंसेप्चुअली समझा रहा हूँ, फैक्ट्स तो कर ही लोगे, आप कंसेप्चुअली समझो, बहुत इंपॉर्टेंट है, ठीक है. मल्टी-मॉडल LLMs that you are training those on multi-modes, text also, voice also, images also. You are training them so that even if you are inserting the image, you are getting a reply. You are sending the voice note, you are getting a reply. ठीक है. चलो, अब let's come to this. See, when your brain functions, and I'm giving a very simple analogy to understand the entire AI, and that is how the entire AI works. When your brain functions, the brain functions in two categories. First is simple reply. You are asking me something, I am replying you. ठीक है. सर आप कब तक छोड़ेंगे? My reply is जब तक है जान. ठीक है. तो जब तक है लाइट. ठीक है. आप कब तक छोड़ेंगे? My reply is जब तक है लाइट या जब तक है जान. So this is nothing but the reply, है ना. The second thing could be, you asked me, sir, tell us something innovative, something, let's say, sir, please draw the image of Donald Trump on the board, है ना. So what I will do, I will use my brain and I will try to draw the image. ठीक है. I will use my brain, I will try to generate the image. ठीक है. Whatever is the image, this is nothing but generative AI. I am generating something, maybe the image. You are giving a prompt, right? Maybe an image. So this is nothing but the generative AI. You are asking me to generate a video, है ना, डोनाल्ड ट्रम्प का डांस करते हुए वीडियो, or maybe something else. So that is nothing but the generative AI. And if you can sense, this may or may not exist in reality. This may or may not exist in reality. So this could be misused. This could be misused. For example, right now people are generating the Aadhaar cards with fake names. People are generating the videos with fake, what I can say, the photos. Deepfakes. So if you are using it for the processing and to generate something new, that is nothing but the generative AI. You can generate the text, you can generate the photo, you can generate the video or anything else. And this is nothing but the entire AI. ये सिक्का किसका है भाई? ले वापस मांगे अब अभी ले. ये मैंने इससे क्वांटम फिजिक्स के दौरान लिया था, मैंने इसको वापस कर दिया है. ठीक है. इंटरेस्ट लेगा इस पे? ज्यादा इकोनॉमिक्स पढ़ा दी इसको. एक दिन का इंटरेस्ट क्या बोलते थे, चल बता दे. जब बैंक एक दिन के इंटरेस्ट पे, लाइक एक दिन के लिए लोन ट्रांसफर करते, तुम लोग बोल लो पहले. हाँ, सुन के बता रहा है पारस. ठीक है. तो दिस इज द एंटायर, व्हाट आई कैन से, द लेयर्स ऑफ एआई. इसमें कंफ्यूज नहीं होना. नाउ एंटायर अदर थिंग्स आर फैक्चुअल. फॉर एग्जांपल IoT. IoT is nothing but Internet of Things. If I'm linking anything to the internet, for example these tube lights, if I'm linking this with the internet, or for example when I'm entering into the room, I'm linking this with the sensors of the internet, this is IoT. When I'm training my machine over these neural networks or with these neural networks to give you the same response, that is nothing but the machine learning. And when I'm doing anything out of these neural networks, be it robotics, be it machine learning, be it anything. That is nothing but the artificial intelligence. See you in the next class. Thank you. अरे हाँ, एक और बात, आप लोगों में से किन किन बच्चों ने अभी त्रिनेत्र नहीं किया है? मास्टर लेक्चर नहीं किया है, त्रिनेत्र मास्टर लेक्चर on this Sunday, coming Sunday, we are having the Trinetra master lecture. Please do not miss it, do not postpone it. It is a very important lecture. Complete है ना? Thank you. Online. I hope you enjoyed the class. ठीक है, कोई फीडबैक है तो दे देना मेरे को. अरे एक और बात, लास्ट बात बहुत इंपॉर्टेंट है. सुनो. जाके जो भी फीडबैक है कमेंट में डाल देना, मैं प्रॉम्प्ट करूंगा. आई विल प्रॉम्प्ट यू, यू हैव टू राइट अ फीडबैक. डाल देना प्लीज, ठीक है? ऑनलाइन यू ऑल्सो. एक और बॉम्ब आया है, सॉरी, एक और इंफॉर्मेशन है फ्रॉम अमृतान सर. यू हैव एक्स्ट्रा क्लास टुमारो. कर लो, वो बजे वो डाल देंगे. ही विल सेंड यू द टाइम. ठीक है, कर लो यार. कहाँ खींचोगे उसे बाद में जाके? खत्म करो अभी. त्रिनेत्र क्या बाबू, क्या?